in this particular target, and how mining engineers and rock excavation engineers particularly, and there is a lot of similarity between IIT ISM and VNIT Nagpur, in the sense that when we started rock excavation engineering somewhere around 80s, and probably taking the clue and the importance, and VNIT Nagpur being a central place next to Dhanbad, the second capital of mining, it's a timely course that they have started in masters, and that's how we see that today it has grown a very big entity now. The master program attracts good number of students, like ISM Dhanbad. And we also, apart from rock excavation engineering, we also thought there would be no necessity to open up into tunneling sector. That's how we started tunneling and underground space technology. So both together they have combined, and now today the conference is pretty apt actually to look into the country's requirements of development of one is ports, another is tunneling. Mining is, of course, is our bread and butter, which we are doing already, and many engineers are into mining sector already. And but then tunneling sector, if you look at only a few institutions like CMRI, Central Institute of Mining and Fuel Research, and NIRM, and CSMRS, some of them, but many of them, are not very much into this tunnel design or cavern design or instrumentation and so on and so forth. Very few organizations are there. So what I wanted to say is mining engineer is basically equipped with handling various other sectors other than only coal mining and metal mining, which is surface or underground. So today we'll just open up this new sector, that is, the talk goes like this: engineering port expansion, integrated approaches to underwater demolition and rock excavation. And in fact, I have a privilege to introduce my scholar, Dr. Suman Kumar Modi, who was with me for the last 6 years, in this particular sector, and who had done his PhD also, probably the only PhD in underwater rock blasting. So he is also a co-author with me. So I thank him for his support. If you look at the India geographically, and if you look at the coastline particularly, you see the states that are colored here. They have the privilege of working in this sector, and they are already doing it. You see many ports are there which are really the ports of economic activity, and waterways is most economic as well as eco-friendly. If you see the carbon footprint we talk about and the net zero targets that we have before us, I would say that this sector, if you can develop in a larger perspective and improve the cargo handling particularly with some hinterland connectivity, and that's a change that we are bringing in today, and the seaports have become functional gateways today, and India has a great opportunity of expanding this. I have 11,000 kilometers approximately. You can see the states that are connected in the picture. And Government of India has really come forward very thickly to support this sector like any other sector. And the name called the Sagar Mala program envisages that it has 800 projects now at different stages of completion, mostly connected to modernization of ports. In terms of, we will discuss how their functionality can be improved. And you can see about 10,000 million metric tons of cargo is supposed to be handled by 2047. That is the target. And it's a huge target, as we can see. And what exactly is conceived out of this is conceived in this is modernization, connectivity, industrialization, coastal community development. That's very important. If you see, if you want to grow India, we have to grow our community also. So it's a huge opportunity to work with our own people of India, and coastal shipping and inland water transport. If you look at, probably this is the sector which we normally use for tourism and moving around and making joy out of it. But then if you look at the kind of development activities that have to happen there, probably this way, when mining started, it was thought that it may displace people and all, but then today it has become a very important supportive economic activity for the people of India. Similarly, this port sector also offers a great opportunity for connecting to community. And the other one that has started recently is the Jalvahaka scheme, is set to boost inland waterways. Now, the ports basically are associated with seas, but we need to have connectivity amongst these across seas also. So the inland waterways also is being now given a lot of emphasis in the budget. And today the total cargo volume, if you see in 2013-14, it was 18 million metric tons. And as I mentioned, slowly we are now inching up towards 100 10,000 million metric tons. So the chart is, the ride which we have to do is very steep. As we are, onboarding onto technology, what we talk about, the AI/ML introduction into various, fields. Similarly, as AI/ML also has invaded us, and then it is basically we are riding on a very steep curve. The port sector also has a very important challenge, which the mining engineers can really take it up. And mining, along with, it's a multidisciplinary kind of activity. So mining, civil, mechanical, IT, and a combination of these, engineerings can be introducing this kind of, approach while, the curriculum is being built. Today, if you see, about 95% by volume and 65% by value of the trade is occurring, through these ports. You can understand the importance of these ports now. At present, India owns 14 major ports and 217 non-major ports. And the challenge is now, when we want to have this huge volume of cargo to be handled as we envisaged by 2047, 10,000 million metric tons. It's no way possible with a very shallow ports. If you see, characteristically, all the ports are 10 to 12 meters deep. But today, if you want to handle this, most of them have become, more or less close to 16. That is 16 meters is the draft. And today we are pushing that to 20 meters because looking into the steep target that we have to handle. Now, when we do that, probably it is not by just soil dredging you will be able to achieve this depth. So therefore, most of the construction companies like dredging companies, construction companies like L&T, Dharti Dredging, you name it, SEM India, there are several companies who are in this business, and they are assiduously working to deep these soft soil, as well as whenever they encounter rock, there is no way that you can excavate by only mechanical methods. So a combination of techniques are being used today. So we'll discuss more on that. So two prominent techniques that are being used today are mechanical excavation and drilling and blasting. So we'll more channelize our talk onto drilling and blasting, though mechanical excavation is also being used in a big way. So I'll not go into too much of details into this. So you can see, as I mentioned already, the port development, there are certain key aspects which you can see. Infrastructure expansion and modernization is one, where basically you are deepening and widening. These are two important aspects that you have to do. When you are widening, obviously the old berths have to give away. If you see most of the old ports, like Visakhapatnam or Chennai, Paradeep, Jawaharlal Nehru, there are several such ports which are basically already operating, which are having, a very narrow channels and lower depths. So the channel has to be deepened as well as widened. So when you widen, obviously the old berths have to give away. So some of them are very old and they're under capacity. They cannot handle, large cargo loads. Therefore, these demolitions also have to happen. So that means it is not only deepening, widening, it is also demolition of those existing concrete berths which are there of different strengths, different times. So which you require to demolish. So that's another area, demolition of the old berths, concrete berths. Obviously, as I said, capacity boost is what we are looking at. Now, recently, you must know the Greenfield project, Vadhavan port is, a very important port now, going to handle closely in one single port 300 million metric tons. You can understand the total target. So the kind of smart digitization and smart technology is now invading into ports also to connect using various port community systems and IoT sensors, including drones also, because it's a large area, like a mine. It's a large area, you need to have controls. So the usual geospatial technologies could be engaged there. A lot of hydrographic surveying that you have to do in a quicker manner. Real-time kinematics have to be put into place. And then not only the ports, side, the sea side, you have to connect the hinterland connectivity also that need to happen. So that also requires many rivers that are connecting these, seas have to be deepened also and widened also. And there are several challenges there also. Thereby you are basically connecting to various rivers also. And then environmental sustainability, where you know that, the green footprint, wherever you talk about today, we would like to reduce. So obviously the same kind of, use of renewable energy and even reducing GST on bunker fuels to 5% is one. And green channel clearances also are being, developed now. And there are some ports like Mangaluru and all, which are being, considered as a strategic hub developers, basically. So they are going to work as a hub for all these activities. One index I would like to, we talk about many indices like RMR, Q, and many indices in geomechanics and for that matter in many places. One index I would like to bring to you, this is Logistics Performance Index, which is an interactive benchmarking tool developed by World Bank to measure the efficiency of trade logistics across different countries. It helps nations identify challenges and opportunities in their supply chains and provides a global benchmark for logistics industry. So here we consider these parameters like customs, clearances and infrastructure, availability, international shipments, how many you are handling, logistic competence, tracking and tracing, and timeliness. If you combine all this, this LPI is formulated, and if you look at the comparison, just a quick comparison of how the situation was in 2014-15, that is about say 10 years ago, and today where we are. As I mentioned, most of the ports earlier was 10 meter deep. Today we are now, most of them are getting into minus 16 or 16 and moving towards 20. And cargo handling has phenomenally increased, and it's going to increase, as I mentioned, by 2047, 10,000 million metric tons. You can see it's doubled now in the last 10 years. Logistics Performance Index also has come down. That's a lower index, better it is, so 54 to 38. And future expansion plan, I mentioned already, we have a very stiff target, like we have coal targets and the emission targets and all. So the cargo targets are also pretty high. One good thing is the turnaround time also for the ships, has come down by a half almost. And container dwell time, you have containers being used, handled. So that also has come down to 3 days. Earlier it used to be much higher. And Harit Sagar guidelines, basically the carbon footprint also, Harit Sagar, you can see, we also now care for the environment. It has already, come down, going to come down by 70%. Today it is at about 30% by 2030, the reduction in carbon footprint in port handling activities. And solar power integration also for green hydrogen hubs and PM Gati Shakti. These three are also being integrated into the port sector. So you can understand the kind of multidisciplinarity that is existing in port sector development today. Now coming back to the technology part, actually how we are doing this deepening and widening, wherever there is criticality and the production requirement is not very high and you will be able to meet your timelines quickly, so probably mechanical methods of demolition are most common. In the sketch you can see in the slide, underwater rock breakers are very common. Then some chisels are there, you can see these are the underwater rock breaker of AP Rock. It's a very established one, just to name one. There are different companies that produce chisels that break. Actually, civil engineers are pretty familiar with these, chiseling activities and all, because a lot of beds are being demolished for various purposes or pavement breakers and all. Hydraulic crushers, very simple one, but these are all, low capacity, and the drum cutters also have a capacity of not more than 10 cubic meter per hour. That too is a very high value, I am telling you. And typically the peak consumption or the peak wear and tear is very high. Therefore, not for very high volumes we prefer these kind of techniques. And we have used, this diamond wire cutting which we use in normally marble and granite cutting for, improved recovery and reduced damage to the rock mass and better, economics. So this also as a technique we have used in one of the ports where, the adjacent berth was to be protected because it's a contiguous berth of say kilometers. So a part of it you want to demolish, a part of it you want to retain as it is without causing any damage. So therefore we were trying to use these kind of techniques where the damage cannot be extended beyond even half a meter. So though there were techniques like line drilling and all which we'll discuss, but mechanical is the most sought out method because of non-damaging kind of nature. And even you can also think of using abrasive water jet cutting, but this is a low capacity as I mentioned, at a lab scale or a very nominal scale we can use it, or for profiling and all those things. But this can be used. The diamond wire technology probably can be used. Okay. And as I mentioned, the mechanical cutting is one part. So when we are trying to cut the material, you need to dredge it out also. So you need to have a dredger. So there are several dredgers. Probably this area we don't talk about because we mostly confine ourselves to mining and related, evacuation systems, either conveyor belts or haul trucks and all. But here we talk about, a combination of equipment which I will show you. A dredger here, what you see is a trailing suction hopper dredger. This again a kind of, learning that I had to do almost 10 years ago. that what kind of dredges are being used for soil dredging and compact soil dredging, or even slightly, moderately hard rock and finally hard rock. So when it comes to hard rock transition, we normally look into the drilling blasting alternatives, but generally, given a choice, these are the most commonly used dredging machines for soft soil, which we call as TSHD, that is trailing suction hopper dredger. Another is cutter suction dredger, where there is a cutting drum. You can see a rotating axial cutting head like a rotator, a Dosco type rotator in coal mines, which we try to cut and then convey through a suction. So these are all basically the standard methods, and you have a pipeline to transport that. I'll not go into details of more of dredgers and all, but this is one area where the mechanical and mining engineers can think of, developing what kind of dredgers, what capacities, and the entire logistics planning we can do. This is all floating vessels, which will directly convey, and there are other, dumping barges also where we try to dump there. So, which will come, hand in hand with drilling and blasting. So, apart from mechanical cutting, as I said, underwater drilling and controlled blasting has become one of the most important method today to help port sector to complete this deepening and widening operations. What you are seeing is a typical drilling barge. I think most of you who are connected with civil engineering, port expansion related works, construction companies sitting here, I think they are all pretty aware of all these things. But then I wanted that this area also should be touched upon for the benefit of mining engineers who are basically working here and then trying to expand their wings. Apart from other civil engineers present here, so you can see these are several such drill machines, one after the other. The number depends on like what is the production target, etc. And the distance also, we design a blast system where a drilling, drill dia, and then the burden and spacing as we design in our normal blasting operations. Here we need to understand the confinement of water actually, say depending on the depth of the water. So there's a formula that we normally use that the confinement has a negative effect on the performance of explosive. So the specific charge kg per cubic meter that we utilize has to go up actually, considering the depth of the water table and the sediment that we have to handle and the fragmentation that you are looking at. So keeping those things in view, we decide the dia, we decide the spacing, and then the burden. So these three are two important things, and accordingly the drill dia and the spacing, once it is fixed, the drill rigs are mounted there on the drill barge, and these drill barges have compressors, independent compressors or shared compressors. You can see back of it, and then there is, it's an entire thing is floating, and you have spuds also to stabilize it. There are 2-3 varieties of spuds that are available, so which we can use them, or you can have a anchoring also, rope anchoring also if it is nearer to the shore. So this is the drilling barge. So the tools and components I am talking about. If you see explosives, just one second. So we have actually, in underwater, the water pressure has certain negative impact, as I mentioned. The performance of explosives have to be commensurating with this water confinement pressure. So they are normally, they can withstand up to 50-meter water cover. And these are slightly different explosives that we use compared to normal shaft sinking or general bench blasting or tunneling and all. So these are specifically made up explosives, emulsion type explosives mostly. And nonal is the most common initiator, though earlier electrical detonators were being used, but today we completely stopped them. Like the mines also we stopped, considering all the safety issues and all, and the true bottom hole initiation that we can achieve. So there are various delays that we can have as per our design, in hole delay as well as hole to hole delay. And typical blast pattern, these are not very complex compared to any dragline bench blast or any shovel dumper bench blast and all. So, or tunnel blast, which is 100 holes and all. So these are very pretty simple ones. Only thing that we need to see is there should not be any flashover from one hole to other hole. So minimum distance of 2 meters is normally recommended. So that's how we normally design our dia also accordingly, on explosive also accordingly. But then when it has to be very close to a particular berth structure and all, maybe we have to reduce it to 75 millimeter hole dia, and accordingly the explosive dia also will reduce, which we are doing for demolition particularly. So these are typical patterns. Now for the people who are not very familiar with underwater kind of blasting in ports, These are some of the challenges. You can see the ports, we have operational ports. The cargo is coming and going, and tugs are coming and going. There are several challenges. So generally the harbor master or the main person, the marine department will not allow you to do any kind of blasting or even charging also. Only drilling maximum you will be allowed, provided there is a safe stand-off distance. So that's a challenge. So there is generally we expect a window time given. Sometimes it's not possible, and only in an operational port you have to conduct blasting while a ship is going that side, maybe at a distance of 75-80 meters you have to conduct a blast. So we have conducted a similar kind of studies in Visakhapatnam port, even in Chennai port also. So hydrodynamic conditions, we need to understand the swell also. That's a challenge because the stability of the barge, as you have mentioned, everything is floating on water. So all barges, because the entire fleet is on water. So if the swell is more, your operational efficiency comes down. So this is not a challenge normally. Like we deal with nature, where we classify the rock and try to understand whether it is going to give up or it's going to give us an adequate stand-up time before we finish our operation. Similar is the challenge here, that the swell, how much swell will be there. Unfortunately, we have meteorological predictions that can help us to understand the swells and all and plan accordingly. So these are some of the constraints in which you have to understand, and geology of the seabed. So generally we go for profiling as well as geophysical surveys, conduct the kind of exploration survey with regards to core recovery and RQD, etc., and try to understand the competence of the rock. Accordingly we design our specific charges and burden spacings, etc. And most importantly, the location. When we are trying to locate a particular hole, because of the swell, because of the location, because of the integrity of the entire barge, there is always a chance of this 2 meter distance is pretty low. There is every chance that half a meter this side, half a meter, if there is no proper anchoring and no proper spudding and all. So it's a huge challenge, that how do we locate the hole and properly drill at the same location where you planned. If it is only demolition, then you can have some control. But if it is underwater rock blasting in the mid of certain channel, it's really a challenging where you are putting your hole, whether it is properly as per your design or not. And then navigational influences also. These are some of the challenges that we need to understand for planning. And as I mentioned, this sketch actually helps you that where a ship is there on the left side on the berth, on the right side you have a new structure which is to be protected, where a seismograph is placed. A water surface keeps going down, up and down, and you see there is a profile, existing seabed, and then you need to basically lower it down by 2 meters, 3 meters, 4 meters, whatever. Normally you do it based on the maximum charge per delay that you can blast, considering those structures that are nearby. So two things we need to talk about. One is the structural vibration in the marine structures, and the other is water shock actually. So water shock also has adequate impact if you do not monitor. So we made it a practice now. Probably for the first time, I can say that in IIT ISM we have started this almost about 10 years ago using hydrophones. I don't think at many places this water shock is being measured while blasting in underwater, I am saying. So this is the kind of constrained environment you need to work. The rest of the things like the hydrophone and its function, geophone and all, you understand. We try to paste them properly and try to understand these two important values. Now here when you want to really go deeper, whether it's a very high berth with a wall outside, so masonry walls or concrete walls and all, you want to do normally in a single kind of hole. Sometimes it is not possible, so you go for decking. So what I am trying to show here is decking, which we do in mining. Optimum delays that we need to do, because overlapping of delays sometimes is a problem when you have a structure nearby. In fact, we have a Navy building nearby. There used to be a regular complaints coming up from Navy side. So we had to put sensors on top of the building, at the ground level of the building, and even at the berth also, very close to the this one here, that side, seismograph where it is there. So that's the nearest one where the blasting is happening. But beyond this, about 50 to 100 meters, we have several structures. So there were complaints. So we keep addressing them by putting various instruments. Just 1 minute. You can see this is line drilling.
Sorry. This is the bubble curtain which we are using. And we are also using some acoustic signals, acoustic devices for measuring the water sound levels, etc. This is the RQD values. You can see the core recovery is very low, but then still they can project you a lot of hardness. You can see the core recovery values of this. We classified them into different kind of categories, and we try to design our specific charges at those locations based on core recovery values. This is also, we divide the entire thing into different zones as per the RQD and all, and the depth available. Accordingly, we design. This is just a depth and blasting zone profiles. This is the usual pattern that we do. How do we design a blast? Probably this is just for the academic purpose. Two things are important. I will say that linear charge concentration, and the third one divided by specific charge. What you get is a breakage area, and then you accordingly design your spacing to burden ratio. Assuming square pattern, so say 2.5 by 2.5. So burden and spacing, typically you see 6.25. So this is a simple calculation. So therefore, we normally use, so what is the explosive that is available in terms of kg per meter, and then what is the specific charge, as I mentioned, depending on the dredger I am going to use, I am going to select the specific charge. So available explosive in linear charge concentration divided by the specific charge, you get meter square area, which that particular column of explosive can command. So accordingly we design, and when we calculate the stemming and all the other things, and finally we come out with the entire design process. Now it's like any mining cycle. We have a very important cycle here, getting to know the coordinates and positioning the barge and trying to lower the casing. Now today we have casing and without casing methods also, depending on the requirement. Sometimes when it's deeper and there is a chance of something, the hole getting collapsed, we normally go for casing. Otherwise today we are doing without casing also, depending on the rock nature. So when there is a loose rock, then there is a chance of rock falling into the hole. Therefore we normally go for casing. And then all this lowering of casing and lifting during wire pulling and all, and finally connecting these things takes a time. You can see the typical cycle time could be fastened also depending on the number of rows and drilling machines, their drilling rates, etc. But typically about say 540 minutes. So you can understand say about 9 hours. So typically in a day 2 cycles you can blast, and you can go ahead with your blasting. Of course, this can be improved upon. I just want to give you a typical cycle. What you are seeing here is in a port very busy, where drilling, we have already discussed that, charge preparation, manual charging, of course we are doing here, shock tube connection, and then connecting them into a proper kind of banding them in different rows and blasting. You can see the blasting happening here. You can see there is a LPG container ship actually there, and you have a excavator barge and a dumping barge, and blasting has happened here. Now it's loading basically the broken material. You can see the distance is hardly some say 150 meters or so. It's a oil container berth. Unloading the oil, unloading is happening into a underground cavern actually. This is a case of Visakhapatnam I am just showing you, just to give you an idea like how the entire scenario looks like. Drilling of course is a very cumbersome process, lot of wetting happens, so you need to have some proper personal protective equipment, etc. And you can see this was electrical wiring, basically electrical that time was being used. I just wanted to give you initially from electrical to non-electrical we have moved now. When it is electrical, you need to have the additional responsibility of checking their connectivities and continuity, etc. So then you can see all the wires being, you need to have a divers, to help you to locate the charges, to see whether the blasting happened properly or not, and pulling the wires, connecting them properly. It's a very cumbersome. And then finally, the vibration monitoring the nearest location which you want to, the berth that you want to protect. And post blasting, you can see the loading happening like in a dumper. So looking into the kind of fragmentation, you can change your patterns. Of course, here I will not. This is a specific case where on the top, what you are seeing is basically it's a concrete berth, outer wall actually, which we need to blast. So that side you want to protect. You see there is a blue ones. The blue ones are the basically the line drilling holes, which we wanted to put there, so that when we blast this 1, 2, 3, 4, 5, 6, nothing should happen there. So we made some calculations, and the strains produced due to the charges and the charge quantities have been fixed up, delays have been properly done, and finally we executed not only that side delay, and you can see the decking also that has happened. So this is a very specific case of a port actually where we wanted to protect a berth. And again, underwater also, this is a demolition one, and this is underwater also, similar kind of decking we are doing. And wherever we have done, you can see because of the technique like bubble curtain has helped us to reduce the vibrations. Even there also, a combined technique of line drilling and pre-splitting also helped to reduce the vibrations. So that the engineers can be assured of confidence. So obviously, when you look at the takeaways, detailed understanding of rock, soil, dredger, as well as explosive rock interaction is required, as I mentioned, and integration of field measurements, laboratory testing, and numerical simulations will play a key role. This is another area, that numerical simulation using various softwares to understand the impacts and the damages, including advancing dredging technology. So when we talk about mining technology, dredging also now I'm taking into the mining foray. Considering the underwater challenges, rock excavation systems, namely mechanical, drilling and blasting methods, require sustainable and environmental friendly acceptable solutions. And obviously a good collaboration between industry and manufacturers, could be equipment or could be explosive manufacturers, will help us to engineer a solution that will really help us to meet our targets. So I was just proposing that these are some of the research areas probably our young budding engineers who are doing research can think of. And also some curriculums, academic curriculums we can introduce with regards to underwater blasting as a whole for the port sector, so that we can finally make this sector more thriving and meet the Viksit Bharat targets of India. Thank you.
Thank you very much, Professor Murthy. Very interesting and
if you permit
lecture,
one,
and also a relatively new area. So.
One small video I just wanted to show you,
Okay, sir.
but just I'll take one minute only.
Okay, sir.
Just 1 minute. इसमें अंदर कैसे जाएंगे? Okay. करके here. Okay. Just 1 second. This one? D? Okay. This one now? Yeah. Just 1 second. I just wanted to show you one small video. Just 2 minutes. You can just, you get a feel actually when you see the things. You can see kind of drilling that's happening. So this is just to show you, those who have not seen, just to give you an idea. Then you can see charging. So you can see the long column, what they are bringing, this is a prefabricated charge, put in a PVC and being lowered into the hole. You can see the length of the charge straight away, and the decking and all is done already. It's done and kept it ready in the store so that it becomes faster. This is a recent one. You can see the ship standing there, and all the blasting happens now at a distance of about 150 meters or so. So you can understand very carefully they are lowering that with a wire. And these are all primed already. It's primed, ready, decked. Only the diver has to go and ensure that it is sitting and it is entirely embedded into the hole with a clear gap of some, say, like kind of, stemming height of half a meter at least. So that, though the water column acts as a stemming, but this is also a good challenge that the divers have to ensure, and divers have to be a part of the entire system. And lastly, I'll just show you this one so that this gives you a final kick actually. This is a very a berth that actually mechanically demolished. Now we are going by drilling and blasting. I'll just forward it. Oh, just 1 second. Yeah, here. In fact, we were trying to do some studies, using numerical modeling, the kind of plume heights and the energy release, and underwater testing. For explosive energy estimation, we use underwater tests only. So this could be one good precursor, for some kind of energy estimation studies and explosive performance evaluation also. So thank you very much.
Thank you, Professor Murthy. A very good lecture. Yeah, please, sir. So I would like to now invite Dr. Sripad Nayak. He is Acting Director of National Institute of Rock Mechanics. His lecture will be Applications of 3D Modeling in Metal Mines, a Critical Appraisal, my very own field of working. So my dear colleague, Dr. Nayak, shall be presenting his keynote lecture. Actually, time has overrun a lot, so please make it as brief as possible. And maybe some 15, 20 minutes.
Yeah, sure.
Thank you. We are already running short of time. We can interact during tea break. Sorry.
Very good morning to all the participants and respected Chair Dr. John, respected Co-Chair Dr. Pankaj, and all the eminent mining engineers and civil engineers. So this is a conference where I see a combination of mining and civil engineers that used to be absent long back, like any conferences, mining conferences, it never used to be so many civil engineers also participating in such conferences. So, today's my topic is like applications of 3D numerical modeling in metal mines, a critical appraisal. So I'm very happy to share the space with Professor Murthy, who has been a constant inspiration and support for NIRM over the years. And Dr. John himself is a stalwart in numerical modeling, particularly in mining applications. Yeah. If you see, numerical modeling and understanding of rock mechanics is a key for any numerical modeling you take up. Here, understanding of the rock is very, very important. Then application of the mechanics comes. But the first part itself, most of us fail. We fail to understand the rock properly. As you see, traditionally rock mechanics was about preventing the collapse. Okay, earlier rock mechanics, the numerical modeling applications, we used to concentrate more on making the excavation stable. But now it is towards sustainable mining. So every ore that is present in the earth, that is important. We cannot afford to leave, because if you leave it like that, it may be lost forever. So our future generation will blame us. So the application of numerical modeling will certainly help us in achieving this goal. For example, I will just give you an example of optimized pillar extraction with backfill means the less ore locked in pillars. Recovering 10,000 tons of, just imagine, just leaving 10,000 tons from pillars underground. So if you are able to extract with, with backfilling and other means, so it will avoid a lot of carbon footprints. So you can avoid opening of the new stoves, reducing ventilation energy, haulage design, diesel, and development blasting. All these things you can avoid. And at the same time, we are leaving a lot of subsidence footprint, like advanced 3D modeling, we can prevent surface subsidence, protection of the infrastructure, and a community as a whole. So the key components of social license to operate. So if you are able to achieve this one or optimize the resources using 3D numerical modeling, so that will be a big contribution in conservation of the mineral. So why rock mechanics is special? So see, if you are analyzing a steel structure, you all know that you know each and every property of the steel, or to that matter even concrete structures we can analyze with a lot of ease. But when it comes to rock, we have so many complexities. As you can see here, see, the rock is, it is not homogeneous, it's heterogeneous, okay? So there are combinations of many types of the rock variants that you come across, and it is discontinuities. It is not like there are faults, there are joint planes that influence the behavior of the rock. And then most importantly, it is anisotropic, because the strength is not uniform in one particular direction. Yeah, with a simple concept, I would like to, it is not possible to go into the each and every detail of the rock mechanics, this one. So here, because the whole 3D numerical modeling as a whole, it revolves under understanding the strength of the rock under a particular stress condition. Okay, so the first thing is we have to measure the stress. Okay, that many of us, particularly in the mining industry, it is the last priority. So we don't measure the stress, and we make too many assumptions. And next one is understanding the strength of the rock. Okay, so because see, whatever excavation you make, so it will be stable if it is made within that particular, if it is able to hold that particular strength, then it will be stable. If it is not, then you can increase the strength of the rock by means of say any reinforcement or other means. So it is total numerical modeling revolves under like understanding the stresses and the strength of the rock. So here, if you see a simple excavation here, so this is a case where your vertical stresses are more than your horizontal stress. That results in the de-stressing in the crown and the stress concentration on the sides. So whereas if your horizontal stresses are more, then you will end up having the stress concentration in your crown and the de-stressing in the sides. But one thing you have to understand here, both these conditions are undesirable. Okay, both have its own implications. Yeah, just to give an idea about, don't know, it is not playing. Yeah, I'll just play here. Yeah. Just to give a simple concept, we have just created a small tunnel. So just how the intersection of the tunnels, so how it is affecting the performance of the tunnel. I think I have to play in this mode only, otherwise it won't play, I think. Yeah. So just to give a simple concept of formation of the wedges with intersecting joints and how it is going to affect the performance of your tunnel. So as you can see here, these intersections, because of the intersection of joints, there is a wedge that is getting formed here. Okay, so if it is not supported on time, then see, this is going to create a wedge is going to fall into your tunnel. So this is a very concept, just to give you an example of how the simple understanding of the joint orientation in your whatever excavation it may it be a tunnel or a mining excavation or a stope or whatever it may be. So, and then if you are supporting with the shotcrete or the rock bolts, so you can stabilize those excavations. Yeah, I'll just yeah, now coming back to the topic. So historically, rock mechanics relied on simplifying 3D problems into 2D plane stress strain analysis, often using questionable assumption. I remember about 30 years back, we were using like a software like Besol, Befe. They were all very preliminary softwares based on 2D assumptions. So now, but over the years, a lot of developments have taken place, and computational power has expanded, and it is affordable also. So that has led to the developments of very high-end like finite element method, finite difference method became the industry standard for non-linear behavior and large strain deformation that are required for cave mining and other complicated issues. So just to give you an overview of what are the numerical methods that are available today for a practicing mining engineer or a civil engineer. See, you have all these things you are aware of. This one, I just would like to give you an overview of that. So you have finite element method, you have finite difference method, and then boundary element method, discrete element method, and combination of all these things. See, the primary use of say finite element method, it is best for complex geometries, okay, and non-linear material behavior and groundwater interaction. But FDM, if you are dealing with a large strain problems and dynamic analysis, the FDMs are the best ones. And then you have boundary element method that are particularly useful if you are, it is like only elastic analysis if you want to do, and it is not heavy on the resources. It is very easy, you can easily do this boundary element analysis. And for complex jointed rock masses and this one you can use the discrete element methods where the software like 3DEC and PFC 3D, all these things come into play. And there are other softwares that are this one. And here choosing the correct discretization method or the method itself, it plays a lot of important role. Like the continuum methods software, like see these are all these softwares are becoming popular, particularly RS3 FEM software, but their utility, you have to carefully examine their utility into the problems, particularly the complex problems of the metal mines. This one we have to be very, very careful. Then you have Flag 3D. They are very robust for modeling complex and anisotropic rock masses. However, they often struggle to capture large scale block separation and discrete joint movements. In such cases, you have to go for discontinuum models like 3DEC and PFC to some extent also. They are superior for assessing the stability dictated by the structural features. Because you have to understand one thing also, there are two types of failures. One is structurally controlled failures that is very predominant at shallow depths, and the stress control failure, they are more at the great depths. And then you have boundary element software like EX3 that offers speed and simplicity for large scale mining footprints. You can certainly use EX3 just to get an initial assessment of the distribution of the stresses based on your mining layouts. And then mathematical formulations also, what constitute model you are using for your 3D model. That is also very important because traditionally we have been using more column and then hook and brown, generalized hook and brown and all these things. And now more and more advanced models like Itasca model for advanced strain softening models, they are coming up because uh, uh, you have to understand rock still has, even after failure also, there is still some strength retained in the rock mass. So that strength, how to utilize that strength, that you will understand only if you do a post failure testing on the rock samples and try to understand the post failure behavior. So that is possible only if you adopt strain softening models and other advanced models. So just to give you a methodological framework for 3D modeling, it is just a general framework. First phase is data and characterization. This is a very important step. This is the foundation for your 3D models. So here the first one is construction of your geological models. Because it's a very, particularly in metal mines, it is a very complex geological models because you will not find like in coal mining a uniform layer of your this one. So ore body will be going in whatever direction. So it is very difficult to model geological models. And then just to get the impression of your strength, then you need lab testing, then the parameter estimation, whether it is hook and brown or more column, whatever parameter estimation is also very important step. And then in situ stress, because this is the foundation for your the 3D model, because if it goes wrong, the in situ stress goes wrong, then the entire results that will change. So it is better to get your in situ stress measured for your any particular site. It is very important here. That is the most ignored part in our mining industry. And then validation of this data, whatever data you are using in your model, that needs to be validated. And then next stage is model construction and staging, mine geometry, and then boundary placement, mesh refinement. That most of you practicing engineers will be aware of all these things. Then comes the excavation sequences, and then if you are going for a backfilling, then the backfill activation and all this this one. And then phase 3 is output and performance evaluation. See, there are various parameters like you can evaluate the stress strength ratio, that is nothing but a factor of safety. And then the yielding zones, displacements, and then the subsidence, and then you can also see the loads that are getting introduced in your support elements. All these things can be analyzed once you get the outputs. And let me just come to the practical applications in metal mining. There are various applications that you can think of. So some of the applications that we have utilized is for pillar optimization, assessing the stability of the ribs, crown pillars and sill pillars to so that you can minimize the locked up ore. And another this one is sequence design, because see, if you can plan your the stopes according to your the in situ stresses, then the sequence can be optimized, so that you will be able to do once you have a proper 3D model in place. So determining the optimum direction of mining to manage the stress concentration at critical locations in the ore body, that is also very important. And then you can do a support evaluation, quantifying the performance of rock bolts and shotcrete, so that you can optimize the support requirement. And then environmental mitigation. So you can you can predict the surface subsidence, and you can design if you are important structures on the surface, then accordingly you can change the dimensions of your stopes or whatever this one you can optimize that. And then one more important one is the slope stability analysis, that one this one. And then briefly I will, because of shortage of time, I will not go into details of some of this one that is already given in the paper. So some of the applications, so this is an application for Hatti gold mine optimization of mining parameters here. As you can see here, the sequencing of the stopes, so you can study the sequencing of the stopes so that you can study the barrier pillars stability, the main rib pillar stability, and all these things can be optimized. And same thing you can go ahead with the paste fill and or the rock fill this one, and you can study these things. Similarly, the extraction sequence, see this one, how the displacements are getting concentrated on your hang wall and foot wall, all these things also you can study and optimize your pillar layouts. And this also pillar stability, and particularly the cap rock stability, that is also one very important parameters that you can optimize using some of these numerical models. And one more challenge what we are facing nowadays is, because you have a huge open cast mine on the surface, and you will be going for as you go deeper, the only alternative left is to go for underground mining. In such cases, it is imperative to have a comprehensive 3D numerical modeling because the influence of the excavations of the open cast also will be there on the thing. So, so all these things can be optimized if you develop a proper 3D numerical modeling. Here, I would like to just demonstrate one thing. See, if the your stopes are not oriented along your in situ stress directions, then there can you can have a lot of displacements that are in the hanging walls getting this one. So same thing if you orient it along the stopes, so that can be minimized. Similar is the case with the shear stress concentration and other things also. So just by changing the stope directions, you can minimize, see, a lot of anticipated stress control, the strata control problems can be minimized just by going for the change in orientation of, so for that reason only understanding the in situ stress is very, very important. So measuring the magnitude and direction of in situ stresses is very crucial if you want to understand, like optimize your layouts. So these are some of the, see, once you change the orientation of these stopes, those stress concentration just they vanish, this one. So some of the results from this one, see, the hang wall shows high displacement due to redistribution of in situ stresses around the ore. But so these were the results from the actual orientation. Same thing is improved, like once you reorient your stopes, then the maximum shear stress around the oriented stope significantly is lower in than in the non-oriented stopes, and it reduces the likelihood of shear failure in the hang wall or backfill. Displacements are also markedly decreased. So all these benefits are there, the output of 3D numerical model. See, and see, we did some study on, see, some of the pillars are left, already left, but still there is a scope for going for extraction of the pillars that are left underground. So that study also we can see, and with backfilling, paste filling and other techniques, how you can extract those pillars also and maximize the ore recovery. Yeah, yeah, yeah. And some of the this slope stability for a underground, open cast mines also. So you can model the entire mine and introduce like we adopted a 3-deck model here, so that some of the very critical joints could be incorporated into these mines, and you can see the for the entire mine you can do a slope stability analysis, particularly for open cast mines. So these are some of the results. And then just the robust modeling framework that is needed for metal mines. So you have to start, you have to go in a tiered approach. Like start with a simplified 3D continuum model for global stress distribution, refine into high resolution local models for critical zones, and then use empirical tools for cross checking. Then here most important thing in numerical modeling is validation of the model. Otherwise, it will be just like you will be having a beautiful set of pictures and in the reports. If they are not validated, it's of no use. So it is a mandatory requirement is you have to go for the validation of the model with your instrumentation data. Some of the instruments like MPBX, stress meter, convergence station, they are mandatory if you are going for a 3D numerical modeling. And you have to validate against actual performance and this one. But we have critical challenges and limitations because data quality is very, very important. Reliability of 3D model is entirely dependent on the quality of the input data and rigor of calibration against field observation. And sometimes you get what is known as illusion of validity. You think that the model is validated, but actually it is not. So, and all this, there are some calibration constraints also because the quality of the instrumentation data that we get, it may not be very good. So, all this, this one. And just to give you a future direction for enhanced prediction, so we have to go for improved site-specific data, particularly the stress measurements and displacement monitoring, and we can go for advanced microseismic monitoring. So that will give you more input data for your model, and we can go for hybrid continuum and discontinuum approaches, and advanced backfill models are also under development. So all these things can enhance the quality of your this one. And just coming to the conclusion part here. So now 3D modeling is a necessity. It is not an optional exercise anymore because 2D models often underpredict deformation in non-homogeneous rock masses. And as far as possible, we have to adopt advanced constitutive laws so that represent the actual rock mass behavior. So we have to go for some strain softening models so that we try to utilize the inherent strength of the rock mass to the extent possible. And the calibration is also paramount. Model must dynamically calibrated using microseismic and stress measurement data. And embrace technological convergence. So we can use so the AI and high precision geomatics to create a living digital twins for proactive risk management. Risk management is also very, very important. So we can use all this to make 3D modeling because there is still in Indian mining context, it is not a very well accepted tool. So we have, if we have to make it acceptable, then the validation of the model is very, very crucial. Okay. So with this, I close my this one. Thank you. Thank you very much.
Thank you, Dr. Shripad Naik, for a very informative lecture. But we are already running short of time. So we have about 6 lectures following. So I would like to call one by one. We have very limited time, only 6 minutes per lecture will be possible because already we have passed almost 10:45. So I would like to call Anand Sharma for his first lecture. Yeah, please you can come forward, all the presenters. Mr. Ayan Ahmed, you can sit in front here. And Mr. Pankaj, Dr. Pankaj, sorry, Mr. Romil Mishra. And Ms. Varalakshmi, please come. And Mr. Suman Modi, Dr. Avinash Paul. So please, Anand Sharma ji, please I invite him to deliver his lecture. And please make it short, very brief, and then to the point. His topic is reserve estimation for high wall mining under complex geology using Minex software and approach. Please, go ahead.
So, okay, sir. Okay. So, good morning, respected chairman, distinguished faculty members and delegates. and dear friends and colleagues. Myself, Dr. Anand Sharma, Senior Technical Officer from CSR Simfer. Today, I am going to present our work titled Reserve Estimation for High Wall Mining under Complex Geology using MINEX and Approach. So, as we all know that India has vast coal resources, that is nearly 378 billion ton, and in future coal will play continue vital role for the energy security. Currently, open cast mining contributing nearly 97% of total production, whereas from the production from the underground mining are constantly declining. As open cast mines approaches their ultimate depth limit, significant coal remains locked beneath high wall as well as pit boundary and geologically disturbed zones. So, accurate reserve estimation is essential under the challenging geological condition, underground old workings, and irregular seam condition. So, high wall mining offers a viable solution for recover such resource without further surface expansion, and MINEX software will play a precise role for calculating the reserve estimation. So, objective of our research are to design a MINEX-based framework for precise reserve estimation and high wall mining zone identification. Second one, integrate goof affected area, present working pit profile, and optimize drivage direction using sectional analysis. And finally, to quantify mineable reserves with validation. So, in this study, we have considered the case study of NEC Tirap mine, which was started in the year 1983. So, this figure represents the location of that particular mine. So, initially mine was started by the method of underground Baska method. Further, later it was converted to open cast mine, and it has a quality of G1 grade, that is GCV value more than 7,000 kilocalorie per kg. And it contains majorly 3 seams, which first one is 8 feet, 20 feet and 60 feet. It contains various faults and folds, and total 60 boreholes were drilled in the lease area. So, for reserve estimation, we have used MINEX software. For MINEX software, we have prepared an input database for such as lithology, assay value, and color data. All these things were prepared by using the geological report, which was submitted, given by the Coal India Limited. Further, from the contour map, contour plan, we have converted, made a DTM model. And from the module of faulting and refaulting, we have created a seam profile, which is shown in that figure. Further, we have also identified the goof edge areas, which was already done the mining by underground mining method. So, first we have identified the area for the high wall mining. So, based on the applicability condition of high wall mining as well as underground old working, we have identified the high wall mining area, which is indicated here in pink color. So, total 0.41 kilometer square area were identified for high wall mining. And for reserve estimation, we have used multi-directional section method for the evaluation of reserve. So, from this method, we have found that in the identified high wall area, the reserve for 8 feet and 20 feet were found fully extracted. Only 60 feet seam was mineable. And finally, we have found 2.74 million ton for that particular seam. So figures represent the sections as well as different areas which was cut into sections. So from this study, we have found that 0.41 kilometer square high wall mining zone identified using the based on the Minex model. 24.25 million ton we have found the geological reserve, whereas 2.74 million ton we have found mineable reserve. And this methodology indicates future, it is a good, shows a good path for the identification of old working gopes which was already carried out by underground mining, and it was provide supplementary recovery without deeper open cast expansion. So this is all about my today's presentation. Thank you for your patience.
Thank you very much. You finished it in time. So any question, one question maybe we can have. Any questions? Yeah, please. Yeah, both the
Hello.
High wall mining means just we are using the high wall miners. Do you think for that?
No, sir. Actually, in this case study, earlier it was carried out by underground mining method. Then they have converted that particular mine into open cast mining method, sir. Then further, they have decided that the coal which is still there for the mining.
No,
they
high
can-
wall mining method means what? By which method? High wall miner are already in operation in India.
Yes, sir, it is
Yeah,
high wall miner.
miner. Yes, sir.
High wall miner only. It's a continuous miner. I think you know it goes cuts, makes cuts inside that remotely. That's what is unable to understand your question. That's why I'm
Oh,
explaining.
I see. Okay.
Thank you, sir. I would like to invite the second lecture, prediction of surface subsidence and strain over inclined seam using influence function method. And this is will be presented by Ayan Ahmed. Please come. Make it very brief, 5 minutes.
So, good morning everyone. My name is Ayan Ahmed. I am a 5th year undergraduate student of the Department of Mining Engineering, enrolled in its dual degree course at Indian Institute of Technology, Kharagpur. So, my paper topic is prediction of surface subsidence over inclined seam and strain using influence function method. So, what is subsidence? It is downward movement of ground due to underground excavation. That's why we need a reliable prediction, because it causes damage to surface structures. So our approach here is influence function method, which use superposition principle. Here I develop an influence function method which is suitable for inclined seam having dip in between 0 to 12 degree. It incorporates seam inclination using coordinate transformation, and I validate the model using the field data of Adriala Longwall mine. So this is influence function method. As you can see, there is an excavated panel, and this excavated panel is divided into many infinitesimal small elements, and due to each element UZ, UX and UY is calculated, which is displacement in X, Y and Z directions, and then all of them are superposed. So this is the weight function duz xy s max e to the power minus pi x square y square by a square, and where a is h10 beta, s max is maximum subsidence value. So duxy is duz tan alpha, dux is equals to duxy cos theta, and duy is equals to duxy sin theta. So this was for flat seam. Now we have to use this for inclined seam. So what I did here, I transformed this from our current scenario is figure 3. So I transform this to figure 4 with some by changing its coordinate from x, y, z to x dash, y dash, and z dash. By doing this, we can apply the same influence function method which we apply for flat seam. So we can now we can apply the same weight function here also. So now the case study. These are the details of Adriawala longwall mine. This is the mine map. Now the red line, you can see that the red line, on this red line we fitted the model, and then on blue line we test the model. So this is the orange line, you can see this is fitted subsidence, and the actual subsidence data is the blue line. So you can see that it is almost fitting, and the green line is estimated strain. So by this we calculated our two parameters by fitting this Smax and beta. So Smax is equals to 1.3 and beta is equals to 20 degree. Now we use this same parameter to fit on the blue line to check the blue line. So on this blue line you can see the blue graph is actual mine subsidence data, and the orange one is the predicted subsidence by the model, and the green one is the estimated strain. So as shown in previous two slides, the RMSE for training data set is approximately 0.25 meter, while for testing data set is 0.26 meter, within subsidence ranges of 1.25 meter and 1.6 meter respectively. So this is I think it is a good result. So conclusion, I extended the influence function method for inclined seam, and model shows a great agreement with field measurements, and it is also computationally efficient for subsidence prediction. So thank you.
Yeah, thank you very much. You also finished it in time, so I'm very grateful to you. Any questions, please? So I do have a question actually. Influence function for incorporating for inclined seams, what you did is shifting of the influence zone by this angle beta. That's what you did?
Shifting what? No. Angle beta is actually angle of draw.
Oh, angle of draw.
Yes.
Okay. Anyway, we
This
don't
is
use
a parameter. This model
but
has
of
two
course,
parameters.
I have done modeling of this, that's why I'm telling you. Because in Adriala we found a large shift in this subsidence trough. It is abnormally large shift. So we had to, because the seam inclination is not that great, so but even then the shift is too much. And you have to actually to do meaningful prediction, I think I suggest you, there is asymmetric influence function can also be tried. Okay,
Yes.
thank you.
Okay, thanks.
I would like to invite Mr. Romil Mishra. He will be presenting this paper on stability assessment of an in-pit waste dump on sloping terrain, a case study of an iron ore mine. Please, Mr. Mishra, you have 5 minutes.
Very good morning to respected chair, all the dignitaries and delegates. I'm Romil Mishra. I'm working as faculty in the Department of Mining Engineering at NIT Raipur. I'll be presenting a study on the stability assessment of an in-pit waste dump on sloping terrain. This is a case study of an iron ore mine that we did a case study on its ultimate slope and a waste dump slope that they are going to create on a sloping terrain. So the main research question was that can a stable in-pit dump be safely constructed on a sloping terrain under weak foundation and high rainfall conditions? So it's an open pit iron ore mine. Usually the main concern with the open pit mines are the area that the dump slopes take. It's a large area which is generally not of use other than keeping the dump. So in this mine, the situation was that it is an iron ore mine on a hillock and surrounded by a dense forest region and tribal habitats. So there was a concern when the iron ore mine was going for a capacity expansion. So the mine management was concerned about creating a dump slope in between quarries, quarry at the top of the hillock and quarry at the foot of the hillock, and in between they are planning a dump. So they had the space there, and that dump was also not of permanent nature. They are dumping the rejects, iron ore rejects, which are not of used with the established facility there, but they have plans to go for some pelletization plant in future, so that they can utilize that dumped reject in their plants, which is now a reject for them. So this was the scene that we observed there on the available dumps. The rain cuts were there, and this is the particulars of what the expansion and volume of waste that they have to handle. So the mine expansion was from 0.15 million tons to 1.2 million tons, and will generate approximately this much of waste, and 40.13% of plant dumping, 56.48% of backfilling, and 3.39% for infrastructure. The rejects are highly porous, non-plastic and non-cohesive, rendering the dump susceptible to instability, rainfall, induced erosion and collapsibility. So we did analysis for different sections, 8 different sections, but this X10, Y10 was the most critical section, in which this dump was lying between quarry 1 and quarry 2. This is the quarry 1, which is the top of the this one is at the top, and this is at the foot of the hillock, and in between that we have to assess the proposed dump. This dump has not been created. We have to assess whether dumping here will be stable or not. So we did collect the samples from there and did laboratory testing of all these parameters, and got that the foundation that is usually the weathered shale and BHQ had very low internal friction angle. These were the key observation, that soft laminated ore was, this is also a part of the foundation, and 8 to 10 megapascal was its UCS. The rock mass parameters were derived using Hook-Brown criterion, and the disturbance factor was calculated as 0.8, and GSI values of 30 to 50. So this was the representative dump mixture that we used for testing the material. We used fine reject 70%, laterite 20%, shale of 5%, and BHQ of 5%. We determined the Attenberg's limits, compaction test, and direct shear test. And we reduced the values by 30% to make the values more realistic. And then we used FLEC slope version 8.0 for analysis of the slope stability. And we adopted the benchmark criteria suggested by the DGMS. Since it's a non-permanent slope, we use 1.3 as the value, and we did the analysis at X10, Y10 section. First we did the analysis for ultimate quit query, the proposed dump, and query 2, and we did 2 kinds of analysis, one for individual dumps and another for query 1 dump and query 2. So the proposed in-pit waste dump composed predominantly of fine ore rejects exhibiting marginal standalone stability of 1.33, but acceptable stability when integrated with adjacent pit slopes. High porosity and inferior cohesion render the dump susceptible to rainfall-induced collapsibility. So the recommendations made were that since it is a very less cohesive material, means it can slide a lot, so it was recommended that quarry 2 should be demineralized before dumping, since it will be very hazardous if a dump exists there and we work on quarry 2. So it was ensured that it was recommended that quarry 2 should be demineralized and the dumping should be carried out in a manner, and particularly push dumping should be done, not direct dumping by the dump trucks. Thank you.
Thank you, Romil Mishra. We have also finished it almost in time. You can take one question. Please, sir.
Yes. Yes, yes. Actually, what we did was we took a conservative value and reduced it by 30% as recommended in literature. Yes.
Okay.
Okay. Thank you.
Okay. Thank you, Mr. Mishra. So I would like to call the fourth lecture. That's Intelligent Geoelectrical Reasoning Framework for Data-Driven Decision Making in Mining Safety. Ms. Varalakshmi P. from NIT Surathkal. Okay, please. You have 5 minutes.
Yes, good morning everyone. Myself Lakshmi, as a research scholar from NIT Surathkal. I will be presenting here intelligent geoelectrical reasoning framework for improvement for mining safety through the data-driven and decision making. Now introduce the topic is intelligent geoelectrical reasoning framework for improvement of mining safety. Actually, this is main importance of how the stability of how we'll get the stability of rock mass to get some parameters by using here. That parameters here using resistivity, porosity indices, and by using here main semi-quantitative and inspired to get interpretable by using of these parameters that rock stability will get the stability of rock mass. And again you have to use conventional methods assess of this resistivity, porosity and UCS. And one more, need to improve the integrated interval and decision making from these parameters by using how to will get the stability of rock mass. This is the main work of this introduction. Next, these key parameters. This explain there are three parameters only. The three parameters here. Porosity, UCS, and what about resistivity, and how these curves means here this curve shows that how they will abruptly means this curve shows that means the sharp images means low, and this indicates there are three parameters indicates here. It indicates this curve shows that green color is a high values. These each three parameters also separately. See, these three parameters value indicates this horizontally, and again this how much probability of will getting. Probability means how much stability of this rock parameter, each parameter of this. So this fuzzy membership means here abruptly means that is gradually transition of each parameter, means avoid the this stability of rock mass. And next framework, this is the main keyword of this paper. This framework means the overall there are 5 layers of framework designed. By using of these five layers means this is the first one is include input and pre-processing, and third one is inference, fourth one is decision, and fifth one is action layers. So these 5 layers by using of you get the framework. By using of this one more quantitative analysis here, geoelectrical stability index. This quantitative this quantitative using how the parameters is three inter parameters are relevant to the subsurface stability. Actually, this is the main higher geoelectrical stability index value is more IA indicates. That means here subsurface stability is more. Means we'll get these three parameters which value is higher. Means based on this formula by using of these three parameters we'll get this analysis. Next, this parameters allows the assessment of across the zones. And next, from this table indicates these high values. There are classification of three zones, zone A and zone B, zone C. These three zones classifications based on that geoelectrical index, susceptibility index is greater than 0.7 means is very safe zone means safe, and again this is less than 0.452 and 0.65 in between will get the JS value means is caution. Is very less means is less than 0.45 means this is very critical zone. Means here there are three classifications of zone A and zone B, zone C. Based on these parameters means, for example, this resistivity is more and UCS is more, and what about porosity is very less. Means these three is a higher values of this. Before I explain the quantitative analysis, no, that is will get the more value, that is the safest zone. So next this is this explain this only for there are three factors, low and medium and high bands of these fuzzy bands. These parameters means avoid the misclassifications of avoid this rigid cutoff anything means this stability, and allows this stability of states will get the partial membership of this, and means based on these fuzzy bands means there are three classifications, low, medium and high. Based on this will get the avoid these misclassifications, and based on the environmental hazard evaluations also. See, then again this flow chart indicates here what about input parameters are given. Actually there are 5 layers is there, right? That 5 layers, the first you have to take the input parameters, then pre-processing. Pre-processing means that mainly framework, how to this frame means get input to this high or low or medium. We'll get this based on this check this is hazard classification of this means critical means this low resistivity plus high high porosity, then low UCS means very critical. So based on this is the only for empirical relations only, not only exact. These empirical relations will get the these values. The next, spatial hazards means this indicates this graph shows that spatial analysis of geoelectrical stability index. This is very hypothetical from this mine slope. This green border means highly safe zone. This yellow, this is caution, and critical means this is right. See, these three correlated whether this is high. This indicates means is very low means critical zone means is very weak zones or saturated regions. Next, this also recommended to operational research stability of classes. There are recommended to means these indicators recommended. What is the recommended here? High porosity and low high resistivity and low porosity, and strong UCS means is recommended to monitoring the as usual the mining plants. Is very weak means how to required means how to stop that locations, and based on this that mining people will get the either cost zone or whatever safe zone or critical zone. This sensitive analysis is resistivity variations geological variable here. Most of these resistivity values mean this is very efficient of resistivity values means how the probability of this, and this change of this process this means 0.10 is very less, this 0.01 is very less means based on these three parameters. Actually what about these three parameters, each parameters will get the interrelated will get that how the stability of rock mass. See here, most efficient here resistivity of the rock. So 20% of resistivity reductions causes maximum stability loss. This framework is interpreted and suitable for integrations with this is very suitable for rail monitoring systems. See next finally concludes that I conclude that my research work, the present semi-quantitative geoelectrical framework is facilitating mining safety and incorporating resistivity, porosity, UCS and unified model. Means these three parameters based on that quantitative and give them one framework. That framework based on this you have to this is a unified model. This and one more geoelectrical stability index, that stability surface means this is the subsurface and underground and subsurface mining also indicate the stability of rock mass, and this again using the fuzzy threshold weighted the parameters also using 5-layer region classifications. That validation means the field validation, and based on the hypothetical scenario, the generation of that sensitive analysis and design the simplicity and transparency. The system provides the correlation between hazards levels and clear operational action. Means how to take how to improve the mining safety for throughout the any decision making. Means based on this you have to take the decision making. This framework also contains the basis of future work also. This is a real-time monitoring technology and decision supporting technology. Thank you, sir. Thank you for this giving this opportunity.
Thank you, Ms. Varalakshmi, for her brief presentation. So, any questions, please? Okay, then we will move on to the next one. Thank you.
Thank you, sir.
Next lecture is influence of direction of initiation sequence along and across the protected berth on dominant frequency of vibration induced due to underwater rock blasting by Mr. Suman Modi. Please come. Please make it. Sure. Before this, I would like to ask that there is one more lecture which is listed in this session. That is a multi-sectional stability assessment framework guided by 3D modeling for open cast dump slopes by Deepthi Moore, Amit Kumar Mankar, Radhakanta Konar. If anybody is present here, please come forward, because we still don't have any information of any of the authors. Otherwise, yeah, please continue.
Yeah. Very good morning to one and all. Myself, Suman Modi. Working as a research associate in IIT ISAM Dhanbad actually. So Professor Murthy has already given an overview of underwater blasting. So now we will discuss, I will just present the influence of direction of initiation sequence along and across the protected berth on the dominant frequency of vibration, as it is the most crucial parameters for the protection of the any structure actually. So this will be my content. So introduction. As compared to different modes actually, waterways offers the cheapest mode of transport across the globe, and just as as the population is growing to meet the increasing trade actually, the depth of port needs to be increased. When compared, different rock excavation methods, underwater drilling and blasting has been proven as most productive, and in lesser time period at lower cost actually. But however, it is also associated with some challenges such as vibration, water shock, and air pressure. As we know that these are the berth actually. So which offers as a platform for cargo handling, and that requires to be protected from those blast-induced stresses, which we measure generally in form of vibration, and which is quantified as peak particle velocity. So as we know that every structure has its own natural frequency, and and the structural responses. And the key concern is to whenever a blast-induced seismic waves actually just interact with the natural frequency of those structures, resonance occurs. Resonance occurs, which may cause damage of different various degree to these structures. So that is why even at low PPV, peak particle velocity, we generally have observed that structures get damaged. So this is the now structural vibration we'll concentrate on. So it is composed of two different phases, right? One is forced vibration phase, that is during the allotted period of time for the blasting, and that would be followed by free vibration phase. But that we in that phase that structures oscillates with its natural frequency. So for key differences between forced vibration and free vibration are: forced vibration that depends on physico-mechanical properties of rock mass, explosive properties, and implemented blast design. Forced vibration, that frequency, it attenuates with an increasing in propagation distance, and it is partially controllable through our blast design. Whereas the free vibration that depends on the mass and stiffness of the structure, soil structure interaction, and other environmental parameters such as temperature. And structure vibrates at its natural frequency, obviously. And but here this free vibration, it is not controllable because it is totally dependent on that structural properties. So this is so here our main objective was to assess the impact of direction of initiation sequence and row of blast holes relative in as compared to the protected berths. These are the berths as both sides of the channel actually, where we need to dredge this much of seabed strata, and accordingly we conducted experiments to assess that influences. So one across this is the berth A, this is the berth B, where, and this is called across blasting, across the channel blasting case, and this was the along the channel blasting case. So in both the experiments, number of rows was 1, number of holes 10 number of holes with 4 meter hole depth, and maximum charge per delay of 12 kg with a spacing of 1.5 meter, and interhole space delays of 25 millisecond was allotted, and total blast duration that we provided actually was 225 millisecond. So as you can see, this was the entire waveform of our entire waveform signal, and this was the forced vibration phase and it was followed by free vibration phase, that we truncated this waveform into a single, and just we calculated those the domain frequency of this one in the next slide actually. So these are the structural responses during forced vibration phase in each direction here. Across initiation across direction actually, our dominant frequency was observed to be lesser always, 22, 22, and 22 in all the three orthogonal directions actually. While along direction blasting, our that dominant frequency was observed higher as compared to that of the case in across blasting, that is 68 in transverse direction, 28 in vertical direction, and 30 in that longitudinal directions. So also we compared peak vector sum of the peak vibration also, that was 4.39 mm per second in across blasting case and 4.07 mm per second in along blasting case using this formula. So so what we observed actually, that during the blasting across and along the berth that lasted for 265 millisecond and 254 millisecond, that was basically due to that maybe because of the scattering on the nonal system and all. And the PVS, so peak vector sum due to blasting across and along the berth was evaluated to be 4.39 mm per second and 4.07 mm per second at respective distances of 75 meter and 100 meter from the blast location. So here vibration followed the attenuation law that yes, it attenuates with the distance. However, the dominant frequency for across blasting at 75 meter distance was found to be 22 hertz in all directions, but for blasting along the earth at 100 meter distance, it was 68, 28, and 30 hertz in respective directions of transverse, vertical, and longitudinal. As we know here that dominant frequency also, as the distance it attenuates with increasing distance, right? So what may be the reason? Because the dominant frequency of the vibration due to along blasting actually was greater than that because of the intact rock mass that the seismic wave encountered between that row of blast holes and the structure. And while in the across blasting case, the initiation sequence was this way. So the blasted muck generated by the blasting of the previous initiated holes that behave as the that behave as a filtering medium of those shock waves that converted these seismic waves of high dominant frequency to a low dominant frequency. And this is why, so here just we concluded that across the birth rows, firing of rows with initiation sequence blasting with initiations rows parallel to the berths should be preferred for underwater seabed blasting. So now I will just move to conclusions actually. So blasting should be considered within the initiation sequence oriented along the berth to ensure structural safety against blast-induced vibrations. This also indicates that the row of blast holes should preferably be aligned parallel to the berth, and it also implies that row of blast holes should be along the berths. So obviously now it is having some limitations that only 2 experiments we have covered here, and further experimental studies and field validations are required to generalize this concept. So this is from my side. Thank you very much.
Thank you, Mr. Modi. Any questions? Yeah, please. Please.
In general,
sir,
during blasting, whether underwater or in a rock, if the dominant frequency is high,
yes, sir.
Is it good or bad for the structure?
Yeah, it is good, sir. Actually,
it is good.
Yeah.
But you are saying here the opposite in the conclusion that we should do because you got along this dominant frequency high.
Yeah, yes, sir.
But you are saying we should do the other way.
No. Along the blasting, we should do the blasting along.
Okay.
Yeah, exactly, sir. Exactly. Thank you, sir.
Yeah. But I also had that same doubt because in one of your slides you showed that low frequency is better.
No, sir. That along the blasting we should.
I think. Yeah. Thank you very much.
Oh, thank you, sir.
Nice
Thank you very much.
presentation. So we'll come to the final presenter, Dr. Avinash Paul. His support design for safe extraction of coal over stored working condition.
Good morning, ladies and gentlemen. Myself is Dr. Avinash Paul, working as scientist staff in CSI at Simfer in Geomechanics and Mine Design Department. Today, my topic of presentation is support design for safe extraction of coal over stored working condition. As we all know that roof fall affects directly to the safety and productivity, and till date also it contributes around 40% of fatalities in underground coal mines. Some of the causes of the roof fall is bed separation and blast induced vibration, presence of laminated eliminated bedding planes, geological challenge areas, and some improper grouting and lag in installation of the support system. To overcome all these irregularities, if we provide the rational and adequate design of support system, then all the problems which I have just tried to explain can be overcome. So the objective of my study is, first of all, I did the geotechnical investigation, then characterization of the roof rocks. Then I have suggested a design of support system for final extraction of the coal lift over stored working considering the varied galleried condition. This is basically a case study of Chanda Rayatwari of WCL. Here my research approach. First, I did the rock mass classification by using CMRI RMR system. Then estimated the rock load with the help of the empirical model. Then with numerical modeling also I tried to find out the rock load height and rock load. Then after comparing this the result which I obtained from numerical and empirical model, I tried to design the support system for the opening, then developed some nomogram in the terms of gallery width, rock load, RMR, and required factor of safety. Then I have also proposed a guideline for the support design. This is the study area where 3 lifts were already stored of 9 meter of the length, and we have proposed the support design for the 4th lift, whose thickness was 3 meter. Here the dipping of the seam was is 1 in 5. The method of working is board and pillar method. Now, first of all, we have determined the RMR for 4 meter galleries. The basic parameters which we have used in the RMR is layer thickness, structural features, weatherability, compressive strength, and groundwater conditions. Then after determination of the RMR, we did some adjustment in this RMR for that is 10% reduction for solid blasting. Then we have estimated the rock load for galleries and junction, which comes as 3.15 and 4 ton per meter square for galleries and junctions. Now we determine the RMR for 4.2 meter gallery width also using same parameters, and the rock and then we have also determined the rock load for galleries and junction. The rock load which is obtained for galleries is 3.78, and the rock load obtained for junctions is 4.54 ton per meter square. Then the estimation of the rock load was done by numerical modeling also. This is the rock properties which we have used during the numerical modeling. Here the total development of drivage was 4 into 3 meter and 4.2 meter into 3 meter. Extraction height 3 meter, depth of the cover was 120 meter. Here in the numerical modeling, basically the safety factor ranging 0 to 1, generally taken as a height of unstable zone, and which requires the proper and adequate support system. This is the modeling result. The rock load find for 4 meter galleries for junction is 2 meter, and for galleries was 2.5 meter, and for 4.2 meter gallery width it is 2.5 for galleries and 3 meter for junctions. Then I did the comparison of the rock load which I have found for this numerical and empirical approach. Here the deviation in the rock load was observed between 2 ton per meter square and 4 ton per meter square of the rock load, with the gradual increase in rock load. A steep increase in the rock load was also noticed between 4 ton to 5 ton per meter square of the rock load. Here the gradual increase in the rock load refers to the stress distribution within the rock mass, then closure of the cracks, then presence of some weakness of the plane. An steep increase in the rock load may refer to the possibility of the rock mass failure when the load bearing capacity of the surrounding rock mass decreases. So this gradual and steep increase in the rock mass can be taken care by designing rational and adequate design of support system. Now the result which we obtained for 4 meter and 4.2 meter galleries, and by comparing it is seen that the rock load from both the approaches found in the close agreement. Thus for safety prospects, the empirical approach was selected for design of support system. This is the design of support system which we have proposed for 4 meter and for 4.2 meter gallery width. I did some analysis of the result also in terms of this rock load and required safety factors for galleries and junctions. For galleries, as it's shown by the graph, an increase in the rock load was observed with the increase in the gallery width and with a requirement of higher factor of the safety. For an instance, if our gallery width is 4.2 meter width, then the rock load will be 3.5 ton per meter square and required safety factor will be 2.6. Now, same interrelationship was found for junctions also for gallery width, rock load and required safety factor. Here also the increasing trend in the rock load was shown with the increase in the gallery width of the junctions, requiring the higher factor of the safety. Here the junction with the cross section area of 17.2 per meter square, we can directly the projected range of the rock load falls between 4 and 4.4 ton per meter square with the associate safety factor of 2.52 to 2.58. The applicability of the nomogram that we can find directly the different ranges of the rock load from this model. Analysis of the result was also done to find the trend of rock load in the terms of RMR, rock load and factor of the safety. Here also, as depicted by the graph, RMR increases with decrease in the rock load, required factor of safety decreases and increase in the RMR. Here the benefit of the model is that by knowing any value of the RMR, we can directly predict the rock load with its corresponding factor of the safety. This analysis is done for galleries, and same observation and same trend was observed for the junctions also. Support design guideline also suggested in terms of for different gallery widths in terms of RMR, rock load and factor of the safety with the projection of the with the projection of the required support system. Applicability here also, if we know any RMR value, then from this guideline we can directly find the required the rock load and the required factor of the safety. Conclusion that first of all we have find the rock load for different gallery width, that is for 4 meter and for 4.2 meter. Then the rock load rating was calculated for both of the gallery width, and it was found as 40.5 and 37, reflecting the fair and poor roof condition respectively. Then for the gallery of 4 meter, the rock load was evaluated as 3.15 and 4 ton per meter square for junctions and galleries. And for 4 meter gallery width, the estimated rock load for numerical bonding was 2.98 and for galleries 3.72, and the rock load for 4.2 meter gallery width is 3.72 and 4.47 ton per meter for junctions. Here the rock load found for both the approaches are are in the close agreement. Hence, the empirical approach is suggested for design of support system. Then then trend of rock mass, rock load, along with the safety factor for galleries and junction was also found, and it was seen that increase in RMR with decrease in rock load, and the required safety factor decreases with increase in RMR. The support design guideline was also recommended for the different gallery width for 4 meter to 4.8 meter. And here I have divided that support design with the 3 zones of the RMR on the basis of the rock load and factor of safety, so that we can directly determine the rock load and required factor of safety if the value of the RMR is known. Thank you.
Thank you, Avinash Paul. Any question?
Yes, I think I am audible. So, to determine RMR, the most crucial thing is layer thickness.
Yes, sir.
How do you find out layer thickness? Is it physical measurement, and how many samples do you take? Because you have to take the
measurement, sir. But
you have to take layer
sometimes
thickness in the
we
roof.
find difficult in determining the layer thickness. If layer thickness is exposed, then we can directly measure from the pillars if the immediate roof is coal, and if the immediate roof is sandstone, and if the layers are not visible, then we have to go for some recent falls, or we have to then we have to go for blasting to determine the layer thickness. And in earlier stages also there one is the borehole strata scope was also there. From there we can directly determine the layer thickness in the rocks.
Thank you, Avinash. Okay. Now we are coming to the conclusion. I would like to hand over the mic to my co-chair, Professor Pankaj Devangan. He would like to just say a brief about this session.
Thank you, Dr. John. So, as we are running startup time, so let me conclude this session in a very brief. So, in this session, apart from keynote lectures delivered by Dr. Murthy and Dr. Sripad Nayak, there are 6 technical papers which are presented, starting from reserve estimation to measurement of surface subsidence, and the use of numerical modeling for stability assessment of in-pit waste dump, as well as for support design. So, no doubt, I am sure that the papers which are presented here in this technical session are having lot of significance and relevance to the mining industry and the overall growth of the nation to make this nation the world's 3rd largest economy. So I am very thankful to all the participants for beautiful presentation of their paper in the given time schedule. Thank you and best of luck to all the participants.
Thank you very much, session chair and session co-chair. Before we formally conclude the session by felicitating the presenters and the keynote speakers, Dr. Nikhil Sardesai, the organizing secretary of the conference, has a few announcements to make.
Thank you, sirs, for your kind time. I request that the evaluation sheet that has been given to you, you kindly deposit that sheet with Dr. Nachiket Bhagade before you leave the chairs. We'll now start with the thanking function and the validity function for this session.
Thank you so much. So I hope everybody had a very interactive session, and I heartily congratulate all the presenters. So first of all, we will begin with the felicitation of the presenters by the session chairman. I request the session chairman to please felicitate Mr. Anandji Shyamji Sharma. I request the session chair and co-session chair to please felicitate Mr. Ayan Ahmed. Okay, so may kindly felicitate Mr. Dr. Romil Mishra. Ms. Varalakshmi. Dr. Suman Modi. Dr. Avinash Paul. Mr. Ayan Ahmed, is he back? May I request Professor Deb to be Thank you so much. I request the session chair and co-chair to please take their seats. I request Dr. Nikhil Sardesai to please felicitate Professor VMSR Murthy, our first keynote speaker of the first technical session. Big round of applause, ladies and gentlemen. I request Dr. Anupam Kher to please felicitate our second keynote speaker, Dr. Shripad Nayak. I request Dr. Sumant Mohanto to kindly felicitate our session chairman, Dr. John Louis. I request Dr. Sandeep Panchal to kindly felicitate our session co-chairman, Dr. Pankaj Devangan. Thank you so much for your precious time and having an interactive session. It was really a pleasure to have all of you for this first session. Now, I thank all the keynote speakers, Professor Murthy, Dr. Nayak, and the session chairman, Dr. John Louis and Dr. Pankaj Devangan for a wonderful session and limiting within time. Thank you so much. Now we'll proceed for tea break. Yeah, please, please, please.
One announcement. Today I am on behalf of the entire organizing committee inviting all of you for the dinner here in the hotel itself. Please join us for the dinner as well in the evening 7:30 p.m. onwards. You're all welcome for the dinner. Thank you.
One more announcement. I'm really sorry about this, but we have awards, a couple of awards in each category. There's a best paper award, two awards in mining, 2 awards in environment, 2 in tunneling and 2 in cyber physical systems. Along with that, we also have a best conference paper award and a best early career research award to be given out on the day of valedictory, that is last day, tomorrow. So I request all of the participants to please stay back till tomorrow evening, and the evaluation done by the chair and the co-chair and by the reviewers will be used as a indicative figure to decide and judge the awards. So please stay back and let's see who gets the award. Thank you.
ये हटा दीजिए ना फिंगरप्रिंट.
हाँ वो करना सर.
तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, जब चट्टानें रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है, और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं, तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र, विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी डीजीएमएस, आईबीएम, डीएमजी और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक और आधुनिक तरीकों से की जाती है। क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी सशक्त पहचान बनाई है। कंपनी के पास उच्च गुणवत्ता वाले कैलिब्रेटेड इक्विपमेंट उपलब्ध हैं, जैसे कि सेस्मोग्राफ, डस्ट और नॉइज मेजरमेंट इंस्ट्रूमेंट्स, टोटल स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बेंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुजलॉन और अनेक प्रतिष्ठित सरकारी व निजी संस्थाओं के साथ रॉकटेक ने विश्वास और गुणवत्ता का रिश्ता बनाया है। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, इंजीनियरिंग द इम्पॉसिबल सेफली, प्रिसाइजली एंड रिलायबली।
मैं मनोज गुरारीकर, निदेशक रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, आपका इस कॉन्फ्रेंस में हार्दिक स्वागत करता हूँ। हमें पूर्ण विश्वास है कि रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड की विशेष योग्यताएं आपके भविष्य के प्रोजेक्ट में महत्वपूर्ण योगदान देगी।
जब चट्टानें रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है, और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं, तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र, विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी डीजीएमएस, आईबीएम, डीएमजी और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक और आधुनिक तरीकों से की जाती है। क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी सशक्त पहचान बनाई है। कंपनी के पास उच्च गुणवत्ता वाले कैलिब्रेटेड इक्विपमेंट उपलब्ध हैं, जैसे कि सेस्मोग्राफ, डस्ट और नॉइज मेजरमेंट इंस्ट्रूमेंट्स, टोटल स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बेंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुजलॉन और अनेक प्रतिष्ठित सरकारी व निजी संस्थाओं के साथ रॉकटेक ने विश्वास और गुणवत्ता का रिश्ता बनाया है। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, इंजीनियरिंग द इम्पॉसिबल सेफली, प्रिसाइजली एंड रिलायबली।
मैं मनोज गुरारीकर, निदेशक रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, आपका इस कॉन्फ्रेंस में हार्दिक स्वागत करता हूँ। हमें पूर्ण विश्वास है कि रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड की विशेष योग्यताएं आपके भविष्य के प्रोजेक्ट में महत्वपूर्ण योगदान देगी।
जब चट्टानें रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है, और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं, तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है। और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल
श्री कृष्ण जी महाराज को
जब चट्टानें रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है। और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र, विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी डीजीएमएस, आईबीएम, डीएमजी और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक और आधुनिक तरीकों से की जाती है। क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी
I request all the presenters to take their seat as soon as possible. We are soon going to start our second technical session. सर वो पहले वाले हैं। थोड़ा क्लियर कर दो।
and reliably.
मैं मनोज गुरारीकर, निदेशक रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, आपका इस कॉन्फ्रेंस में हार्दिक स्वागत करता हूँ। हमें पूर्ण विश्वास है कि रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड की विशेष योग्यताएं आपके भविष्य के प्रोजेक्ट में महत्वपूर्ण योगदान देगी।
I request all the presenters and the participants to soon take their seat. I request all the participants and the presenters to please take their seat as soon as possible.
तकनीक रास्ता बनाती है और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग
I request all the participants and the presenters to please take their seat quickly. We have to start the next session.
और तकनीकी परामर्श सेवाएं भी प्रदान
We are already running behind schedule.
अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है।
I request all the presenters and the participants to please take their seat. The tea break is almost over. I request all the participants and presenters to please take their seat.
GMS, IBM, DMG और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक
I request all the participants to please take their seat.
क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी सशक्त पहचान बनाई है। कंपनी के पास उच्च गुणवत्ता वाले कैलिब्रेटेड इक्विपमेंट उपलब्ध हैं, जैसे कि सेस्मोग्राफ, डस्ट और नॉइज मेजरमेंट इंस्ट्रूमेंट्स, टोटल स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बेंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुज़लॉन और अनेक प्रतिष्ठित सरकारी व निजी संस्थाओं के साथ रॉकटेक ने विश्वास और गुणवत्ता का रिश्ता बनाया है। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, engineering the impossible safely, precisely and reliably.
मैं मनोज गुरारीकर, निदेशक रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, आपका इस कॉन्फ्रेंस में हार्दिक स्वागत करता हूँ। हमें पूर्ण विश्वास है कि रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड की विशेष योग्यताएं आपके भविष्य के प्रोजेक्ट में महत्वपूर्ण योगदान देगी।
जब चट्टानें रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है, और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं, तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र, विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी डीजीएमएस, आईबीएम, डीएमजी और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक और आधुनिक तरीकों से की जाती है। क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी सशक्त पहचान बनाई है। कंपनी के पास उच्च गुणवत्ता वाले कैलिब्रेटेड इक्विपमेंट उपलब्ध हैं, जैसे कि सेस्मोग्राफ, डस्ट और नॉइज मेजरमेंट इंस्ट्रूमेंट्स, टोटल स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बेंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुजलॉन और अनेक संस्थाओं के साथ रॉकटेक
Thank you so much. So good afternoon, a very warm good afternoon once again. I am Dr. Nachiket Vivek Bhagade from the Department of Mining Engineering, VNIT Nagpur. I welcome you to the second technical session of ISAMET-26. First of all, I would like to introduce our session chairman, Professor Yashwant Katpatal. Professor Yashwant Katpatal is a professor HAG at the Department of Civil Engineering, Dean Research Consultancy at VNIT Nagpur. His research interests are spatial analysis through remote sensing data and geographical information system. Professor Katpatal has published 305 research papers in international national journals, conferences and books. He has been awarded 11 R&D projects, total worthing 255 lakhs in area of remote sensing and GIS, geotech analysis. He has guided 25 students for PhD degree on remote sensing and GIS application for water resources management, environmental engineering, transportation and urban planning. Based on his contributions, Professor Katpatal has been granted 6 patents on remote sensing and GIS. Professor Katpatal has completed around 50 consultancies in the area of remote sensing GIS applications to several organizations. Now I request Dr. Suman Mohanto. Now I request Dr. Praful. I request Dr. Praful to please give a floral welcome to Professor Katpatal. It's right there. Yeah. Give a big round of applause, please. Thank you so much, sir, for being here. Our session co-chairman is Dr. Amar Prakash, who is a chief scientist at CSIR Simfer Dhanbad and head of mine subsidence and surveying section. He secured first class in BE and Bangalore University and received MGMI gold medal. He holds surveyors and first class man manager certificate, medal unrestricted, certificates from DGMS and 7 years of industry experience at Hutti Gold Mines. He earned his PhD in mining engineering from ISM Dhanbad. With over 24 years of research experience in mine surveying and subsidence, Dr. Prakash has published more than 120 papers in reputed national and international journals and conferences. Now I request Dr. R.D. Lokhande, sir, please, to kindly give a floral welcome to Dr. Amar Prakash. Thank you so much, sir, for joining us. The first keynote delivery is by a very prolific faculty from University in Colombia, Professor Daniel Lopez, who we know is a distinguished mining engineer and a tenured professor at the Universidad de la Guajira, Colombia. He holds a PhD in managerial sciences and an MSc in business management from Universidad Rafael Belloso Casin, URBE, along with a mining engineering degree from Universidad Pedagógica y Tecnológica de Colombia, UPTC. Dr. Danny has led more than 40 research projects and is the author of 12 scientific books. He has published over 90 peer-reviewed publications and has delivered 38 conference presentations, including 19 at international forums. He is a recipient of Luis Antonio Robles Suarez Medal, the International Champions League Award as Internalization Ambassador at Uni Guajira, and the Honorary Award by Municipal Council of Maicao. Now I request Dr. Praful to please give a floral welcome to Professor Danny. Please, sir. Professor has joined us all the way from Colombia. Thank you so much, Professor Danny. I now hand over the session to our session chairman, Professor Katpatal. Thank you so much.
Yeah, it's working. So good afternoon to all of you. I welcome all of you for the second session, in which first we will have a keynote address by Dr. Daniel. And then we will be having 4 presentations which are slated in this session on the theme environment. The keynote address will be on the topic of environmental situation of mining in Colombia, challenges, lessons and opportunities. Dr. Daniel, I was told that he has traveled almost 36 hours to reach here, and we are very eager to listen to you about the situation in Colombia and your experiences therein. So first I must introduce my co-chair who will be doing the report here. He will be taking notes and then we will share the proceedings with you. Dr. Daniel, please.
Okay, good afternoon. My name is Daniel Lopez Ubinao. I am professor at the University of La Guajira in the north of Colombia, in the border with Venezuela. My presentation is about the environmental situation of mining in Colombia, challenges, lessons, and opportunities. First of all, mining is an important pillar of our economy, but we have several activities, for example, tourism, fishing, services, commerce, and mining is one of the most important activities in my country, but we are not a mining country. In my opinion, it's very important to transform my country into a mining country, because with this determination, we have less environmental affectations and more benefits for the communities. We need a lot of social programs, health, education, roads, infrastructure, but mining is not our priority right now. Even our president disagrees with mining, especially with coal mining. Similar than you, our most important mining is coal mining. But our president has a radical position, like about climate change. Then he has it's a little difficult, the situation with him. But we have important geological potential. For example, we have coal, gold, emeralds, iron, nickel, limestone. We have a similar scenario than that you have here coal, copper projects, iron, limestone, clay. We have similar scenarios. And this is the reason that I am here, looking for opportunities and looking for international collaboration. I will be now this week in Nagpur, and next week I will be in Salt Lake City also in another international conference looking for this international collaboration. We have also my university, we have an international conference about mining also with this environmental approach. And I hope that some of you will be in Rihuacha, in my city, sharing your knowledge and your experience about mining in India. And then we have this important geological potential, but at the same time we have a lot of debates in some regions about environmental topics. Sometimes people prefer agriculture over mining to use water sources. Then there are a lot of disinformation about mining, that mining is bad and environmental affectations. But for me it's very important, because for our economy we need these royalties, that in Colombia we have in some areas poverty, then we need to improve this situation. For this reason, I am a researcher. I have several articles and books about mining, but especially about environmental topics applied to the mining. Then this information is very important for the government, the companies and communities to make better decisions in terms of mining. As I mentioned before, we have several commodities: coal, gold, nickel, emeralds, construction materials, and now we have also copper projects. You know that copper is very important now because of the energetic transition in the planet. And we have also large, medium, and small scale mining, and also artisanal mining. Artisanal mining is developing by communities to make a living, just to survive, and this is not our goal, because for us mining is a synonym of wealth, not just to survive. And also we have now a big problem. This is illegal mining, that they are using this activity over narco traffic, because gold mining now, the international market, the price of the gold is very high. Then they prefer this activity to finance their illegal activities. Also, we have tensions between mining and agriculture by local communities to use water sources. They prefer agriculture over mining. Then we are working very strong in environmental education with these communities to this is aware of this importance of mining for us. The point is to transform my country into a mining country, you know. We need this determination, and in 2 months will be the elections again in my country to the new president. Then it's an important decision about my society. Then Colombia is located at the top of South America, you can see in the map. And also my university is located at the top of Colombia in this purple state, close to Venezuela. You know that Venezuela is very famous now for the situation with the US and Maduro. Okay, then we have important projects about coal in La Guajira and Cesar, and also in the west we have nickel, and also gold and copper projects, and in the center of my country we have iron and emeralds. We are very famous for the emeralds. And on the south of my country is the Amazon, you know, it's very important for the planet. The Amazon is the lung of the planet right now with Brazil, Ecuador, and Peru. But in this area we have illegal mining. They are destroying our resources. They are stealing our resources, and they destroy all this environment. Then the situation in my country about environment versus mining is a very complex scenario. Then we have key environmental challenges, for example, about water pollution. These illegal groups are using mercury, and you know that mercury is a very toxic element. Fish eat this mercury and communities eat this fish. Then it's very evident and very clear that we have now intense problems in the health communities, in the human health. Also, we have deforestation in the Amazon and in Antioquia. These illegal groups are using gold mining to finance and to buy weapons. Then we have an intense debate about mining versus environment. Colombia is one of the 3 most important countries in terms of biodiversity. We have sensitive ecosystems, and we have also a small institutional capacity. We have several institutions, public institutions, but the effort is not enough. We need more public workers to reach this global agenda about decarbonization to face the climate change. First of all, or initially, the situation is legal versus illegal mining. For us, legal mining is not a big deal, because there are multinational companies that they develop sustainable mining. This is not our problem. Obviously that they have problems with the pollution, these kind of things. But our real problem is illegal mining and artisanal mining. Why? Because they don't develop environmental activities, and we don't have the control over these activities. Then we have a lot of informality. The point is to transform this informality into a legal mining, to have the control over these activities, and to confront illegal mining with the military power of my country, you know, to use the police, the army, because they are stealing our resources. They don't generate any profit or benefits for the communities. They are stealing our gold. Then we need more social oversight, more social participation is very important for us because mining is in this mining transition to reach sustainability. Also with energetic transition that we need to use more clean energies, you know. And I am aware of mining, coal mining here in India is so important also. It's similar the scenario than in Colombia. Then artisanal and small scale mining, they are using rudimentary technologies, and it's very important to enter in this tendency to use more clean technologies and advanced technologies because they are using chemical substances and they have problems in human health right now. Then with them, it's very important formalization processes to have more technical assistance. It's very important that our government to support them to buy this technology for them. The tier one, we have opportunities for improvement to reinforce the environmental control, to promote the mining formalization with more social participation, to use more clean technologies, because it's very important, this determination. For this reason, in the beginning of my presentation, I told about it's very important my country will be a mining country. Mining country in South America is Chile, for example, Peru, and Brazil, but my country is in the beginning of this process. Then we are working in a strong way. For this reason, I am here looking for innovation and sustainability. For example, advanced water treatment that you have available here, maybe in China, the US, Australia. The point is to use this kind of technology to apply also in my country. More clean technology that we have in the north of my country, solar energy and eolic energy. Then it's very important to use this kind of energy in all the process in large, medium, and artisanal scale mining. The point is to reduce these emissions, you know, especially in the air, that we have problems, for example, with dust. Dust contain coal, and then we have close to the mines respiratory problems for the communities. Then we need to face this situation with more advanced technology. As I mentioned before, Colombia is one of the 3 most important countries about biodiversity. We have mining close to protected areas. Then it's very important to use, for us, to use technical instruments, for example, environmental impact assessments, to reach this balance between development and conservation. As you can see, this is an holistic situation, you know, holistic debate. The point is this balance between economy and environment. Then we have a lot of regulation, environmental regulation. For example, we have institutions like ANLA, this is National Authority of Environmental Licenses, the Ministry of Environment, and regional environmental authorities. In my region is called Corpo Guajira. Then the point is to work together with the academy, companies, and communities to reach our most important goal right now is sustainable mining in my country. Environmental regulation are developing like 30 years ago, and mining in large scale mining like 50 years ago. The point is to work on the same line with more practical implementation and using environmental monitoring systems. Then my university with other 4 universities, we are working in this point, research and innovation, about institutional and official documents about mining, you know. With this information, government can make better decisions. For this reason, I am here looking for international collaboration. Also because we need more innovation and as I mentioned before, to use environmental monitoring technologies. The point is this scientific information, about articles, and this is the point that we can work together with you. I was talking with some of you about this possibility. Maybe some of you will be in our conference in September in Colombia also, sharing your knowledge and to work together because you have this prestige. Then we have lessons learned. For example, regulation alone is not enough. We need more social participation. We need to transform informality into legal mining to have more control. We need also a preventive approach. We have now a reactive approach in front of mining. Also more community participation because we are thinking in long term. To transform my country into a mining country, then it's very important social participation because they are close to the mines. When we have all this information and we compare this information with international practices, it's very evident that we have a small institutional capacity. For this reason, we need more public workers in these institutions to have the control over these illegal activities. With them, the only way with illegal mining is to confront them with our military power, because they are stealing our resources and our problems with the environment is because of them. Then it's very important for us this integration between development objectives and environmental protection. Also, as I mentioned before, it's very important this preventive approach to avoid with studies about avoid these environmental problems, the negative impacts. And because we are in this tendency about sustainable mining transition at the same time with energetic transition. Finally, the conclusion of this study is that we have environmental challenges and our scenario is very complex. For example, we have a lot of biodiversity, a lot of species of plants, of animal, water sources, and also we have even indigenous and black communities. Then it's not easy to develop mining in my country. Even as I mentioned before, our president Gustavo Petro disagrees with mining, especially with coal mining. Then it's not easy for us, but we are working in a strong way. That we have several subsectors, as I mentioned before, coal, emeralds, copper. Then the point is to face these environmental problems in a differential way. Sustainable mining is important, but it's also important this coordination with the academy because we have this scientific information to make better decisions. And also because mining is very important for our economy. You know that we have in Colombia a lot of poverty and mining is a good pathway for us. Illegal mining is our most important cancer. I think that you don't have this problem here in India, but this is a big problem that we have, illegal mining. They are stealing our gold right now. And we need to reach sustainability, this combination between regulation, innovation, and social participation. The point is to achieve this balance between economy and environmental protection with more mining formalization, and also because sustainable mining is for us an opportunity, it's not a problem. Lastly, the recommendation is more environmental education with the communities, more networks, more international collaboration, to promote the formalization of artisanal and small-scale mining, also to adopt international good environmental practices, and improve this coordination between academy, government, industry, and communities. These are the references that I use for my presentation, this one also. And this is the conference that we are organizing, is international conference about mining and geology with this environmental approach. And it will take place in Riohacha in the north of Colombia in the border with Venezuela in September the 22nd for 3 days. Thank you very much for your attention. It was a pleasure for me to share this information with you.
Thank you, Dr. Daniel. You had a presentation which covered all the aspects of mining in your country. When the deposits are formed actually globally, they follow same scientific principles. But when the regions are demarcated by the boundaries of the country, the situation changes. And we are understanding that with more and more collaboration with country like India, I think the system will be benefited, where not only the policies will be generated, but also the mining scenario will be formalized, and certainly it will be put into a system whereby it will be good for the economy. Thank you very much for your thought-provoking presentation. Thank you.
There are 4 technical papers. The first title of the first paper is Dry Beneficiation of Low-Grade Bauxite Ores for Improvement in Al2O3 SiO2 Ratio. Manoj Modi, whether he will be presenting? Okay, time limitation is very less, so you have to complete within 5 minutes. Okay. 1:15 we have to complete.
A very good afternoon to all of you. This is our next paper on the dry beneficiation of low-grade bauxite ores for improvement in alumina to silica ratio. So India's bauxite demand is experiencing rapid growth, which can be observed from this compounded annual growth rate, which is projected around 4.8% from 2025 to 2035. So this study evaluates the dry beneficiation process of low-grade bauxite ores, which are obviously rich in silica content, to improve the alumina to silica ratio of low-grade bauxite and to determine the influence of particle size on the total alumina and total silica content. Due to the depletion of the high-grade ores, we are compelled to move to the low-grade aluminum ores, and also due to the reduction of threshold value from the mineral conservation perspective. The low-grade low-grade bauxite ores are being mined, and the companies are encouraged to being mined, but conventional beneficiation methods of bauxite are primarily the wet processes, such as washing, screening, and gravity suppression. These require substantial amount of water and commonly cannot ensure good separation, where silica is very fine-grained. So with the help of a study that carried out in bauxite mines of Eastern Ghats in the Kodinga-Mali Plateau of Odisha. So these are the details of the mine. With the revision of the threshold values by the Indian Bureau of Mines, the reserves of the mine A has increased from 61.47 million tons to 76.73 million tons, with an associated increase in the bauxite, which has a higher total silica content. So a dry beneficiation, we took the samples of bauxite from the mines, and a dry beneficiation exercise was carried out with the help of this simplified dry beneficiation circuit and vibratory screens. So this is the brief process that first the bauxite is crushed to -40 mm, and then secondary cone crushing is carried out, and after that the screening is carried out to make 4 different size fractions of -40 plus 30, -30 plus 20, -20 plus 10, and -10. And the oversize is returned to the cone crusher for further size reduction. The process aims to exploit the preferential concentration of silica and alumina across the 4 size fractions. So this was the composite samples. These were the composite samples that we collected from the mines. Then we classified it into different 4 size fractions. And then we conducted the laboratory study to determine the we carried out the chemical analysis to determine the alumina content, FeO2 content, loss on ignition, all these things. And this was the trend curve that we obtained for 4 different size fractions, which we have LGD1, these are the mean values of what we have obtained. The finer fractions, you can observe that the finer fractions have less value of total alumina content, and it is quite higher at the -40 +30. This behavior demonstrates that alumina is preferentially restrained in coarser sizes during the dry crushing and screening. The scenario is totally different in case of total silica. When we observed all the samples, we found that the silica increased dramatically in this -30 to -10 region. Consequently, removal of -10 mm fraction from beneficiation is better to get a good alumina to silica ratio. This the beneficiation performance was analyzed with these marginal mean graphs, and it can be observed that there is a slight interaction in this area between in case of only total alumina. The results were quantified with the help of analysis of variance, and for that we prepared 2 null hypotheses and corresponding alternative hypothesis. The overall beneficiation outcomes were that the TA was improved with this dry beneficiation. TA improved by 5%, and total silica decreased by 10%. And mass recovery, which is the recovery after losses, is 90%. So these were the null hypotheses. These were tested with ANOVA 2-factor without replication. The analysis was conducted with a randomized block design with a significance level of 5%. The size fractions were considered as factors and the sample types were considered as blocking variables. And these are the results of the analysis of variance. And we can easily see that the size fraction is a significant factor in case of the total alumina content, and the size factor and sample type both are significant factors, but size fraction is a predominant factor with a mean squares of 59.179. So the null hypothesis were rejected, confirming that the size fraction is the dominant factor controlling the beneficiation performance. Based on this, we can draw these conclusions that dry beneficiation by crushing and screening provides measurable improvement in low-grade bauxite quality through selective removal of silica-rich fines. The +10 mm fraction demonstrates higher alumina, lower silica, and improved alumina to silica ratio suitable for blending in alumina refineries. The process operates without water, reduces caustic losses, lowers red mud generation, and enables utilization of expanded.
You are talking about you haven't used water in your crushing arrangements.
Yes.
Then how you control your dust emissions?
Dust emission is a bigger concern, but we observed that it can be controlled by dust mitigation measures at the transfer points. Although it's a bigger concern, but at this point of view, the water consumption is a more prioritized thing as compared to dust in a particular region, because water that is involved in wet processing is of large quantity.
mining community is worried about silicosis, and you are talking about your.
No, I am not negating the fact. The dust is equally important. We have to take measures for that. But in this process, we have used dry beneficiation as a gesture for reducing water consumption.
Okay, thank you.
Thank you.
Your name is?
Romil Mishra. Yes, sir. We use that kind of things. At the transfer points, we have at the transfer points of conveyors, we have heavy dust generation that we have observed. Thank you, sir.
Okay, thank you, Romil. Next paper title is A Comprehensive Low-Grade Strategy Framework for Indian Coal Mining Industry. Who? Pranay Ramesh Moon.
Good afternoon all. I, Pranay Ramesh Moon, research scholar, IIT ISM Dhanbad. Today's topic, a comprehensive low carbon strategy framework for Indian coal mining industry. India recognized as one of the fastest growing country globally and significantly coal user faces challenges maintain growth addressing international demands to reduce the greenhouse gas emission and mitigate climate change. In accordance with global initiative, India is the systematically transforming energy and industrial field to reduce the continuously use of coal because they will be more produce carbon emission. We promote to low carbon technology. Coal continues to provide is India's power generation and production. Nevertheless, the nation is progressively incorporation climate change in energy policy and planning frameworks to transition of low carbon future. This is the source of carbon emission in India's coal mining region. There are two types of carbon emission. First is a natural emission, and second is a emission caused by humans. So this is the classification we see. Carbon emission from whole coal seam first in natural emission. Second is a carbon emission from underground discoloration emission. Okay. Now we see at first in block scale of tectonic evaluation, gas monitoring, and the cumulative difference effect. In second block, we spontaneous combustion by metal carbon budget, and in second block, fuel and natural gas, first coal coke and crude oil and diesel. We see that the analysis of strategy reducing how to reduce the coal mining region. This is the analysis in India's is a very big issue for carbon emission because the India is the majorly dependence of the electricity production or coal mining. So we see that this is the we upgraded. So technological equipment is a most important, significant pollution reducing carbon emission accounting boundaries and absence the economic analysis models. So this is we see that there in the carbon reduction is a more effective for future generation or future dependence. The reduction of carbon emission and the advantages of green development should provide coal mining region collaboration among these. We see that the collaboration about the government bodies, academic institution, research field, and we enhance to partnership of government bodies and universities because these are majorly important of in other future tendency. So essential responsibility of mitigating carbon emission in coal mining region, employment of supplementary resource, rehabilitation and development sustainable mining operation is second is most important. Carbon market trading and carbon emission rights is third is most important. Fourth is a carbon emission accounting system is also because this is this four things is more important for a low carbon emission system. This is the investigation and development of how to low carbon technology. We see that we see that this is the framework. Framework goal. What is the goal? Verification, quantification of carbon emission, and to study carbon reduction strategy. We see that the verification and quantification of carbon emission is source. What is source of carbon emission in different field? Waste management, electricity consumption, water resources consumption of fossil fuels, unregulated consumption, coal and mines, and coal mining activities. This is the second analysis, and third is a study, how to study reduction of reduction strategy. So field investigation is analysis, how to analyze field investigation, studies and test, theoretical studies, numerical simulation, on online monitoring, on-site monitoring, and field test. This is the analysis of method. Then next is how to reduction strategies. We'll study how to study increasing the investigation energy efficiency of low carbon technologies, proper use of CBM, enhancing implementation of additional resources, enhancing recovery and growth, how to sustainable mining we use, and CCES and CO2 ECBM. And last is
actively participate in carbon market. How to currently scenario of carbon market, and how different countries, how India's will more carbon production. Lastly, we study also outline to express strategies mitigation carbon emission in coal mining areas to achieve significantly mitigation, essentially strength sustainable coal mining techniques and enhancing ecological management. And the last is a study highlight advanced technology essential for sustainable growth in coal frame, implementing an online carbon emission monitoring system, and addressing the technological challenges. CO2, ECBM, CCUS are essential for how to will absolutely to do low carbon emission. These strategies provide the significant economical benefit and environmental impact and reduction carbons. Okay, thank you.
Thank you. Any question? Okay. The next paper is Comprehensive Review of Sustainable Processing Methods and Critical Metal Recovery by Aditya Nagar.
Yeah.
Okay, so good morning everyone. I am Aditya Nagar, a dual degree final year student from the Department of Mining Engineering at IIT BHU Varanasi. Today I will present a comprehensive review of sustainable processing method and critical metal recovery. As we transition toward a green economy, our research focus on how to secure the mineral essentials for the future without compromising the environmental standards. So as we know that the critical metals like lithium, cobalt and REs are the backbone of the modern renewable energy and defense systems. However, as the matrix on the side illustrate that mineral face a high supply risk due to the extreme geopolitical concentrations. To diversify this supply and ensure energy security, we must evaluate the technological development made between 2015 to 2025 The research gap and objective. The primary gap we identify is that while India holds 6% of global RE's reserves, we contribute less than 1% to the global production. This is due to the technological hurdles and strict regulations. Our objective is to evaluate sustainable beneficiation and extraction technologies that can bridge this gap while integrate AI and circular economy principles. So the global and Indian scenarios. Currently, global production is dominated by a few players, the DRC for cobalt and the China for 61% of REO production. India currently lack a domestic supply for cobalt and lithium. However, this is high potential in the monazite sand of Tamil Nadu and Kerala. Unlocking these require navigating the strength atomic energy load that currently slow commercial exploitations. The advanced beneficiation. Sustainability begins with smarter beneficiation. We are moving towards sensor-based shortening using XRT and NIR to reject waste at the early stage, which significantly cut energy consumptions. Additionally, the use of biosurfactants like rhamnolipids achieve our 75% recovery with an 85% lower environmental impact than traditional chemical collectors. For extraction, bioleaching is a game changer. While utilizing microbial oxidation, we can achieve 80 to 90% recovery of cobalt and nickel from mining, tailing and low-grade ores. This method is low energy and capital efficient. Most important, it's enable urban mining, allowing us to reprocess industrial residue and turn waste into wealth. For the purification and high purity refining, to achieve a 99% purity required for a high-tech application, we are exploring green chemistry while solvent extraction is the industry standard. It faces scrutiny for toxic waste. The new protein-based strategic using laminoline achieve our 99% selectivity under ambient condition, while membrane process like nanofabrication offer high energy efficiency. The modern mine is data driven. AI driven analytics can cut drilling cost by 25%, and digital twin allow for real time risk reduction and scenario evaluation. Furthermore, AI control feeds can see a 15 to 20% increase in utilization through predictive maintenance. This allows machine learning to optimize process interactions that exceed human comprehension. Technical excellence must match environmental responsibility. Since refining is the most carbon intensive stage, we advocate for the life cycle sustainable assessment to measure our total impact. Our research align with the UN Sustainable Development Goals and Sustainable Development Goal, supported by Indian National Critical Minerals, a virtual policy blueprint for a self-reliant green economy. So the conclusion, we must pivot to the hybrid technologies. The combustion of sensor-based shortening and bioleaching is our most effective tool for lowering cost and emission. Finally, urban mining will provide the supply diversification we need. So that is all about my presentation. Thank you for your precious time.
Any question? Thank you. And the last paper is downstream process of UCG processed syngas, utilization and potential options in India by Sadhana Kumari.
Notes. स्क्रीन में दिखेगा स्क्रीन में आ रही है स्लाइड्स सॉरी ये किसी और का आ गया यूसीजी ये तो नेक्स्ट नहीं ये वाला स्टार्टिंग दूसरा स्लाइड खुला है ये मेरा वाला नहीं यहाँ पे आ रहा है पेन ड्राइव हाँ दो पेन ड्राइव ये नहीं है पेन ड्राइव लेके आ रहा है बैग में है लेके आ रहा है
This is not your presentation, huh?
Good afternoon to everyone, respected chair, co-chair, the participants, delegate and professor and faculties and all presenting in this hall. Myself Sadhana Kumari, project associate at CSIR Simfer Dhanbad. I would like to thank the organizer in this international conference who is giving to me the opportunities to present in paper. Today I am going to present my paper titled Downstream Processing of UCG, Syngas Utilization and Potential Options in India. UCG is well known since more than 100 years. UCG in India is yet to be established. Worldwide, so many trials has been done, and in some has been country like us, Australia, China, and Africa. The demonstration and trials project are under working, but in India we struggling since part of decade established. So in that ground injections, the oxidation, pyrolysis, all the reactions kinetic is established at the outside. With the syngas produced, that treatment process it established, but unfortunately in India we are not taking that for seriously. was that the underground coal gasification, how it will be separated, how it will be treated and utilized based on the different applications. So it is said that gas produced underground coal gasification has a composition of hydrogen, CO, CH4, CO2, NOx, SOx. So these gases, it has a mixture of a combustible gases and non-combustible gases. So how combustible gases can be used for the power generation? Even combustible gases can be used for making of chemical fertilizer, like was new concept of this in arises. UCG prospect in India. UCG is an in situ process. It means coal is converted into gas inside the ground without surface mining. It allows us to use deep and unminable coal reserves which are otherwise wasted. For India, UCG is important because we have large deep coal resources and high demand for power, fuels and fertilizers. It can be also reduced depends on important oil and natural gas. Underground coal gasification UCG process. This is the ground level raw gas oxidation process and raw combustible UCG gas. Underground coal gasification process, the UCG process occurs inside the coal seam and consists of three main zones. The oxidation zone at the temperature above 1200 degrees Celsius generates heat. The reduction zone produces hydrogen and carbon monoxide. The dry distillation zone releases volatile gases through pyrolysis. Gasify agents such as air, oxygen, or control the gas quality. Oxygen. UCG operations. UCG seen gas composition new seen mainly contains hydrogen, carbon monoxide, carbon dioxide, methane. However, it also contains impurities like tar particulates, hydrogen sulfides, ammonia and moisture. Due to these impurities, raw seen gas cannot be used directly, making downstream processing very important. Need for downstream processing. Downstream processing improves the quality, safety and efficiency of seen gas. The major steps include cooling, particulates removal, downstream processing include removal, tar removal, gas cleaning and conditioning. These processes protect equipment, improve heating value and make the seen gas suitable for different applications. Seen gas component separations in UCG system. Process stage gas separation, seen gas utilization options. After cleaning and conditioning UCG, seen gas can be used in several ways. It can generate electricity through integrated gasification combined cycle. It can also be used to produce hydrogen, ammonia, synthetic natural gas, methanol and liquid fuels. Seen gas utilization options. One important application UCG seen gas is methanol production. Methanol is widely used to fuel, solvent and chemical feedstock. Seen gas can be also be converted into liquid fuels using the Fischer-Tropsch process. These technologies support carbon capture and utilization, contributing to a circular carbon economic. CO2 methanol CH3 conversion. UCG seen gas potential in India. India has a vast deep coal can be supported power generation, fertilizer productions, and chemical impurities. India investigation like CSIR Simfer hence has successfully demonstrated gas conversion into methanol and LPG. UCG producing station. To summarize, the UCG syngas contains a valuable component but requires effective downstream processing with proper cleaning and conditioning. It can be used for power, fuels, and chemicals. UCG offers a pathway to energy security, cleaner coal utilization, and reduce important for India. Thank you very much.
Here we come to the end of the presentations which were slated for this particular session. The highlight of the session has been actually the presentation. We had a keynote address by Dr. Daniel, and he highlighted the situation of mining in Colombia, and we are looking forward to fruitful collaboration with India. Then highlight of other presentations was actually very young people. All the 4 authors were very young, and we heard them in different areas. While Romil Mishra, he talked about the Kondinga Mali Plateau, Orissa, to improve the alumni to silica ratio. Then we heard PR Moon, where low carbon emission strategies through verification and quantification, and to reduce the emission. Then we heard Aditya Nagar, where he reviewed the sustainable processing methods for critical metal recovery, smart beneficiation like microbial, bioleaching, protein-based strategy, etc. And then we heard Sadhana Kumari, she talked about the underground coal gasification and other related issues. So this brings this session to the end, and I am thankful to all the authors for following the time restrictions, and here we come to the end of this. I hand over the proceedings to the Mr. Nachiket.
Thank you so much, Professor Katpatal, for chairing this session. and to Dr. Amar Prakash for co-chairing the session. Does the co-chair want to suggest any comments regarding the closure? Thank you so much. So, so now we almost would like to formally close this technical session number 2. I hereby invite the session chairman and co-chairman to please felicitate the presenters one by one. I'll call out the names. Dr. Romil Mishra, please come forward. Mr. Pranay Ramesh Moon. Mr. Aditya Nagar. Let us make it quick, please. Ms. Sadhana Kumari. Many thanks to the session chairman and co-chairman. May kindly take your seat. Now I invite our illustrious faculty member from the department, Professor I.L. Muthreja, to please felicitate our first keynote in this session, Professor Danny from Colombia. Please, sir. I request Dr. Anupam Kher to please felicitate Professor Yashwant Katpatal, our session chairman. I invite Dr. Suman Mohanto to kindly felicitate Dr. Amar Prakash, session co-chairman. So before we move on to the lunch break, please identify the presenters of the next session and please report it to the registration desk in the lobby. And the presenters for tomorrow, we have parallel sessions tomorrow, so the presenters tomorrow also may kindly report in the lobby, so that we may plan it for the smooth, for the smooth proceedings of tomorrow. So I really congratulate all of you for your hearty participation. The questions were interesting, the discussions were very, very interesting. I thank all of you for your very jubilant participation, and I thank you once again. Thank you so much. Let's join for lunch. Thank you. Yes, sir. Just one second. The volunteers from VNIT, I request them all to stay here, please. Volunteers from VNIT, please stay here. Participants, please move for lunch. Sir, आपके पास पेन ड्राइव है? Sir का please copy कर लीजिए.
एक साथ आते हैं तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी डीजीएमएस, आईबीएम, डीएमजी और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक और आधुनिक तरीकों से की जाती है। क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी सशक्त पहचान बनाई है। कंपनी के पास उच्च गुणवत्ता वाले कैलिब्रेटेड इक्विपमेंट उपलब्ध हैं, जैसे कि सेस्मोग्राफ, डस्ट और नॉइज मेजरमेंट इंस्ट्रूमेंट्स, टोटल स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बैंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुजलॉन और अनेक प्रतिष्ठित सरकारी व निजी संस्थाओं के साथ रॉकटेक ने विश्वास और गुणवत्ता का रिश्ता बनाया है। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, इंजीनियरिंग द इम्पॉसिबल सेफली, प्रिसाइजली एंड रिलायबली।
मैं मनोज गुरारीकर, निदेशक रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, आपका इस कॉन्फ्रेंस में हार्दिक स्वागत करता हूँ। हमें पूर्ण विश्वास है कि रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड की विशेष योग्यताएं आपके भविष्य के प्रोजेक्ट में महत्वपूर्ण योगदान देगी।
जब चट्टानें रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है, और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं, तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी डीजीएमएस, आईबीएम, डीएमजी और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक और आधुनिक तरीकों से की जाती है। क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी सशक्त पहचान बनाई है। कंपनी के पास उच्च गुणवत्ता वाले कैलिब्रेटेड इक्विपमेंट उपलब्ध हैं, जैसे कि सेस्मोग्राफ, डस्ट और नॉइज मेजरमेंट इंस्ट्रूमेंट्स, टोटल स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बेंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुजलॉन और अनेक प्रतिष्ठित सरकारी व निजी संस्थाओं के साथ रॉकटेक ने विश्वास और गुणवत्ता का रिश्ता बनाया है। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, इंजीनियरिंग द इम्पॉसिबल सेफली, प्रिसाइजली एंड रिलायबली।
मैं मनोज गुरारीकर, निदेशक रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, आपका इस कॉन्फ्रेंस में हार्दिक स्वागत करता हूँ। हमें पूर्ण विश्वास है कि रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड की विशेष योग्यताएं आपके भविष्य के प्रोजेक्ट में महत्वपूर्ण योगदान देगी।
जब चट्टानें रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है, और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं, तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र, विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी DGMS, IBM, DMG और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक और आधुनिक तरीकों से की जाती है। क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी सशक्त पहचान बनाई है। कंपनी के पास उच्च गुणवत्ता वाले कैलिब्रेटेड इक्विपमेंट उपलब्ध हैं, जैसे कि सेस्मोग्राफ, डस्ट और नॉइज मेजरमेंट इंस्ट्रूमेंट्स, टोटल स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बेंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुजलॉन और अनेक प्रतिष्ठित सरकारी व निजी संस्थाओं के साथ रॉकटेक ने विश्वास, और गुणवत्ता का रिश्ता बनाया है। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, engineering the impossible safely, precisely and reliably.
Namaskar, all respectable dignitaries and dear friends. First of all, I am making my apology that I am not physically attending this important conference because of my some health problem. I am happy to convey my best wishes to the organizers and participants of the International Symposium on Advance in Mining, Environment and Tunneling, which is being organized by the Department of Mining Engineering at VNIT Nagpur. It is also related with my ministry. We are in the process of making tunnels that costing at least 5 lakh crores and at least 340 tunnels are in our plan. At the same time, the railway, the irrigation department, the hydro projects, state government, they have also got a lot of projects. The problem in all this mining project is we need to develop technology, and technology is very important because by using best technology, we are going to reduce the cost. I always talking to the people that the most important thing which is the strength for India is the young talented engineering manpower is the most important strength. And the second important thing is the innovation, entrepreneurship, science, technology, research, skilled and successful practices. We name it as knowledge. And conversion of knowledge into wealth is the future. Regarding the minerals, we are also developing a lot of mining sector in the deep sea also. We have got the tremendous potential, and particularly in the Nagpur where the conference is going on, Maharashtra's 80% of the minerals are in Nagpur, Vidarbha area. We have in Gadchiroli district, we have got iron ore of 65 grade. This is to be supposed to be the best in the world. And even in Jamshedpur, the grade of the iron ore where Tata is using that is of 55. So today the steel industry is going to develop in our area. Already we received the investment of 7,50,000 crore in Gadchiroli district. Today at the same time manganese is very important. We have already import of manganese because we have a lot of shortage. In particular in Vidarbha region, in Bhandara, Gondia, Balaghat, some part of Nagpur district, and near Madhya Pradesh area, we have got a lot of manganese available. This is the time that we need to develop appropriate technology by which we can increase the productivity and reduce the cost. At the same time, in the mining sector, the most important thing is coal. And here totally we have got a lot of potential in coal. The government is already giving priority for development of CBM, that is coal bed methane. And from coal we are making methanol, ammonium nitrate, and at the same time we can make urea and petroleum products from that. And one of the products is DME, and that we can easily add into LPG, where we have maximum import of LPG. Today in the national interest, our policy is to reduce our import and increase our export. For that point of view, the mining sector is the most important sector for the country. We are the fastest growing economy in the world. Now our number is 4th. And the dream of our Prime Minister to make Indian economy as the 3rd largest economy in the world, the $5 trillion economy. Our mission is to make India as a Vishwaguru. In this process, the heart of our Indian economy is the mining sector. Even in automobile industry also is one of the important industry. Now we are making lithium-ion battery in electric vehicles. We have maximum export of electric vehicles, car, two-wheelers, and now we are in the process of electric equipment, electric construction equipment, agriculture equipment, where need lithium-ion battery. And the cost of the lithium battery when we started, at that time it was $150 per kilowatt per hour. And now it comes to $55 per kilowatt per hour. In Indian, young talented engineers doing excellent job in the research. Now we have got the aluminum air technology by which our fuel will be aluminum sheet where we can make it a fuel from that. I personally experience that these are the good technology. Regarding the sector where I need, there are a lot of challenges. Regarding mining sector, there is a lot of pollution where we need to reduce the pollution, and at the same time where we are using maximum coal, where the problem is the emission of carbon dioxide is a big challenge for the country. In a sustainable development, we need to protect our ecology and environment. We need to find out with the help of research that how we can make value addition in carbon dioxide and where we can make a lot of value added products from that. That is to be a very important priority for the society and for the country. Internationally, there are a lot of research are going on. We have got the potential. Whatever the good available in our country, we can use it. And which is not available in our country, we can take that successful practices from the world and we can accept it and we will go ahead. Today, this is the sector which is the heart of our economy. I feel that even for this sector, we need to develop different type of equipments of international standard. Research we need for that. And even in the deep sea, we are given a lot of priority for development of this mining sector in deep sea. There are huge potential for major minerals, and it is the time for the country that the success in the mining sector is going to decide the economic future of our country. I am really happy that today this conference is organized in Nagpur. I am the Member of Parliament of Nagpur. So first of all, I welcoming all of you who are coming from abroad and different part of the country in Nagpur. This is the Orange City. This is the center of the country. 0 mile is in Nagpur. And as a Member of Parliament, I am welcoming all of you for this conference. Once again, I am giving my all best wishes to all the stakeholders, and this conference will 100% will going to useful for the development of our futuristic development in the mining sector. The methodology, the research, at the same time reducing the cost, which are the important agenda. At the same time, we have to very seriously think about the pollution, that how we are going to reduce that. I am giving my best wishes to all of you. Thank you very much. Namaskar. Namaskar, all respectable dignitaries and dear friends. First of all, I am making my apology that I am not physically attending this important conference because of my some health problem. I am happy to convey my best wishes to the organizers and participants of the International Symposium on Advance in Mining, Environment and Tunneling, which is being organized by the Department of Mining Engineering at VNIT Nagpur. It is also related with my ministry. We are in the process of making tunnels that costing at least 5 lakh crores and at least 340 tunnels are in our plan. At the same time, the railway, the irrigation department, the hydro projects, state government, they have also got a lot of projects. The problem in all this mining project is we need to develop technology, and technology is very important because by using best technology, we are going to reduce the cost. I always talking to the people that the most important thing, which is the strength for India, is the young talented engineering manpower is the most important strength. And the second important thing is the innovation, entrepreneurship, science, technology, research, skilled and successful practices. We name it as knowledge. And conversion of knowledge into wealth is the future. Regarding the minerals, we are also developing a lot of mining sector in the deep sea also. We have got the tremendous potential, and particularly in the Nagpur where the conference is going on, Maharashtra's 80% of the minerals are in Nagpur, Vidarbha area. We have in Gadchiroli district, we have got iron ore of 65 grade. This is to be supposed to be the best in the world. And even in Jamshedpur, the grade of the iron ore where Tata is using that is of 55.
जब चट्टानें रास्ता रोकती हैं तब जब चट्टानें रास्ता रोकती हैं तब तकनीक रास्ता बनाती है, और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी डीजीएमएस, आईबीएम, डीएमजी और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक और आधुनिक तरीकों से की जाती है। क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी सशक्त पहचान बनाई है। कंपनी के पास उच्च गुणवत्ता वाले कैलिब्रेटेड इक्विपमेंट उपलब्ध हैं, जैसे कि सेस्मोग्राफ, डस्ट और नॉइज मेजरमेंट इंस्ट्रूमेंट्स, टोटल स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बेंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुजलॉन और अनेक प्रतिष्ठित सरकारी व निजी संस्थाओं के साथ रॉकटेक ने विश्वास और गुणवत्ता का रिश्ता बनाया है। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, इंजीनियरिंग द इम्पॉसिबल सेफली, प्रिसाइजली एंड रिलायबली।
मैं मनोज गुरारीकर, निदेशक रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, आपका इस कॉन्फ्रेंस में हार्दिक स्वागत करता हूँ। हमें पूर्ण विश्वास है कि रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड की विशेष योग्यताएं आपके भविष्य के प्रोजेक्ट में महत्वपूर्ण योगदान देगी।
ये जवानी
लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र, विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी डीजीएमएस, आईबीएम, डीएमजी और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बेंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुजलॉन और अनेक प्रतिष्ठित सरकारी व निजी संस्थाओं के साथ रॉकटेक ने विश्वास और गुणवत्ता का रिश्ता बनाया है। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, engineering the impossible safely, precisely and reliably.
मैं मनोज गुरारीकर, निदेशक रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड, आपका इस कॉन्फ्रेंस में हार्दिक स्वागत करता हूँ। हमें पूर्ण विश्वास है कि रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड की विशेष योग्यताएं आपके भविष्य के प्रोजेक्ट में महत्वपूर्ण योगदान देगी।
जब चट्टानें रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है, और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं, तो जन्म लेती है उत्कृष्ट इंजीनियरिंग। रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है। पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है। इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है। रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है। इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है। सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक, मेट्रो स्टेशंस का निर्माण, हाई राइज बिल्डिंग्स के लिए फाउंडेशन एक्सकेवेशन, टनल एक्सकेवेशन और कंस्ट्रक्शन, हर क्षेत्र में रॉकटेक ने अपनी सटीकता और तकनीकी श्रेष्ठता सिद्ध की है। अंडर वाटर एक्सकेवेशन जैसे अत्यंत तकनीकी और चुनौतीपूर्ण कार्यों को सफलतापूर्वक पूर्ण कर कंपनी ने अपनी क्षमता को नए आयाम दिए हैं। खनन क्षेत्र, विशेष रूप से पत्थर खदानों में एक्सकेवेशन और क्रशिंग जैसे कार्य रॉकटेक द्वारा सुरक्षा, गुणवत्ता और नियमानुसार पूरी जिम्मेदारी के साथ किए जाते हैं। कंपनी डीजीएमएस, आईबीएम, डीएमजी और अन्य सभी वैधानिक संस्थाओं के साथ पूर्ण समन्वय में कार्य करते हुए सभी नियमों और मानकों का पालन सुनिश्चित करती है। रॉकटेक में तकनीक के साथ साथ मानव जीवन को सर्वोच्च प्राथमिकता दी जाती है। खनन जैसे जोखिमपूर्ण कार्यों के दौरान प्रत्येक श्रमिक की सुरक्षा, स्वास्थ्य और कार्यस्थल की सुरक्षित परिस्थितियां हमारी प्रतिबद्धता का मूल आधार है। रॉकटेक की सक्षम तकनीकी टीम द्वारा रेस्पिरेबल डस्ट कॉन्सेंट्रेशन मेजरमेंट, नॉइज मेजरमेंट और ब्लास्टिंग से संबंधित वाइब्रेशन स्टडीज वैज्ञानिक और आधुनिक तरीकों से की जाती है। क्वालिफाइड इंजीनियर्स, अनुभवी सुपरवाइजर्स और स्किल्ड ऑपरेटर्स की मजबूत टीम के साथ रॉकटेक ने माइनिंग और नॉन माइनिंग दोनों क्षेत्रों में पिछले 25 वर्षों में अपनी सशक्त पहचान बनाई है। कंपनी के पास उच्च गुणवत्ता वाले कैलिब्रेटेड इक्विपमेंट उपलब्ध हैं, जैसे कि सेस्मोग्राफ, डस्ट और नॉइज मेजरमेंट इंस्ट्रूमेंट्स, टोटल स्टेशन सहित आधुनिक सॉफ्टवेयर्स और न्यूमेरिकल मॉडलिंग लेबोरेटरी भी। अल्ट्राटेक, गोदरेज प्रॉपर्टीज, मुंबई और बेंगलोर मेट्रो, इंडियन एयरफोर्स, HAL, लोढ़ा ग्रुप, हयात, मॉयल, सुजलॉन और अनेक प्रतिष्ठित सरकारी व निजी संस्थाओं के साथ रॉकटेक ने विश्वास और गुणवत्ता का रिश्ता बनाया है। रॉकटेक इंजीनियरिंग प्राइवेट
Hello. So, good afternoon all. Myself, Dr. Sandeep Panchal, and I will be anchoring for this session number 3. The theme of this session number 3 is tunneling and excavation. So, we have today with us chairman for this session, Dr. Shripad R. Nayak, sir, and I request Dr. Nachiket Bagade to do floor welcome to our chairman, session chairman, Dr. Nayak. Bagade sir, please, and Nayak sir. Let me give a brief introduction about Dr. Shripad Nayak sir. Okay, before that, let's have one photograph. So, ladies and gentlemen, let me introduce Dr. Shripad Nayak sir. Shripad sir is graduate in mining engineering from NIT Surathkal and acquired his masters from IIT BHU. He completed his PhD from NIT Surathkal in 2017. Shripad sir joined NIRM in year 1992 and presently he is in-charge director of NIRM. He has expertise in numerical modeling and instrumentation in the areas of mining, civil engineering. He has published more than 35 technical papers in journals, national and international conferences. And now our session co-chair is Dr. V.M. Galante sir. So I request Dr. Sumant Mohanto to do this flower welcome, please. Sir. Thank you, sir. And now we have two keynote speakers. First will be Shri Senthilnathan K, but he is not available. So Dr. G.D. Raju, who is Senior Chief Engineer Manager, Geotechnical Division L&T, will be acting on behalf of him. So I request Dr. Sumant Mohanto or Dr. Nachiket Bagade to please do this floor welcome to Shri Dr. G.D. Raju on behalf of Shri Senthilnathan K. So let me give this brief introduction about Shri Senthilnathan K. Senthilnathan sir is the Executive VP and Head of Technical Services for Heavy Civil Infrastructure IC and L&T Construction, Chennai, with over 36 years of extensive experience in the design, construction, planning and execution of the major infrastructure projects in India and abroad. He obtained his B in Civil from College of Engineering, Chennai. He has successfully led large multidisciplinary engineering team for complex projects and he is widely recognized for his expertise in structural design, construction methodologies and advanced construction machinery for bridges, metro, modernization system, highways, marine works and building infrastructure. He is currently leading a technical workforce of around 600 professionals across multiple regions in India. His leadership and technical contributions have significantly advanced modern infrastructure construction practices in India. And we have keynote 2 is Dr. Ministerial host. Please come forward, sir. And I request Dr. Mohanto to please come forward and do the floor welcome to Dr. Host. So guys, let me introduce Dr. Radisson host. He is an Australian inventor and chief principal civil expert with 28 years of international experience in tunneling, geotechnics and infrastructure engineering. He currently serves as Director Technical and Head of Ground Engineering and Technology at Embark Senior VP at TI and member of Indian Road Congress, that is IRC, Hill Roads and Tunnel Committee. He is also a former VP of ISCG and an academic advisor. He holds PhD in civil geotechnics, MPhil in civil structure, and MSc in geomechanics, and BE in civil engineering. Dr. Binshoyan has developed several influential engineering innovations, including the Venetian strength failure criterion for rock, soil, and concrete, security concrete classification, DIC technique for strength measurement in concrete structure, SRS system for time-dependent and burst-prone ground, VID technique for structure damage control by blasting, I system for ground classification, IDP for structure design, ITM tunneling method, and IGI for advanced ground investigation. His technologies are widely applied in industry, and he has led major metro, railway, hydropower, slope, foundation, and road projects across 4 continents. He has authored over 50 peer-reviewed publications, published the book Stress Non-Uniformity in Concrete and Rock Structure, and released iSTEM software. His inventions are referenced in national engineering guidelines, and he has delivered over 118 keynote lectures worldwide. So with this word, I hand over the session to our session chair, Dr. Shripad Nayak sir.
Good afternoon. This is a recurring announcement regarding the presenters who have their presentation tomorrow. During the tea break, those who have not submitted the presentations for tomorrow may kindly proceed. During the tea break, mind you, not now. Please attend the session. Once the session is terminated, you may please proceed to the registration desk in the lobby and submit your PPTs for smooth proceedings tomorrow. Thank you so much. Sir, please. Over to the chairman, sir.
Good afternoon, everyone. I welcome all of you to a session on tunneling and excavation. This is an afternoon session after a heavy meal, so it's going to be a very tough session. But I'm sure the keynote speakers will set the tone for a very active session. I'm quite hopeful for that. This session is for 1.5 hours, and the first one is a keynote address by Dr. Raju is going to give on transforming India's tunneling infrastructure and industry perspective on the future. And the second one is by Dr. Hose, an outline of I-System and its latest developments. And that will be, I think he has one more paper also. I think he is going to combine both. So keeping that in mind, I suggest the first keynote speaker, Dr. Raju, to restrict his thing to about 25 minutes. And Dr. Hose, you can combine, I think, both of them to about 30 to 45 minutes max. And that will leave us with 3 more papers. So I think we can allot around 6 to 7 minutes for each of the papers. So with that, I think we should be able to manage this session on time. So with this, I once again welcome all of you, and I welcome Dr. G.D. Raju to deliver his keynote.
So, good afternoon, everybody. I am fully aware that how difficult the post-lunch sessions would be, and I am also aware that I will try to wake you up at least, and my content at least. If my voice disturbs you, I am sorry. So, take care of your sleep. And also, I assure you, Dr. Hose, that I can lend you my 5 to 10 minutes. So, you can carry on with your I-Systems. So, very good afternoon again. And you heard it right that I am here today on behalf of my Executive Vice President, Mr. K. Senthilnathan, who is also head of our technical services at L&T, Heavy Civil Infrastructure. I will be on behalf of him, and hopefully I will do my justice for his presentation. So, very good afternoon. And the topic is transforming India's tunneling infrastructure. There is no research, there is no case study, nothing. So, don't worry. I will be just putting a point in the industry perspective. Okay, so let us see what it is. So if you see the evaluation of tunneling practice, for years, we relied mostly on the technology from mining style methods, like drill and blast and empirical supports, reactive management. They built capability, but constrained predictability and safety, especially in dense urban environments. So then came this decisive transition when we went into mechanical excavation, that is with TBM, coupled with automation and live data. We are moving from intuition-led choices to system-driven delivery, where design, execution, and monitoring operate as one. Okay. So here, if you can see the modern technology pillars, as I can say, the mechanized excavation, automation, and data-driven are very key. Okay. So if you see at a global, tunneling market overview, the forces, global forces are aligned with this shift as well. If you see here, 2024 market value, 27 billion approximately, and 2029 projection is about 36 billions. Again, what is the demand drivers here? You can see the urban population density. It's peaking and there is no depth for it, and it is going to continue. And carbon reduction initiatives, which is, there is no choice now here, they are imposing. And also energy transition requirements, and there is one seismic risk resilience as well, where we operate mostly. Okay. So underground solutions in India is syncing rapidly with these tailwinds. Okay. So if you see the global mechanized tunneling trends, the TBM market by 2030 is going to be approximately 10 billion. Okay. So where we need operation reliability, like mechanized tunneling has emerged as the defining solution for high productivity and long drives, particularly in urban setups, and then low disturbance in the urban excavation, or with minimal settlements. If you can see, with high density population under historical buildings, we are doing tunneling, and with low covers under the waters, under the sea, we are constructing tunnels. Okay. So here, when integrated with logistics and quality systems, we can deliver reliability at scale. So if you see at Indian tunneling market landscape, it is going to be 48 billion over the coming decade. Just decade I am talking about, not even the Viksit Bharat 2047. You can think of by that time what would be the market. If you see the planned length of tunnels, it's around 1,800 kilometers, where already 1,000 plus kilometers are operating in 500 plus sites. This includes metros, railways, and latest addition is high-speed rail tunnels. And as you all aware, that recent budget emphasizes on high-speed rail projects, multiple of them, and this count definitely will increase with that addition. And then strategic road tunnels, I put it Himalayan region, but it is not limited to Himalayan region, as you can always already see that is happening in Mumbai. Already one road tunnel is operating, which is built by L&T proudly, and one more road tunnel is under progress in Mumbai itself, which is 5.6 kilometers long, hard rock tunnel, deep tunnel, we are doing with TBM, under a lot of urban settlements, a lot of historical establishments, and underwater bodies. Also, recently, Bangalore has come up with a dream project. They call it B-Smile, 16 kilometers of road tunnel. 3 lanes of road tunnel, twin tunnels. The diameter of the tunnel, some years before, this diameter used to be a K1 size diameter. Now it is going to be 15 plus meters of the diameter of the tunnel, 16 kilometers, and there are more to come in the cities like Mumbai and Bangalore. The sectoral distribution in India, if you see these sectors like, railways, metros, hydel, so they are roughly, railways are contributing 18%, hydropower still continuing, dominating with 31%, and urban metro equally 18%. Road tunnels, you see the second largest contribution, 24%. Water and utility, where I can say water and utility, including the sewage tunnels. Also, there are a lot of tunnels are happening in Mumbai for these purposes. Okay, railways, when I say that, we have not included again high-speed rail component of it. And then each sector, if you throw some light on it, if you say hydropower, it remains a mainstay, long alignments under high overburden, complex hydrogeology, and major underground caverns includes not only tunnels. And these assets are strategic for clean energy and water security. If you look into the road tunneling, 25% of active portfolio, and then the road tunnels are they are mission critical, delivering all weather connectivity and decongestion. All of you, I hope, heard of our minister talking yesterday about his vision of road tunnels, particularly in the border areas. Now it is, they have got very big, clear vision to connect the border roads. And in this, alignment, already border road organization, they are fully getting trained in tunnels, and they are ready to execute these tunnels. So Himalayan corridors, particularly to access city, and the emphasis is here safety, speed, and resilience. So urban transit and metro infrastructure, 80% of market share. There again, you have challenges like shallow cover, sensitive environment, tight geometry, settlement control. We have very, very, very stringent conditions on metro tunnels. Not even 1 mm, 2 mm excess, project is stalled. Buildings are damaged. Okay, and particularly if it is under the river body, then gone. Entire tunnel is gone. So with those stringent conditions, these have to be executed. So this is where our modern TBM systems excel in Indian cities. Now water and utility tunnels, they are critical underground services like sewage and also drinking water tunnels. You have a lot of network of them coming up, particularly in Mumbai. Okay, and also we have started going for cabling, underground cabling using tunnels, and there is also proposal for stacked tunnels. If you have a road tunnel, you will have a stacked tunnel above that for sewage and for utility tunnels, and also the rectangular TBMs are in offing. If you are thinking of only circular TBMs, there is already rectangular TBMs are in offing for these services. So what are the challenges? So if I am talking about the transformation into future, what are the challenges that we are going to have? Particularly the Himalayan geology, you are all aware of it. What is it? Okay. So, and hydrogeology, which is again, diverse groundwater, urban surface, subsurface, okay. So where you have a lot of stringent restrictions, in one of the metro projects in Mumbai, where we have to cross these historical buildings for a tunnel of few meters. We have done almost some 1,000 microblasts to just cross this, since it is a hard rock. How do we stay predictable in the face of geological uncertainty? The answer is disciplined design and engineered controls. So geological responsive design approach is what we propose. The observational approach is very much essential to managing uncertainty, where continuous refinement of ground models, systematic monitoring of support behavior, no need to say on real-time basis. Anyway, digital monitoring and automation are part of it. Okay, so risk is managed by design, not by chance. So planning and GBR considerations. So planning, if you do early stage planning, which can integrate your all uncertainties, and then you will have your geotechnical baseline reports with all the required investigation data, early investigations and clear geological baseline reports. They matter a lot, and they reduce the variability, align the contracts and set realistic expectations for the performance, and also risk sharing equally to both the parties. I mean the contractor and the client. And then integrated risk framework, just a typical one we are showing here for a different type of projects, like urban and TBM, what is high risk and what is the medium risk and what is the low risk, like that for mountain tunnels, and strategic with the resilience, what is the risk category, and variable non-urban tunnels like roads and other tunnels. So this is the risk framework that is being proposed. Okay, so here again TBM can be dominated by systems integration, high overburden hydro emphasis geology. See, high overburden, you can think of like the days are gone, TBMs will work only 20 meters below. We have projects doing in the Gulf. The TBM will be operating at a depth of 80 to 100 meters below. And the hydrology, the water column is on the surface. With the high water pressure, with the high in situ stresses, still we are able to devise methods for the TBM tunnels. So execution and risk management is going to be another challenge which we have to deal with only engineering controls, like the real-time structural health monitoring. I can give many examples for this, and where L&T is already pioneering this. And you all know about the Atal tunnel in Mumbai, that is called MTHL. We have successfully completed that project, and we are post-operation on request of the client. We are monitoring the structural health real time, sitting here, 24/7, ensuring the post-operational strategy, and also staged execution methodologies and strategies, clear owner and contractor risk allocation. That's where I was talking about earlier slide. Okay, so execution excellence today means real-time structural health monitoring. Also, we are in the proposal, and soon we are going to make it reality, that we are going to execute and also review the projects remotely with IoT and digital twins. That is also in the pipeline. And the unambiguous owner contract risks allocation. So this is very redundant and taking all our time in this. Like, this is not my risk, this is your risk, and he says it is my risk. So we must have a privileged predictive management over the post, work. See, normally the post-work corrections is not the answer. Risk allocation even before, and then you come out of the project without any post-work corrections. So that is where we are heading up. And the tunnel cost characteristics again play a major role in transforming this journey. Costs are governed by relative cost intensity, which reflects again into geological complexity and the overburden that is covered. And then access constraints and logistics, operational safety systems. See, normally costs for the tunneling projects are majorly governed by the geology and at what overburden you are doing it, and the access to the project and the logistics costs. Also the safety systems that we adopt, and also excavation rates and support regime change with the ground. So we budget for relative cost intensity, but not the averages. Also, mechanized supply chain integration is very much important, like, cutter head tooling. When you are planning a hard rock tunnels with TBM, so with cutter head tooling, still we are importing. So an eye on that, how to, supply on time. And then a lot of other consumables like availability of the cutters, the grout materials, the additives for this purpose. So you need to have indigenous manufacturing, as I said, increasing TBM and match the rock strength and abrasivity. Sometimes if you are not selecting a proper TBM, so you are gone. Okay. And also uptime depends on the cutter tools, grout and additives being available when it is actually needed. So industrialized segment production, when I say segment production, so TBM segment lining, mostly precast. So factory-based precast production setup will give you the quick and control quality and also supply. It is now mostly industrialized. The precast segments manufacturing is industrialized, and factory like yards with tight tolerances, again tolerances of segment making also. Automated steel and concrete and optimized cycles, quality and speed are engineered into the manufacturing cell. Also, this will be scaled up considering the upcoming prospects and the scope, where already we are using robots in reinforced tying and also 3D printing kind of things. So industrialized segment production, factory-based precast production setup with robots, automated rebar and also concreting, delivering 3 to 5 times faster than with high precision and lower workforce intensity. It is ideal for scaling when multi-TBM projects are set up in action. Now you can see in any city, I can give you an example of Chennai city. Now L&T alone is operating 8 TBMs parallelly. You can think of the requirement of all these things. And in Bangalore B-Smile project, we are proposing 12 TBMs at a time. Parallelly, they will be in operation. So digital systems and life cycle performance, you have a big, leap in this technology. When you are adopting something, it is already going 10 times ahead. So you have to catch up. As I said, real-time optimization. So in this regard also, we are catching up, and we are already have our integrated, real-time, monitoring in Chennai TBM project. My colleagues are here who are executing that project, where we have integrated GIS with the real-time monitoring. Anybody sitting on his office can see where exactly my TBM is now and what is the surface condition there and what is the settlement is happening. If there is any excess settlement or anything, immediately alerts will be sent to the concerned people through email and SMS. So successfully, already we have implemented in this project and it is continuing. Digitally, we fuse TBM parameters with geotechnical instrumentation. That's what we exactly did. And also it enables live optimization, early anomaly detection, and also predictive maintenance. So skilled workforce development is another area, a big challenge that by seeing the length of the tunneling that we are going to do in future times. So here, skill domains like simulator-based training, data analytics, advanced QA/QC, collaboration with academia and education institutions. Again, again here I would quote, and I'm happy to announce that we have already couple of years back had a tie-up with VNIT Nagpur, mining engineering department, and we are training our workforce engineers in tunneling in our Tunneling Excellence Academy near Chennai. So already a few batches have been certified successfully. Some of them are here presenting their papers. So we had 3 years MOU, so level 1, level 2. In level 2, 15 days, our engineers will have their course in VNIT and another 15 years at our Tunneling Excellence Academy near Chennai. So we are going to scale it up. We are going to tie up with more institutions and kind of things. So strategic recommendations after seeing all these challenges, like industrialization. So we have our strategic playbook, like industrialized delivery by integrating excavation, factory, and logistics. Strengthen early stage DBRs and GBRs to share the risk equally, and then adopt system-oriented risk frameworks and transparent contracts. In conclusion, the bottom line is India stands at the forefront of contemporary tunneling and equipment reliability, a robust precast supply, and data-enabled decisions will carry us toward a resilient Viksit Bharat 2047. Finally, tunneling excellence is defined by the ability to deliver high levels of predictability, safety, and quality despite inherent geological uncertainty. So I conclude with a simple standard to achieve this, like predictability, safety, and quality, even amid geological uncertainty. Thank you. I look forward to building the next chapter together. Thank you very much.
Thank you, Dr. Raju, for a very meaningful insight of industry perspective on the India's tunneling infrastructure. Now I request Dr. Hose to start his keynote on outline of I-systems and latest developments. That will be followed by stability indicators related to I-system for tunneling projects in complex geological formations. Dr. Hose, it's over to you.
Good day, everyone. Today, I'm here to talk about I-system. And this lecture would be particularly about the latest developments of I-system. In today's lecture, I will briefly talk about the I system and what it is, what is the components of the I system. Then I would talk about the indices and impact factors. And finally, I will wrap it up. I system defines a new era in ground engineering. I can say that ground classification and characterization using I system is reinvented, and the proof is in upcoming slides. I system having two components, two main components. One is the core components, itself contains several components, and another one is the auxiliary components. The core components of I system include the I class as well as the IGC. I class is the ground classification system, and the IGC is the ground characterization system. Auxiliary components of the I system include IDP as the design procedure, ISI stability indicators, IGI ground investigation, ITM tunneling method, and VID vibration induced damage assessment methods. If we have a look at the details of each component as I system's output, for example, for the I class, when you classify the ground using I system, you would get an output including all of the recommendations you need from A to Z for the support system, excavation technique you need to employ for safe and optimized drive, instrumentation techniques you need to employ to control the deformation and to monitor the situations, prevention techniques from the incidents, from the accidents, from the failures and collapses, forecast techniques, how to predict the ground ahead of your faces or behind your slope faces, and design remarks that gives the principles how to design the structure. In the IGC output, you would get the modulus of deformation, Poisson's ratio, unconfined compressive strengths, uniaxial tensile strengths, cohesion, internal friction angle, and if it is a surface structure, ultimate bearing capacity, net and safe bearing capacities. In the IDP as I system's design procedure, you will be able to do the ground zoning using the I system, identifying the ground mechanical behavior, identify accurately the ground hazards associated with the identified ground behavior, determination of the support systems, a structural dimensioning of each individual measure proposed to you, and finally, a structural verification for preparation of good for construction drawings. In the ISI, I systems, stability indicators, you would be able to estimate the active span, arch action time, deformation limits, plastic zone in terms of thickness and diameter, slip action time for the slopes, squeezing, swelling, and heaving identifier, and support system stress. In literatures also it is referred to as support pressure. In the IGI as I systems ground investigation, you would be able to do a very efficient, quick, and quite reliable investigation. And the output of the work in the IGI would be detailed project report that you are calling it DPR, ground zoning, risk analysis, risk mitigations, geological longitudinal profile, geotechnical and geomechanical I profile, geophysical G profiles, a schedule of quantities and bill of quantities. As ITM output, iSystems tunneling method, you would get the integrated classification and characterization systems with your tunneling work. Be able to do the design. You are able to optimize your design, determine the support systems for your tunnels, excavation, instrumentation, failure prevention, and prediction. And in the vibration-induced damage assessment methods, using iSystem, you not only assess the conditions that you are employing, either manual, mechanized, or drill and blast as technique of the excavation, you would be able to assess the situation in terms of peak particle velocity, frequency, and duration of exposure to the vibration, control the situation, and if in an unlucky event something is happened to your structure in terms of vibration, how to mitigate it and solve it. Now let's delve into the details of iSystem. iSystem stands for Index of Ground Structure, and I stands for index. Means that you are employing an indexing method, which is going to go deep into the details of ground. Not 5 or 6 parameters. 27 parameters would be derived from the ground by naked eye, without instruments and without any equipment or any field test. Course of development of this system took almost 20 years, from 97 to 2019. Case records of development includes 35 rock types, 11 soil types, 4 coal types in 9 countries. What is the concept behind iSystem? Comprehensiveness in applicability and use as both classification and characterization system. It's going to be and serving you as the first system that is doing the classifying the ground as well as full detail characterization of the ground. Unifying geomaterials as ground instead of saying rock mass or soil. Now you do not need to use these terms. You would say ground, including rock, soil, tailing material, and waste geomaterials. Independency from RQD. You know very well RQD in different direction and orientation, giving you different values and different assessments. The first intention in development of the iSystem was that to be completely independent from RQD or any other existing older classifications. Having meaningful and definable range. It is simply from 0 to 100, from worst to best ground in terms of competency. AI readiness by inclusion of almost all determinative features and properties of ground, which with a point and shot camera, parameters can be driven from the ground and immediately calculated. Applicability for any existing tunneling method while offering its own tunneling method as integrated system. Reliability in output when investigation is skipped. This word you in India may be very much familiar. In many projects, especially in the Himalayas, and specifically in the lesser Himalayas, that you have very difficult terrains, inaccessible terrains. Either the investigation is skipped, or if it is not, diluted. So the intention is that how to resolve this? If for any reason investigation is skipped, blindly start the work of the tunneling, for example, or the slope stabilization? No, iSystem have a solution for you. Confusion-free derivability of all parameters through a simple mapping, which is called iLogging. Synergizing designers, site, civil and mining engineers, geologists and geophysicists. That boundaries, that geologists do not interfere in the design. Designers do not interfere in the classifications, in the characterizations. Geophysicists do not know about the structure or about geology. It would be all eliminated by the boundaries which is merged together in this system. What is the application of iSystem? iSystem is applicable for rock, for soil, for tailing, as well as waste. It is for civil engineering projects, for mining projects, and for petroleum projects. You may ask, how for mining? You know very well this is the university that hosting mining engineering department. The concept in design in mining engineering is totally different from civil engineering. In civil engineering, the concept is that the structure to serve forever, right? 125 years, for example. But in mining, a structure should serve until you would be able to take the last piece of ore and extract it from the mine. Moreover, it should be economic. You should save in cost, and you should have good profit margin. By definition of variable shell system in iSystem, you would be able to do that for the mining works. It is applicable for underground structures, for semi-surface structures, as well as the surface structures. It is the first ever system that, considering all these parameters together and having all of these features together as a classification, characterization, design system, stability indicator, ground investigation, tunneling method, and vibration assessment. And it is the first system that, considering all of the problematical configuration of ground in terms of geology, all structural configuration of ground, again in terms of structural geology, a scale effect, earthquake effect, excavation method impact, a special type of behavior like squeezing, swelling, heaving, viscoelastoplastic behavior, fully plastic behavior, time-dependent behavior, and burst ground condition all together in one system. The formula for iSystem is as simple as what you see. I equates 5 indices of AI, CI, HI, PI, SI summed and multiplied into DFI and ETI. DFI is the dynamic force impact, and ETI, excavation technique impact. It is ranging between 0 and 100. Each index share 20% out of 100. And the summation of the indices would be multiplied by 2 impact factors, and finally range sitting between 0 to 100. Then ground is classified into 10 classes, from I1 as extremely good to I10 as extremely poor. I1, I2, I3, and I4 are shown by green code of color, from extremely good to relatively good, and then I5, I6, I7 with the yellow color code as average to relatively poor, and then I8 and I9 in the orange as the poor and very poor, and finally I10 as extremely poor ground in terms of competency. When the classification is done, means that the value of I is derived, is calculated. You would be having for each individual class, as you see in this table, several recommendations, including SS, support system, ET, excavation technique, IT, instrumentation technique, PT, prevention technique, FT, forecast technique, and DR, design remark. Beside that, you would be having all of the mechanical properties of ground for that particular phase that you have done the calculation of I system. How to utilize it? Very simple. You will just send a geologist or an engineer at phase and derive the 27 parameters from the phase and put it into the equations provided for indices and impact factors, and the I is calculated. And the output automatically is the core component of I system. One I class, another one IGC. Input data for I system include geohydrological data, geological data, geomechanical data, geometrical data, geophysical data, geostructural data about the opening, and geotechnical data. This is called data collection or I-logging. Then the 5 indices and 2 impact factors would be calculated. You may see 27 parameters, but don't be panic. It's easy. For each individual parameter, one table is given, and picking the value from the table is confusion-free and very easy. So after calculation of armature index, configuration index, hydro index, property index, strength index, and the 2 impact factors of dynamic forces impact and excavation technique impact, your I value is obtained. Then you would be having the classification with all of the recommendations, and you would be having the characterization with all of the parameters that you need for design or for design optimization or for ground zoning, including modulus of deformation, compressive strength, tensile strength, Poisson's ratio, friction angle, cohesion, and the ultimate bearing capacity. In a summary, just for I system, the lecture is not finished. For just the core of this lecture, the summary is that you will be doing the I logging. The value of I will sit between 0 to 100. You will come in that classification section, find the range associated with the class, and take all of the recommendation for your construction. You will go down for the IGC. Based on the I value you have calculated, you can calculate any of those parameters and use it in your design or your optimization. Now, the output of I system for underground structures is specifically called ITM, I systems tunneling method. There is a software called iSystem software. I think now the version is 1.9.0 that easing the I-logging procedure for you in 4 minutes. And you would be able to do all of these classifications and characterizations. eye logging like face mapping for underground structures like tunnels or a face of a slope. Geologist or engineer would be able to derive the required parameter, look at the table, pick the value, put the index, put it in the index equation, calculate the index. And some of the indices multiplied into the impact factors, I value would be calculated. If you remember, I said that there is two core components and several auxiliary components. Amongst the auxiliary components of I-system, there was one called IGI. What is IGI? I-systems ground investigation. You may have faced with unreliability of conventional investigations in your tunnel projects, especially when the tunnel is placed in very difficult terrain like Himalayas. In the last 10 years that I am working in India as problem solver, as designer, I have never seen any geological L profile, longitudinal profile for rail tunnels to be matched with the encountered condition more than 30%. The best scenario that I have seen was around 30%. Even in many scenarios. When you go on top to see that the boreholes that is reported, that drilled at the depth of 700 meters, you would not be able to find even more than 1.5 meter drilling. One of the addresses is the USBR project, one of the most prestigious projects in India since independence of India. The project that some of the tunnel projects with 3-kilometer tunnels were under construction for 22 years. And this was coming from, for 3 kilometers, as per the report, as per the investigations, more than 30 holes were drilled up to the depth of 150 meters. But when you were doing the excavation work, you were facing with totally different material. And most importantly, in none of the DPRs that in the last 10 years in India I have reviewed or I have used it in my design, I never saw that ground behavior is identified. Never. Never. It is just a collection of boreholes and then deriving geotechnical parameters from field tests or lab tests. IGI is going to resolve this. A costly process of the drilling, geotechnical drilling, field and lab tests that delay the start of the projects, or when it is in the difficult terrain like the lesser Himalayas, give enough reason to the clients to skip it, is going to be eliminated. And instead, a reliable 6-stage autocorrective system to be employed that gives you very reliable details. The latest application of IGI is done by NHAI in the state of Kerala, between Kerala and Tamil Nadu, for near 11 kilometers tunnel in 4 strings of twin tube tunnels in the challenging terrains of the Western Ghats. And interestingly, whole procedure of the IGI is conducted in 117 days, while as per NHAI documents, it was predicted 9 months only for geotechnical investigation, while the IGI is conducted in 117 days, and the output contained the design, not only investigation, also design. But what is IGI? The stage 1 is simple desk studies about the project, about the survey data, about the contour map of the area, about the geology, geotechnic, geomechanics, tectonics, GIS data, and then shortlisting the alignments, selecting some alignments based on the GIS data you are collecting. Either it is the archive data or even the live data. In the stage 2, on top of the alignment that you have shortlisted, you will send the geologists for traverse geological mapping. And the output of the stage 2 would be a longitudinal geological profile as a tentative profile. A stage 3 contains the I logging, and as I said, calculation of I value through mapping process. In this stage, the geologist or engineer this time traverse the surface to measure the I value for each meter along the alignments. In this stage, they will review the L profile they prepared in the stage 2. Based on the output of the stage 1, 2, and 3, they would decide what type of geophysical techniques to be employed for mapping the subsurface. So either resistivity or seismic. Several very simply available techniques would be picked, selected, based on the terrain, based on the conditions that they encountered during the stage 2 and 3. And then at the stage 4, they will conduct the geophysical survey. In this stage, they would be able to check the output of the stage 2 and 3 and scrutinize their outputs. Moreover, at the end of stage 4, they need to compare the geological L profile, I systems I profile, and the geophysical profile, either resistivity or seismic, together to see there is mismatch in the predictions along the alignment or not. By identification of the mismatches and the problems which is not identified in the stage 2 and 3, they would be recommending the location for geotechnical drilling. So, geotechnical drilling would be conducted at stage 5, not as a regular process. If output of stage 2, 3, and 4 is that all results are matching together, no uncertainty, you do not need to do the stage 5. But if you found something in the geophysical profile that it was not there in the geological profile and in the I system profile, you will drill a hole in that location and you will check that situation and you will verify the profile. Either geophysical profile is saying the truth, or the eye logging and the geological profile. So you will correct it, you will verify the situation. Now you would have verified profiles, reliable for your design. At the stage 6, based on the I system profiles that you have prepared along the alignment from one portal to another, you would be doing the ground zoning. For each individual ground zone, you would be clubbing 1 or 2 classes of I system, and you would be placing design based on that classes. Parameters already derived, because by deriving the I value, you are deriving all of the mechanical properties. So this is the IGI. Now that you have done your investigation, you should enter to the design phase. You would be having two approaches. Better to say that one overall approach and one detailed procedure. Overall approach says that you need to employ empirical that defines the practicality of design, analytical which forms the core of design, seismic for dynamic checks, and observational for verifying the adequacy of the measures. And amongst each individual phase of this approach, you need to do these 7 stages of design procedure. You have already done. DC is done through the IGI. GZ is done in the stage 6 of IGI. GZ is ground zoning. GB is the ground behavior identification, is done in the stage 6 of IGI. GH is the ground hazard associated with each ground behavior that's already done. Support system determination already done by output of the I system. And a structural dimensioning you will be doing with the input provided by the IGC, ground characterization. And then you will be doing the structural verification. Now you can issue the drawings good for construction without surprise, to eliminate the geological surprises that you are frequently hearing in India. Another auxiliary component of I-system was ISI, I-system's stability indicator. It includes active span, defining the activated stretch of underground space from the face, arch action time, duration of the time until ground start to wake up from a sleeping mood when you open it. Deformation limits, including the alert and alarm limits, that it is essential for any design, specifically for underground structures. Identification of the plastic zone, in terms of the thickness of the plastic zone, because you need to define what is the influence zone around your underground structure. A slip action time for, if your case is the slope, you want to know that once you are cutting the trench, how much time you have until ground start to wake up. SSH identification criterion, standing for squeezing, swelling, heaving. This is giving a criteria to you to identify that, for example, in the underground work, your tunnel is driving into squeezing ground or not. If yes, what measures to be applied? And support system stress or support system pressure or support pressure that is used for the design of the support system and verification of the measures. All are related to I value. You may have a question in your mind that how to identify the ground behavior. So you assume that you have calculated the I value for the face of the slope or face of the tunnel. You would be having recommendations from I-class, mechanical properties from IGC, and also you can estimate all of these parameters that defined in the ISI. It's now very easy for you to judge what would be the ground behavior. And your judgment would not be anymore a hazy judgment. You can be certain that how this ground is going to behave. Gravity-driven, time-dependent, creep, viscoelastoplastic, squeezing. So you would be able to simply identify it, and based on the output of the I system, to put the right response to that ground behavior. Because the source of an issue, for example, in tunneling, is that the response we are giving to the behavior of the ground is inappropriate. That ground acting violently. If the response is appropriate, ground would not act inappropriate. It would be under control and your work would be done. Vibration-induced damage assessment. Unfortunately, it is missed in civil engineering, neglected. Recently, a project from NIOM came to me for review. And it is interesting to say that the granite rock slope is fractured and undergone global failure only because of inappropriate blasting. And it is interesting to know that they had a threshold for the PPV. They were only checking the PPV, but no frequency. No duration of the exposure to vibration, nothing. Due to the same, they have cracked the granite, very hard granite. They created a major deep tension crack, and the slope of the vault is now under question. Project is suspended now for almost 1 year because of this. And this is the importance of the matter. That's why from the beginning, I included it in ISystem. So you would be able to, during your tunneling work, during your slope stabilization work, during your digging for the foundation works, abutment of the dams, foundation of the dam, whatever, you would be able to check what you are doing with the ground. Sometimes people thinking that if they are employing mechanized excavation, everything is safe. Not. Or they may think if they employ jackhammers, oh, it is not blasting, that's okay, vibration is fine. But I give you one example, Tunnel T1 in USBR project, one of the reasons of the failure of the face that led to sometime 20,000 cubic meter of flow of material from the face was the vibration generated by jackhammer. No blasting, jackhammer. So if your excavation technique is manual, if it is mechanized, including scratching by excavator, jackhammer, road header, drum cutter, continuous miner, shearer, or TBM, whatever you are using. Or if you use blasting, including any of these techniques that I have mentioned here, you would be able to assess the condition, and you would be able to control it, and ISystem provides you the mitigation for that also. This is ITM, iSystems tunneling method. It is a tunneling method that is in continuous check with the ground zoning, identification of ground behavior, checking the ground hazard, classification of the ground, characterization of the properties of ground, dimensioning and verification for optimization of the design, and vibration-induced damage check, control, and mitigation. ITM, main and principal assumptions include arch pressure effect at any depth. For ITM, shallow tunneling, deep tunneling has no meaning. As per ITM, at any depth, you have arch pressure, and you can calculate it, so it would not be neglected. Comprehensive application at any ground, controlled release of deformation, flexible contract and management, permanent life for tunnel structure, primary measures as part of final. It is providing you a variable shell. If you are doing mining, you will be choosing which shell to be used. You are doing civil, you will choose which shell to be used. risk analysis and control, and utilization of ground's load-bearing capacity. It is applicable in any medium and under any condition, at pre-design, design, construction, and post-construction during operation. I-System, due to help delivered to the Indian Railway and resolved a 22 years lasting problem of their projects in USBRL. In 2023, protocols for safe timing. My lecture is almost over. I would just browse this part for you. This is the tables that I talked about when you are doing the eye logging. AI, for example, armature index, contains these tables that you just need to pick the parameter from the table and put the parameters in the equation, calculate the index. The same you will be doing with the configuration index. The same you will do with the hydro index. The same for the properties index, that modeling the soil. Same with the strengths index, including the shape, stress condition, in situ stress condition, a scale, and the compressive strengths. You will do the same with the dynamic forces impact and for the excavation technique impact. So your I value is calculated. The tables that I said as output of the I class, I systems classification, is something similar to this. You would be having the range, the I class identified, then you would be having the SS, support system recommended for that class, ET, excavation technique recommended for that class, and IT, instrumentation technique. Also you will get prevention technique, PT, forecast technique, FT, and design remark for your design optimization. This is for underground structures. This is for semi-surface and surface structures. And this is for special classes when you are facing with the burst-prone ground, like rock burst, time-dependent ground, or viscoelastoplastic ground. Even for the surface structures with a special type of ground behavior, like liquefaction. Also, you are not alone when you are advancing at your faces using drill and blast. You would be able to calculate the optimized and safe pull length. This is not conservative, this is not aggressive, this is optimal. And a good estimate of the pull length that you should get out of your face in tunnel. And also you can derive the drilling length, how much hole to be drilled and how through the blasting. Also, as a quick guide to the engineers at site, you would be able to configure your systematic bolting system. I-System does not recommend any system for the I1 to I4, but for I5, 6, 7, 8, 9, and 10, there is recommendations of rock bolting or anchoring or soil nailing. So you would be able to calculate it, I would say configure it here, but after that you need to check it through the analytical analysis. This symposium is hosted by a university. Certainly a lot of students are here, talented students, who may be interested to work on either of these subjects that listed here. And the presentation is also would be available with the organizer. If you are interested, you can go through and work on that. I would be happy to answer your questions if you have any.
Yeah, thank you, Dr. Hose, for a very comprehensive overview of I-System. because many of the complicated projects in India have adopted this I-system and have benefited from this. But my only question is, because it is a system that you have to evaluate and then design and then go forward. So I wonder, within a say a span of 100 meters, how many design changes will be there once, like, so what is your experiences, particularly in India?
This is the design procedure as you move ahead. So it's up to your pull length, safe pull length that you are getting. After every pull length, you will be doing eye-logging, that face mapping, and you will check the value. If you are sitting still in the same class, you don't need to change anything, just go ahead. But if, after your assessment, you are observing that ground is changed, so you need to take action. And the actions would be given to you A to Z. No judgment.
But you need, I think, a team of professionals for evaluating this, because it involves so many people like geologists, geophysicists, and so many other people. So a whole lot of people will be sitting at this site along with the designers. Then only system can move forward. So that is.
It's a beautiful question. I'm happy that this question is asked. The first part, in the perception and the consideration in the beginning of the development, I considered that those gaps that comes between the geologists, engineers, geophysicists to be eliminated. So very simple, understandable, basic parameters are considered. So no very special, for example, resistivity geophysicist or seismic geophysicist, no, nothing. The parameters VP and VS, every engineer and every geologist knows. About the ground parameters that considered here, it was intentionally considered because I myself started my work in the hydropower project. And I was facing that when people going there for classification, 2 geologists, 3 geologists going there, coming back with 3 value. Right, not with a single value. Because, and everyone, when you were talking with them, they had enough reason that their value is right, right? I took those points and I eliminated it, right? So it's confusion free. So if you send 5 geologists also, they will come with the same class, not jumping with the class. And also the range is very logical. Is not going to change in by .001 or by 100, right? It is changing in a very meaningful mathematical form. So no special people. A junior geologist or a junior a civil engineer or mining engineer can do the job. And the thing is that I eliminated the judgment from the process. So none of the parameters need judgment.
Okay. And what about the implementation part? Like even the contractors will also be equally stressed because they have to be prepared for all kinds of the support systems or whatever it is there.
Yeah.
So for all types of this one, they have to be ready. So what is their response as far as your experience is concerned in?
Excellent. As you see that when I was talking about the IGI, I said that a schedule of quantities and bill of quantities would be given by I-system. And when you are so a schedule of quantities and bill of quantities is given to you. In advance, the contract will be prepared based on the schedule of quantities. No non-scheduled item would be generated. No fight between the contractor and the client, consultant and the contractor, consultant and the client, that I need this measure, but they say that no, it is not provisioned, right? No. All of the, because it is doing the classification along the alignment for every meter, and all of the measures is given. So those measures is there. And as you are prepared in advance, you would not be surprised. You know that at which change, which type of ground behavior you are going to be faced with. and what is the ground quality, and what is the drawing number. Because for each individual class, a drawing would be given, right? So you are safe, not confused, and moving safely. Please. Actually, I should just add one thing. Sir is from NIRM. I'm glad to say that NIRM, in the review of one of the projects, very tricky and very important projects in Goa, they were asked to review, and they recommended iSystem along with ITM to be used. I'm glad. Thank you very much.
Thank you, Dr.
It's the first time I see this.
I think one or two questions we can quickly have it.
Yeah.
Yeah,
Please.
can you say any instance
Yeah.
where IGI is not in agreement with the verified borehole?
Oh, okay.
Do you have any instance like that?
Yes. The very perfect instance for that is the Tunnel 01. I think L&T was in that project, and L&T has done the electrical and mechanical work of Tunnel T1. The geological profiles prepared through the geotechnical drilling was, I can say that 95% mismatch. 95%. None of those materials that seen in the profile was observed, and no behavior that was expected encountered, right? IGI is conducted in the month of February 2022, after 20 years of unsuccessful excavation, after 20 years. Indian Railway decided to switch to iSystem and ITM. In the February 2022, work was given to Amberg Engineering. They started to do the IGI and design in 1 month, and they submitted the design in the March 2022. Design gone under review by Northern Railway and KRCL for almost 1 month. And around the 1st or 5th May 2025, they accepted and they started the work. 97% of IGI profile was matching with the condition that they encountered. And the reason is that, not only through this, you may have heard about TSP, Tunnel Seismic Prediction. A company in Switzerland, they have integrated the TSP with iSystem. Means that even they do the geophysical survey, they will tell you what is the ground class, what is the ground properties in terms of mechanical properties.
Yeah, I was asking, is there any instance where you didn't have an agreement?
In IGI, yeah. Of course, I said that 97% was the profile, right? Or for tunnel T13, which was around 10 kilometers, the agreement between the IGI anticipated and encountered was around 10% mismatch, 90% matching, and it was 10 kilometers tunnel. And interestingly, no failure, and it was full squeezing ground in 10 kilometers, 9.6 kilometers, right? So I believe 10%, 5% is acceptable.
Yeah. Thank you, Dr. Hose. I think people can continue discussion during tea time. So now it is time to give time to our youngsters. There are 3 papers. I request our co-chair, Sri V.M. Galande sir, to take it forward.
Thank you, sir. The next paper is on the design of characteristics of tunneling steps towards sustainability and productivity, to be presented by Ax Malik, I believe.
5 to 6 minutes.
Your time limit is 5 minutes.
I think I should, just begin and end. Hi everyone, I am Akas Malik from L&T Heavy Civil, and this topic on design optimizations in tunneling, I think it will touch a little bit upon what already we have been discussing, and this is just one of the concepts that we have internally worked and developed with Dr. Raju, and it brings towards how we can adopt certain measures. So I'll just begin with some statement on the optimization and sustainability, that they are quite linked. There are a lot of parameters that goes into the optimizations. We need to have the right investigation methods. We need to have right design philosophies and right usage, as well as furtherance of the codes, and the analysis techniques also have to be appropriate. Then we can explore any other alternate approaches also. So I am going to focus a little bit on the design philosophy part itself here, and in the optimization that I am telling here, I want you to understand that we need to answer the whats and whys more than the hows, because now with the development of AI, the procedures and all the things can be very easily developed. How to do something can be easily done, but what and why we are doing is more important. So I will go a little quickly in my presentation, because I thought we had 8 to 10 minutes, but I have half the time. So the first part was the investigation that I cannot miss, because if we don't have the right investigation, the right characterization of the rock mass or the geology that we are dealing with, the universe that we is dealing with, and it has to be right representative, samples have to be collective, right testing have to be done, and what kind of parameters we actually need, that have to be identified more and more to reduce the uncertainties. And that is what we fear most in our all design planning, is the underrepresentation. So that's will start with this, but what I want to focus more is on the design philosophy part, and choosing the right philosophies also. So I am going to brief you. I think this, we are all in agreement. I am not deviating from anything. Everything for me is same, all systems, whether it is NATM, NMT, I system, because they are all dealing with the basic fundamentals are the mobilization of the ground strength itself, the stress distribution part in the ground, and how the ground itself is the primary self-supporting structural element. That is the core, that is the fundamental. And if we see, this is one of, I am not saying this is from the NATM guideline, very old, that NATM also, the method that is very much used in India in many of the contracts, it is a mandatory concept. It is also based on a concept where the ground or underground opening becomes a load-bearing structural element. So based on this, we are suggesting that we apply that one of the support system, which is a rock bolt, and rock bolts are helping the rock mass to be reinforced further and helping in the arching effect. And in that there have been studies that rock bolts do take certain amount of load, and some of the load, this is one of the research in that some portion only fell down. So that has to be further supported by other support systems. And we need to avoid both over support as well as under support. So this particular application of the concept is more on the type of failures which are controlled by wedge failures, and where rock bolts are the main supporting elements in the type of ground behavior. When we, in the stage of design, we identify the ground behaviors. In L&T, our reports, we define all the ground behaviors in our report. So in the initial stage itself, we can choose this. So we develop some ground reaction curves also to understand that where this concept can be applied. So what we are suggesting is replacing temporary bolts with a permanent bolt. And this is has been proven already. A lot of bolts are there in the market which have 100+ years life. We just need to have the right quality assurance and the right quality control. They have coating materials. We have epoxy coating, we have sleeves, and then multiple corrosion resistance coating, and it can be developed the 100+ years life. And even recently there has been a development of code also on the application of permanent reinforcement. Now using this, we have done an analysis and check, and when we are sharing this load with our final lining, that is like mandatory requirement in the NATM system, in that we identified and we found out that we can reduce our lining thickness, which earlier was 400 to 250. So whatever slightly increase in the cost of the bolts, that can be offset. And then we have further checked it with the replacement of rebars with the fibers. And with these, actually what I am talking on this main part is the sustainability element. We come to that, and significant savings on the carbon footprint. If you see, more than 57% in just this case we are able to achieve. So I think I'm rushed quickly, and just for the conclusion, this was a concept, and we may have different understandings on the philosophies, but the fundamentals, they remain the same. And the rock bolts, they can be designed as temporary, permanent. It's on us as a designer, we can choose, but the right quality and right testing has to be done. And still more research can be done on not just on the wedge type failures, other type of rock mass also. How much is that percentage load sharing that our researchers here can work on, identify whether it is 25%, 30, 40, 50, up to 80, depends on that. And then optimized designs results in significant carbon footprint savings. There are many other optimization possibilities also that we can do. So 1 more minute, I'll just added few slides. This is further suggestions on the factor of safeties also. I think we need to, there are some misconceptions on that too, that how the rock bolts are failing. So the factor of safety needs to also be revisited. So this is our suggestion, that it should be defined based on the yielding criteria also, because even if they are standing and they are yielded, it does not mean they are not functioning. And then this concept lies somewhere in this category. If we see the benefit, the value addition that we are suggesting, and the behavioral change, we don't want, it doesn't require much changes. You are doing the same activities, you are doing the same procedures you are following. So this is a high value addition, but with a low behavioral change. But a lot of technologies, a lot of concepts, they are more in the stage where they ask us to change our behavior, our processes, our system. So it will take time for them to come into picture. But we should not simply ignore them also. And so these are some of the others. So I will quickly rush through this. We are focusing as of now in this presentation on the permanent itself, but there are many other scopes we can achieve. So just I will conclude, and I say that small changes can bring big differences, and with positive collaborative efforts. Thank you.
Thank you, Mr. Malik. Any questions? No questions? Thank you.
Yeah.
The next paper is on ground improvement using cement grouted columns to control ground displacement at a tunnel portal. Presented by Sagar Mala. Yes. Please come.
Good afternoon, everyone. Myself, Sai Raju from L&T Heavy Civil Infra. I am privileged to present my paper on ground improvement using cement grouted columns to control the ground displacement at tunnel portals. First of all, I would like to thank L&T management for giving this opportunity. In this, I walk through major 6 sections: introduction, site characterization, ground improvement, numerical modeling, results and conclusions. To start with introduction, tunneling in shallow overburdens will poses some geotechnical challenges. Majorly, if the cover is soil, one of the major challenges excessive ground displacements. So these excessive ground displacement can lead to the structural instability, construction issues, and long-term operational risks of the tunnel. So in this project, we have the permissible limit of 40 mm, but initial analysis shows the more than 40 mm. So to reduce the displacement, a ground improvement, we propose a ground improvement through cement grouted columns. So coming to the site characterization, tunnel size is 14.5 meters width and 11.5 meters height with horseshoe shape. Overburden at portal is only 3.3 mm. 3.3 meters. So the project is located in the mountainous terrain with a consolidated and semi-consolidated overburden. Portal area has a moderate to steep slope with dense vegetation. So the rock mass exposed is basaltic tuff. To understand the comprehensive subsurface characterization, we performed the borehole. The borehole reveals the stratification of gravel of 8 meters, then clay of 4 meters, then a sand and the rock mass. So the soil parameters, shear strength parameters of soil are derived from triaxial test, and the rock mass parameters are derived using GS and UCS. And the soil is modeled as a Moore Coulomb criterion in numerical modeling, and rock mass is modeled using generalized Dukan parameters. These are the parameters used for analysis. So coming to ground improvement, the ground improvement we proposed is cement grouted columns of dia 100 mm with a length of 9 meters, which is 1 meter more than the gravel layer, with a spacing of 1 meters in staggered manner. The minimum grout strength we proposed is 15 MPa. The ground improvement is proposed to extent of 32 meters width and 25 meters along the length of the tunnel. Execution, first the 100 mm borehole should be drilled, and then the grout should be injected at a low pressure of 1 MPa with a water cement ratio of 0.4 to 0.5. Then grouting will start from bottom to up with 1 meter steps. Then to check the effectiveness of the proposed ground improvement, monitoring is proposed through ground settlement markers. These ground settlement markers should be checked daily, and this can be adjusted as per the site needs. So for the numerical modeling, the ground improvement, the proposed ground improvement is modeled using equivalent properties, using the area replacement ratio. So you can see that the modulus of velocity has been increased from 50 to 196 MPa, and there is no change in internal friction. Then the result shows before the ground improvement, the surface settlement was 50 mm, which is more than the project permissible limits. So after the ground improvement techniques, the settlements reduced to 33 mm. There was a reduction of 35%. Then in this geological condition, the support system we proposed is 300 mm shotcrete with steel ribs, that is ISMB 250 at 500 mm center to center spacing. Before and after the ground improvement, the support capacity was checked with support capacity plots in RS2. Which shows the support system proposed is adequate, and the stress distribution around the tunnel was uniform. There was no major stress concentrations, and the strength factor around the tunnel is more than 1, indicating a stable tunnel excavation. To summarize, the provided support system of 300 mm shotcrete and ISMB 250 at 500 mm spacing is adequate for the anticipated ground conditions. Numerical analysis confirms the support system plots for the shotcrete and steel ribs within the permissible limit throughout the excavation stages. The introduction of cement grouted columns resulted in a reduction of surface settlement by 35%, that is from 50 mm to 33 mm. The improved ground is achieved with low pressure staged grouting with no disturbance to the surrounding soil, and the stress distribution and the stage factor around the tunnel periphery is greater than 1 with overall stability and excavation. Thus I conclude my presentation. Once again, I would like to thank my organization for giving this opportunity and constant encouragement and support. Thank you.
Any questions? Schemes for TBM breakthrough in deep clay under backfill pond conditions, a case study. Optimization of ground improvement scheme for TBM breakthrough in deep clay under backfill pond conditions, a case study, to be presented by
Good afternoon, everyone present here. My name is Soumya VS. I am from L&T Construction Heavy Civil Infrastructure. So the topic of my paper is Optimized Ground Improvement Scheme for TBM Breakthrough in Deep Clay Under Backfill Pond Condition. So this is based on a real case study wherein we initially proposed a ground improvement based on a rational guideline-based approach. Later, we based on the construction-led performance-based strategy, we revised it. So I just quickly go through it. So before going into the case study, so TBM launching can be done in various methods, especially for underground metro tunnels. TBM launch, a vertical shaft will be constructed through which TBM will be launched. So the launching is nothing but positioning, assembling, and then starting the tunnel construction. So if it is shallow overburden, it can be done through portal, but we need to have sufficient space on both sides. So when we are launching the TBM through shaft, sometimes soft eye will be used, wherein GFRP panels will be used as a compromised weakened zone so that the TBM can easily cut through it. So what will happen when the TBM launching happening below the ground? So first there will be stress redistribution and the soil will start moving towards the voids. So next, initially there was confinement by the D-wall or secant pile wall, whatever launch is made of. Since now it is broken, the phase stability issues will happen. And also, since there are some loss of soil, volume loss will happen, and which will lead to ground settlements and subsidence. So if it is a water-prone area, water inflow, water-bearing soils, water inflow may also take place. So because of all these stress distribution and pore pressure increase, definitely there will be reduction in the shear strength. And lastly, whatever structures, the ground structure interaction, if we see, so the launching shaft wall, the TBM, the shaft temporary supports and the soft eye, all those things will be subjected to cracks and deformations. So if there is a problem, there is always a solution. So to avoid such problems, we generally go for ground improvement. And if due to phase instability issues, we apply phase pressures. But unfortunately, during the TBM launching, we may not be able to apply full phase pressure because it may damage the D-wall or the shaft wall. And also, to prevent the volume loss or the leakage, we go for tail void grouting. And then to prevent the water seepage, we will go for cut-off walls, ground improvement by cut-off walls. And sometimes the rate of penetration of TBM will also affect the shear strength. So it is suggested that to go ahead with the slow rate. And then continuous monitoring and continuous monitoring of all the instruments that are in place. So as per literature, several launching methods are available. Ground improvement for several launching and retrieval methods are available. So all of them states that the ground can be either improved by injecting the grouting or stabilization, or you can make a cut-off wall or breakable structure so that the TBM launch can happen. And how? What is the extent of the ground improvement? So some literature says the extent can be the length of shield plus 2 rings or 1 rings for TBM launch and retrieval. So can the design be verified? Actually, most of the literatures are silent on this, but we come across one literature on Japanese Jet Grouting Association, wherein they, for the jet grouted ground improvement zone, they have derived some design checks. The design checks involves checking the two criteria. One is improvement length and the improvement section. So they will assume a target strength of the ground improvement zone, and then the length will be verified based on the bending stress, punching shear, and the arch sliding caused by the in-situ soil and water. So for the lateral extension of dimension, BSI standards have given minimum dimensions. However, the top width, side width has to be designed by assuming the plastic region and the radius of plastic region and the angle of inclination of the plastic region. So now coming to the case study, our case study has a launching shaft of 39 meter by 22 meter. It's the shaft was constructed by bottom-up approach with 4 level of temporary studs and 2 permanent slabs, and it's a twin tunnel of 5.8 meter internal diameter. So the groundwater table is 2.5 meter below ground level, and it is completely clay strata with varying SPT N ranging from N and linearly increasing. And the silt contents were on a higher side, 60 to 100%, 90%, and clay content 10 to 50% throughout the depth, and sand content was less than 10%. So as per the plasticity chart, it came around, the soil type comes under CL or CH range, and this is the design soil parameters. So by reviewing the ground conditions and groundwater conditions, we initially proposed 3 options: jet grouting, tam grouting, and soft piles or touch piles. So jet grouting is the best option as a designer, but however during execution, since the area is very small and also it requires specialized person in this, so we eliminated that, and then we thought tam grouting is possible or not. But since the water table is on a higher side, the complete cutoff may not be feasible, so we proposed with soft or touch piles. So it is nothing but the concrete piles of grade M5 or M10 grade, and then it will be overlapping so that it forms a cutoff. And though there is no direct design guidelines for ground improvement, we adopted this JGA guidelines and estimated the length, width and height of the ground improvement. And this is what the initially proposed ground improvement, which came around 184 numbers of soft piles. And later, as I said, based on the performance and the observation-led methodology, during the shaft excavation, up to 4 level of excavation, we did not see any water. So there was minimal to no water seepage during the excavation. And before going to the operational parameter, then we discussed with the operation team any feasibility of reducing the proposed ground improvement scheme. So just for people who are new to TBM, so EPB is nothing but earth pressure balancing TBM, wherein whatever excavated soil will be placed in this mixing chamber along with some conditioning agent, and that itself will provide some pressure for phase stability. So it can be operated in 3 modes: closed, transition and open mode. So closed means if it is very weak, soil plus water is there, then we have to go for closed mode. If it is moderately stable ground, then we can go for transition. And if there is no water at all and soil is competent, we can go with open mode. That means no pressure at all can be applied. So then we came up with this revised scheme, wherein the piles which are in between the twin tubes we eliminated, and then we made an unimprovement zone into it, so that any settlement, if it happens, it happens within this box itself. And then this piles will act as a cutoff wall. So how to verify this? We go ahead with the numerical simulation using Plaxis 2D, which is based on finite element approach. So first we carried out the actual tunnel launching, TBM launching in Plaxis 2D. We also discussed simultaneously with the operation parameters what is the range of chamber pressure can be applied. So then we all unanimously, operation team and the design team unanimously came to a conclusion that here this stratum is somewhat competent, and there we can go for open or transition zone, and this zone is not competent, and we applied the chamber pressure with full chamber pressure. So like that, the same chamber pressure from open to partial zone to closed zone, the same thing we applied in the numerical analysis, and we come to know the vertical displacements and the ground movements were within the limits of as per the contractual requirements. And also independently we did some groundwater seepage analysis, so that unimproved zone here, it may, so what if the water from the shaft excavation, if there is sudden recharge happens, so what is the amount of discharge will happen? So we carried out another independent groundwater seepage analysis, and that results are also within the limits. So with this construction observation based performance strategy, we were able to optimize 96 numbers. Initially it was 184 with this 50% reduction in the ground improvement piles we were able to achieve. So with this, I would like to conclude on the initial ground improvement scheme proportion, which is based on full replacement. Though there are guideline-based approaches there, we can still adopt this Japanese guidelines and we can verify the length and width and other lateral dimensions of the ground improvement zone, which is subjective to case-to-case basis. And this rational method can be applied to similar soft soil bearing soils where the water table is also an issue. And this revised scheme, I would like to add that though we had the whatever initially proposed scheme was well approved, during the construction stage, if there is any deviation from the groundwater or ground, there is still some opportunity for optimization. So this revised ground improvement scheme is an indication that performance-based and observation-led design methodology unanimously, by combining the design verification, design guidelines along with the operational parameters, will lead to a lot of optimization and innovation. Thank you everyone for your patience, and I thank L&T management for giving me this opportunity. Thank you so much.
Thank you for your presentation. Now, since we have no time, no questions will be there. Any questions to be asked, they will be in the break time. Thank you.
Yeah, we have come to the end of this session. So we had a very good presentation by Dr. Raju and Dr. Hose. That took a major share of the time, but the young presenters were able to manage with the given time the three different aspects of design optimization in tunneling and ground improvement using cement coated columns to ground control, and optimized ground improvement scheme of TBM breakthrough in deep clay. See, all these three papers have a very practical relevance, so that is a good part of these presentations. And I'm sure all of you would have got benefited by the presentations that have taken place during this session. So with this, I hand over to the presenters.
Thank you, sir. So now I would like to call our session chair and co-chair to come forward for the felicitation of the all presenter. Sir, please. Session chairman and session co-chair. So our first presenter is Mr. Malik. Please come forward for the felicitation. Next is Mr. Tupala Sai Raju. Please come forward. Is Soumya VS. Thank you, session chair, session co-chair. Now I would like to call Dr. Sumit Mohanto to felicitate our first keynote speaker, Dr. G.D. Raju, on behalf of Sri K. Sindhilathan. Now I would like to call Dr. Nikhil Sardesai to felicitate Dr. Venetian Hoss. Thank you, sir. Now I request our chairman, Dr. Shripad Nayak, sir, to come forward. And I request Professor Yerpude, sir, to felicitate our session chair, Dr. Shripad Nayak. Thank you, sir. Now I request Dr. V.M. Galate, sir, to come forward. And I request Dr. Sumit Mohanto to come forward for felicitation of Dr. V.M. Galate. So with this, the session is closed here, and it was really enlightening in the area of tunneling and excavation. And I request there will be a tea break, so I request all to finish the tea within 5 to 10 minutes because we are already running out of time. We are running 1 hour late. Okay, thank you all.
Thank you, sir. One more announcement. Again, I am honored to invite all of you for the dinner tonight at the same venue. Please, all of you, please join us for a dinner, okay, in the evening after 7:30 p.m. Thank you.
Yeah, yes.
If everything is okay.
One second.
Yeah, those are two of the papers are coal mining related. Yeah. I'm actually the other ones, yeah. And the last paper
Every industry presents unique challenges that demand smart, agile, and efficient solutions. At Solar Technical Services, we don't just provide products. We deliver expertise, innovation, and precision-engineered solutions tailored to your specific needs. From mining to infrastructure development, our expertise extends across multiple sectors, ensuring seamless operations, optimized performance, presents unique challenges that demand smart, agile, and efficient solutions. At Every industry presents unique challenges that demand smart, agile, and efficient solutions. At Solar Technical Services, we don't just provide products. We deliver expertise, innovation, and precision-engineered solutions tailored to your specific needs. From mining to infrastructure development, our expertise extends across multiple sectors, ensuring seamless operations, optimized performance, and sustainable results.
It gives me great pleasure to inform you that Solar is now providing customized blasting services to many of our customers who require specialized blasting requirement. This we do it by providing fit-for-purpose product and making available skilled resources. Solar takes full responsibility of all operation and safety and management of the blasting services. We strive to achieve a safe, efficient, and consistent blasting, which is the strength of our team.
At Solar Technical Services, we don't just provide solutions. We optimize, refine, and enhance operations for maximum safety, efficiency, and sustainability across mining, construction, and infrastructure industries. Blast optimization, engineered for maximum impact with minimal disruption. Efficient fragmentation means lower costs and higher productivity. Optimizing resources for long-term efficiency, minimizing environmental impact while maximizing productivity. Backbreak and overbreak management. Controlled blasting techniques to reduce material wastage, enhancing structural stability and improving cost efficiency. Vibration management services. Cutting-edge technology to monitor and control ground vibrations, ensuring the safety of nearby structures and communities. Fragmentation prediction and analysis. Advanced modeling and data-driven solutions for precise fragmentation and improved material handling. Operational costing solutions. A meticulous approach to boosting productivity while maintaining cost efficiency. Every industry presents unique challenges that demand smart, agile, and efficient solutions. At Solar Technical Services, we don't just provide products. We deliver expertise, innovation, and precision-engineered solutions tailored to your specific needs. From mining to infrastructure development, our expertise extends across multiple sectors, ensuring seamless operations, optimized performance, and sustainable results.
It gives me great pleasure to inform you that Solar is now providing customized blasting services to many of our customers who require specialized blasting requirement. This we do it by providing fit for purpose product and making available skilled resources. Solar takes full responsibility of all operation and safety and management of the blasting services. We strive to achieve a safe, efficient and consistent blasting, which is the strength of our team.
At Solar Technical Services, we don't just provide solutions. We optimize, refine, and enhance operations for maximum safety, efficiency, and sustainability across mining, construction, and infrastructure industries. Blast optimization, engineered for maximum impact with minimal disruption. Efficient fragmentation means lower costs and higher productivity. Optimizing resources for long-term efficiency, minimizing environmental impact while maximizing productivity. Backbreak and overbreak management. Controlled blasting techniques to reduce material wastage, enhancing structural stability and improving cost efficiency. Vibration management services. Cutting-edge technology to monitor and control ground vibrations, ensuring the safety of nearby structures and communities. Fragmentation prediction and analysis. Advanced modeling and data-driven solutions for precise fragmentation and improved material handling. Operational costing solutions, a meticulous approach to boosting productivity while maintaining cost efficiency, ensuring every project stays within the budget. Our expertise has powered some of the
Whether you have asked question to the keynote or not, are you asking that thing, sir? Yes, sir. Yes, sir. Yes, sir. You have to give the time. Generally, sir, depending on lecture, you can take 2 questions, max to max, for the keynotes, these lectures. Yes, sir. Yes, sir. Because it's left. Sometimes, usually, one question, anyone if asked one question, then after he follows another question, same person. So then you have to cut down after the second question. You have not consider, you don't have to consider 2 persons for 2 questions. If same person is asking 2 questions, then you have to cut down the question. Yes, sir. Paper ID is given here. So you have to fill up the paper ID and presenter name. So all the information is given here. Paper ID and the presenter name. First name. Yes. Yes, sir. The only first name which is mentioned, he will present the paper. Yeah. So you have to write down the first name. This is my name. Yes, sir. This is yours name. And yes, sir. Okay.
Every industry presents unique challenges that demand smart, agile, and efficient solutions. At Solar Technical Services, we don't just provide products. We deliver expertise, innovation, and precision engineered solutions tailored to your specific needs. From mining to infrastructure development, our Every industry presents unique challenges that demand smart, agile, and efficient solutions. At Solar Technical Services, we don't just provide products. We deliver expertise, innovation, and precision engineered solutions tailored to your specific needs. From mining to infrastructure development, our expertise extends across multiple sectors, ensuring seamless operations, optimized performance, and sustainable results.
It gives me great pleasure to inform you that Solar is now providing customized blasting services to many of our customers who require specialized blasting requirement. This we do it by providing fit-for-purpose product and making available skilled resources. Solar takes full responsibility of all operation and safety and management of the blasting services. We strive to achieve a safe, efficient, and consistent blasting, which is the strength of our team.
At Solar Technical Services, we don't just provide solutions. We optimize, refine, and enhance operations for maximum safety, efficiency, and sustainability across mining, construction, and infrastructure industries. Blast optimization, engineered for maximum impact with minimal disruption. Efficient fragmentation means lower costs and higher productivity. optimizing resources for long-term efficiency, minimizing environmental impact while maximizing productivity. Backbreak and overbreak management. Controlled blasting techniques to reduce material wastage, enhancing structural stability and improving cost efficiency. Vibration management services. Cutting-edge technology to monitor and control ground vibrations, ensuring the safety of nearby structures and communities. Fragmentation prediction and analysis. Advanced modeling and data-driven solutions for precise fragmentation and improved material handling. Operational costing solutions. A meticulous approach to boosting productivity while maintaining cost efficiency, ensuring every project stays within the budget. Our expertise has powered some of the most demanding projects across industries, including coal mining operations, enhancing extraction efficiency and safety, NTPC PB mine, optimizing blasting for large-scale energy operation, limestone extraction, precision solutions for cement and construction industries, metal mining, infrastructure mega projects, contributing to nation-building endeavors. Raj Infra and Mumbai-Pune Expressway, pioneering controlled blasting solutions. Jayakwadi Dam and Shahpur Railway Blast, ensuring safety and precision in critical engineering projects. With a presence in 82 countries and over 6 lakh metric tons of explosives delivered by FY24. Solar Technical Services is a trusted partner in blasting and technical excellence. Solar Technical Services, expert solutions with the power to propel.
Solar Industries India, electronic control block, the system से पचपन हजार एमपी का ब्लास्टिंग किया और उसने अपने काम पूरा 2.5 महीने में इसने करके अच्छा तरीके से हमको कैमरा कर दिया.
सोलार में इलेक्ट्रॉनिक डिटेक्टर यूज करके हम लोग ब्लास्ट किया. Each hole individual plastic करते इसलिए वाइब्रेशन थोड़ा कम आ जाएगा. नियरेस्ट हाउसेस गोडाउन्स पे हम लोग वो किसी को डिस्टर्ब नहीं करना है, इसलिए स्पेशली सोलार को यूज कर रहे हैं.
जब चट्टानें रास्ता रोकती हैं, तब तकनीक रास्ता बनाती है, और जब अनुभव, अनुशासन और नवाचार एक साथ आते हैं, तो जन्म लेती है उत्कृष्ट इंजीनियरिंग. रॉकटेक इंजीनियरिंग प्राइवेट लिमिटेड इस वर्ष अपनी सिल्वर जुबली मना रहा है. पिछले 25 वर्षों का ये सफर सिर्फ समय का नहीं, बल्कि विश्वसनीयता, गुणवत्ता और तकनीकी परिपक्वता का सफर है. इस यात्रा में रॉकटेक ने न केवल तकनीकी दक्षता हासिल की, बल्कि स्वयं को एक भरोसेमंद और प्रतिष्ठित इंजीनियरिंग कंपनी के रूप में स्थापित किया है. रॉकटेक इंजीनियरिंग मुख्य रूप से कंट्रोल ब्लास्टिंग और रॉक एक्सकेवेशन के क्षेत्र में कार्यरत है. इसके साथ साथ कंपनी खनन क्षेत्र में कंसल्टेंसी और तकनीकी परामर्श सेवाएं भी प्रदान करती है. सरफेस और अंडरग्राउंड माइनिंग से लेकर अर्बन डेवलपमेंट जैसे अत्यंत संवेदनशील और जटिल प्रोजेक्ट्स तक मेट्रो स्टेशंस का निर्माण
Good evening, ladies and gentlemen. We are starting our final session of the day in few moments only. Request all of you to please take your seats. Thank you. Today, in the final session, technical session of the day one of this international symposium, we have the privilege of distinguished speakers, session chairmen, and presenters. The theme of this session is cyber physical systems, and we have 5 papers to present, and we are already running quite a lot late, so trying to start this session as early as possible. So requesting Dr. Daniel Lopez to please come here and join us as the chairman of this session. I am requesting Dr. G.D. Raju to please assist Dr. Daniel as co-chairman of this session. In this session, we are privileged to have with us Dr. H. Sebnam Duzgun. She is a full professor, Fred Banfield Distinguished Chair and Associate Department Head of Mining Engineering at Colorado School of Mines. She also has a joint appointment in the Department of Computer Science. She also serves as Associate Director of GIS and Geoinformatics Program, and she coordinates the Geoscience section of Data Science Program at the Mines Global Future Initiative. Dr. Duzgun has been awarded the Experienced Researcher Grant by the Alexander von Humboldt Foundation to conduct research at the Geophysical Institute in Germany before joining as a faculty in Colorado School of Mines. With over 25 years of research, teaching, consulting experience, Dr. Duzgun is internationally recognized for her work in AI-driven mineral and geothermal exploration, geospatial analytics, mineral supply chains, and decarbonization, net zero carbon strategies. She has 11 books in her name, 90 journal articles, more than 200 conference papers. We are truly honored to have her here in our symposium. Big round of applause for her. I request Dr. Yogesh Kale, the next keynote speaker, to come here. He's already here. I will introduce you, all of you, Dr. Yogesh Kale. He is currently working as a Chief Control of Mines in Indian Bureau of Mines, which is a central government organization under the Ministry of Mines. And after obtaining his bachelor degree in mining engineering, he has obtained master's and PhD from our own Vishweshwarya National Institute of Technology. And he also holds a master's degree in business administration from IIM Nagpur, and diploma in industrial pollution and control, and postgraduate diploma in mineral exploration, mine geology, operations management, and environmental economics. He has more than 36 years of experience, and Dr. Kale has authored more than 55 technical papers in various peer-reviewed journals related to mining, mine environment, mine mineral conservations. He is a fellow of Institution of Engineers, life member of Mining, Geology and Metallurgical Institute of India, Mining Engineers Association of India, Indian Science Congress, and many more societies. So ladies and gentlemen, I request Shabnam ma'am to please join here. We'll start the session. I request Dr. Ajay Kumar Agrawal sir to please welcome our session chair, Dr. Danny Daniel, with a floral bouquet. I request Dr. Nachiket Bhagade to welcome our co-chairman, Dr. G.D. Raju. I request Dr. Yedpude to please come forward and welcome Dr. H. Sebnam Dusgun, our keynote speaker for this session. I request Dr. Nilesh Pratap Singh to come forward and welcome our second keynote speaker, Dr. Y.G. Kale. So please. Thank you, sir. And now I hand over the control to our session chairman, Dr. Danny Daniel. Thank you.
Okay, the beginning of this session about civil physical system. Then it's a pleasure for me to be here with you from Colombia. The first one is about predictive AI system for autonomous underground mining operations. And please, teacher, come to hear Sebnam Dusgun about this presentation.
She has already downloaded here.
Here?
No, I didn't see that. No, she did it in front of me.
Didn't you copy it?
No. No, it is not there.
Oh, okay. My presentation is not ready. In the meantime,
You should have copied, no? I had many seconds.
AI asked me to select between vegetarian and chicken, and the other AI probably knows what my preference. Sorry, I thought that my presentation is copied, so I don't know where did I put. Do you mind if I connect my computer? It's easier for me. Because I cannot find the flash disk that I gave you. Yeah, please, yeah, okay. So you're gonna wait a bit more for AI, but in the meantime, I'm gonna ask how many of you have not used ChatGPT? Okay, we're in good stage. I'll continue while you are preparing for my presentation. Okay.
Yeah, sorry for this glitch. I invite Dr. Yogesh Kale to present here the keynote address here.
Very good evening to all. I know it's from the morning session you are listening to all technical sessions, and it is very difficult time to again receive technical inputs. but I will try my best. The topic of my paper is mineral policy in India, what are the issues and challenges. I am working in Indian Bureau of Mines, which is a subordinate department of the Ministry of Mines, Government of India, and we are responsible for the regulation of mineral industry in India. Yeah. So before going to main topic, just I would like to highlight about what is the position of India at present. You know that India is emerging as a very economic power. At present, it has $4.3 trillion GDP, and just now it has crossed from 5th position to 4th largest economy in the world. And it is the fastest growing economy in the world with 7.4% GDP growth in 25-26. It is a strong digital economy, and it is, you will wonder that 49% of the world digital transactions are being held in India through UPI. It is a key globalized partner in the world, having foreign trade of over $1.744 trillion in 24-25, which includes all merchandise and service sectors. And it is also export value is of more than 825 billion in just concluded last year. We are moving towards a 5 trillion economy. As yesterday's in inaugural session, many of the speakers spoke about the Viksit Bharat. By 2047, we are going to declare as a developed nation. We have strong external sector, having more than 701. Just now, its figure has crossed $735 billion foreign exchange. We have the largest remittance, and the strong points that we have the 2/3 of the India's population less than 35 years, a very young population. Average age in Indian population is 29 years. We have largest middle class population, having large market base, more than 1.4 billion mobile users in India, next to China, it is second largest. As I have already told, it is the 4th largest economy in the world at present. As far as the area is concerned, it is the 7th largest country. We have more than 20% of forest cover and 20% home to 5th world's youth population. And you all know that we have the federal constitution having 28 states, 8 union territories, and more than 768 districts. So this is, with this background, with this setting a tone, now coming to the Indian mining industry at a glance, I can show that this is the map of India. We have 3.2 million square kilometer geographical area, and out of which the Geological Survey of India has identified 0.7 million square kilometer area as obvious geological potential, that is we call as a OGP. And out of this OGP, only 30% of the area has been so far explored, so up to G4 level. So that means there is a lot of scope for further exploration up to G3 level, G2 level, and G1 level. So there is a lot of potential for mineral exploration in India, and we are yet to identify our mineral potential. As far as mining sector is concerned, it is contributing about 2 to 2.5% of the GDP. The gross value added during 23-24 was rupees 0.3 million crore, and we are mining more than 95 types of minerals, which include fuel minerals, atomic minerals, many of the metallic minerals, non-metallic minerals. And if you see that in non-coal sector we have around 3,000 working mines, mining leases, and at the same time in coal sector also we have more than 400 coal mines, and this industry is catering to more than 12 million population, giving the employment. As I told that we are mining 95 types of mineral, which includes 4 types of mineral like coal, lignite, and etc. 10 metallic minerals we are mining at present, 3 atomic minerals, and 23 non-metallic minerals like limestone, dolomite, and etc. And the largest 55 types of minor minerals, which includes mainly catering to the construction industry. So this all includes about 95 types of minerals we are mining at present. If you see that the gross value addition contribution to mining sector during the last 6 years, it is constantly increasing except for the year 2021, which was impacted due to the COVID outbreak. But since then, with the exception of 2021, the gross value additions is on the increasing trend in India. If you see the value of export and imports of minerals from India, you can see the export is more or less constant, but we are heavily depending on import, and especially the oil and natural gas. We are heavily depending on these minerals. So if you see the minerals sector, we are in the minus side if you consider the total EXIM trend. As far as sufficiency of minerals is concerned, this can be categorized as a metallic minerals. If you see, we have abundant iron ore, chromite, but we are very scarce the lithium, the critical minerals like lithium, nickel, tungsten, cobalt, molybdenum, etc. If we consider the industrial and precious mineral, we are abundant in bauxite, metallurgical grade bauxite. We have adequate reserves of zinc. We are deficient in respect of chemical grade bauxite, copper, lead, and we are also scarce in critical minerals. As far as energy and industrial fertilizer minerals are concerned, we are very adequate in dolomite, gypsum, limestone, and mica. We have adequate deposits of graphite, but at the same time we are scarce for sulfur and potash. As far as precious stones minerals concerned, again we are scarce, having diamond, emeralds, and ruby. These are the precious stones we need to explore furthermore. This is a chart showing some mineral resources of some important minerals and India's ranking in the world sector. You can see we are third in the terms of percentage contribution in the world for resources for chromite. We are 7th largest in resources concerned for bauxite, manganese ore, iron ore. We are 8th largest resource base having graphite, and these are some of the important minerals contribution to the world, and what are the resources in India present has been depicted in this slide. If you see the degree of self-sufficiency of minerals is concerned, the last column as far as the supply demand is given with the apparent consumption and the demand supply. We are nearly self-sufficient in respect of iron ore, chromite, bauxite, limestone, aluminum metals, but we are very much needed, dependent on kyanite is concerned, magnesite is concerned, rock phosphates, which is very likely agriculture industry because our economy is agriculture based economy, so we are dependent on import of rock phosphate. As far as copper is concerned, again this copper is declared as a critical mineral, so we are depending on import, and we are sufficient for the zinc metal. So this is a degree of self-sufficiency of some important minerals has been highlighted in this. As far as India's what is the world production ranking, you can see we are 2nd largest in the world for crude steel production and lead refined. Then we are 3rd largest producer of zinc slabs, chromite, with 6.63% and 9.39 respectively. We are 4th largest producer of iron ore in the world with more than 10% of the world production is from India. We are 5th largest for aluminum. We are 6th largest for manganese ore and bauxite production. We are 10th largest, but just with more than 2% of the copper production. Then we are very much deficient for, as I told, for rock phosphate and apatite, which are the agriculture-based minerals, and we are also very less having magnesite productions. But the mineral sector poses a very great potential for the further expansion. As you know that India has posed for the Viksit Bharat, developed nation. We have, our government has announced the Make in India. So lot of minerals are required for the various infrastructure and projects which are in pipeline. We are building more than 100 smart cities. So obviously the demand for minerals will increase. Then we are introducing the high-speed trains. Already one rail link is already in full swing from Mumbai to Ahmedabad. We are slowly moving to e-mobility for e-vehicles, and obviously we require critical minerals for this. We are also having the largest program for large network of highways and tunneling. Since morning you are seeing how we are progressing for the construction of tunnels, for the infrastructure projects, for highways and etc. And our per capita consumption of minerals is very less. So with this envisaged program, the per capita consumption is also going to increase. So in India, the mineral sector and mining sector is having a very prosperous potential, and we can see the quantum leap in the mineral production, etc. Now I am coming to the what are the policy, how it has evolved in India for as far as the mineral sector is concerned. Before 1991, the India has adopted you know that the economic reforms have been introduced by the then government during 1990s, and before 1991 there was no separate mineral policy for India, and the mineral sector was guided by the Industrial Policy Resolution, which is called as IPR 1956. So there was no separate as such per se the mineral policy for India before 1991. And the wide-ranging economic reforms have been introduced by the government. We know LPG liberalization, privatization and globalization. And for the first time in March 1993, the first independent national mineral policy was pronounced by the government of India to have the vision for the mineral sector in India. In September 2005, the government, the then Planning Commission, has appointed a commission which is known as High-Level Committee, HLC, to review the national mineral policy, because whatever the pace we had anticipated through national mineral policy was not expected. So therefore the Planning Commission has appointed a committee, and based on the recommendations of this committee, the national mineral policy was revised, and new national mineral policy 2008 has introduced by the government of India. Then after the 2008 policy, there was some still there were the policy gaps, some judicial interventions were there. That was the period when a lot of illegal mining was taking place, and the government has appointed some commissions for inquiry of all these illegal mining. Many of the cases have gone up to the Supreme Court, and the Supreme Court, Honorable Supreme Court, has also directed that government should revise the policy, should look into examine policy, and with this the government has come out with the new national mineral policy 2019, and it is still in vogue as a guiding factor for the Indian mineral sector. These are the national mineral policy which says the vision documents having the multiple approach, right from exploration to post-mining closure operations. All these have been enumerated in national mineral policy. I will go one by one through what are the features of this national mineral policy. You can see it has a clear vision how to approach about the mineral development in India. It policy says what should be the regulation, what type of at the central level as well as the state level, the role and responsibility of the regulating agency. It has envisaged the exploration programs, private sector participation in the exploration. It has also envisaged the creation of database for GIS database so that investors can have the information on the click of the mouse. Then it has introduced the mineral development, what should be the approach for mineral development, what should be our foreign trade. Then some fiscal aspects have also been enumerated to encourage the industry to invest in mining sector. It has emphasized for more research and development. At the same time, also it has a trace for the intergenerational equity, that is sustainable mineral development in the country. Now, the important provisions which have been highlighted in the National Mineral Policy, it has introduced introduction of the right of first refusal, because the policy says that when any entrepreneur comes and he wants to explore through auction, the government will ask whether he is still interested for the next phase of mining operations, like mining lease. So introduction of right of first refusal has been introduced. Then the policy and message for encouragement of private sector to have more exploration, because the government agency like Geological Survey of India, Mineral Exploration Corporation, or the State Directorate of Mines and Geology, they are not enough sufficient to have more accelerated exploration program. So private sector exploration has been introduced. Then auctioning in virgin areas we have introduced, which says that RP, that is reconnaissance permit, prospecting license, mining lease on revenue share basis. The policy also encourages merger and acquisitions of companies, mining companies, to have larger conglomerate, to have the advantage of greater emphasis. Then transfer of mining uses and creation of dedicated mineral corridors to boost the mineral sector has also been introduced in the mineral policy. Then to boost the mining for private sector and acquisition of mineral areas in other countries, also policy emphasizes knowing that the Kabil one joint sector company has been established by the government of India, which also oversees the acquisition of mineral rights not only in country but outside the country, for which India is deficient. Then the policy envisages the long-term import-export policy to help the private sector as well as the public sector. The policy, one of the important features of the policy is that previously the government sector have been reserved some areas, but they have been brought at par. So if the private public sector enterprises are not starting mining operations, that area will be reserved and it will be thrown open for auctioning by the and anybody can auction, including private sector. The policy also emphasizes for harmonization of taxes, royalties, levies with the world benchmarks, so that there cannot be more taxes, and also it gives trace to resolve the environmental issues by introduction of the Sustainable Development Framework, that is SDF. These are the policy statement. Any policy is very ideal, but what are the action so far initiated by the government of India that has been I am going to highlight here. As far as first is amendment statute, the lot of amendments have been taking place since 2015. There was a major amendment took place in India, which has brought the concept of bidding auctions, because in the previous regime, the mineral concessions were granted on first come first served basis, but the system has been having the glitches like the lack of transparency. Now the concept of auctioning has been introduced with 2015 amendments. There was a provision for renewal of mining leases. Many of the state governments were sitting, they were not emphasizing for renewal of mining leases. Now the ambiguity for renewal period has been removed, and all mining leases will be granted for 50 years. Then for curbing the illegal mining activities, stringent provisions have been made in the 2015 amendment. The important aspect to give thrust on exploration, the National Mineral Exploration Trust has been constituted, which just charges some levy from the mining holders to have encouraged the mineral exploration. Then the concept of PL cum ML, that is prospecting license cum mining lease, has been introduced, which was not there in previously. And the private central government has been empowered to issue direction to the state government for the sake of mineral development. And there was a complaint that social aspect, that the mining companies are exploiting the mineral resources, but they are not doing enough social obligations to overcome this aspect. The District Mineral Foundation, that is DMF, has been created by the Government of India, which is headed by the respective district collectors, and they are emphasizing for the mining districts which have been affected by the mining activities. They are carrying out the social responsibility through this DMF fund. Then in 2020, amendment took place with that. Because at that time the large number of mining leases were expiring on 31st March 2020, and there was it was thought that there will be abrupt disruption in the mineral supply. To overcome this aspect, the government has amended the Act, which says that whatever approvals were there, that will be carried forward to the new mining leases, and this has ensured that the mineral supply is continued, because a lot of iron ore minings, especially in Bellary sector of the Karnataka state and in Odisha sector, were expired. So this amendment has enabled that there is no disruption in the mineral supply, chain supply. Then in 2021, another amendment took place. Previously in auction region there was a distinction between captive and non-captive. This distinction has been reviewed. So anybody, even if auction is granted, they can have mineral consumption for their own industry, or as well as they can surplus mineral is there, they can sell to other parties also. So all the auction which were taking place, that have been removed the end-age restrictions. Then yesterday our Board of Government Chairman has emphasized that the definition has been changed from mining operations with production and dispatch. So any mining leaseholder who are not working and doing production as well as dispatch, they will be treated as likely to have termination. Then in 2021 there was provision that the captive mine owners can sell 50% of their production after meeting their own requirement, but this provision has also been removed subsequently. Then there were many cases where the mining leases applications were pending. So this issue has been resolved, and all applications which were pending for disposal for grant of mineral concessions have been removed through this amendment. Also, as envisaged in the National Mineral Policy, the areas which were reserved for the public sector, if they are not brought into production, they will become the de-reservation after the year 5 years. And transfer of all mineral concessions without any charges between the entities have been allowed through this amendment. Then in 2023, another set of amendment took place, and which have taken contemporary needs for defining the critical and strategic mineral, and a concept of reconnaissance operations have been introduced. 24 minerals have been introduced as a critical and strategic for India's requirement, and this auction of critical minerals have been empowered to the central government, and central government can do auction, and subsequently they will recommend to the concerned state government for grant of the mineral concession. And concept of exploration license for deep-seated for critical minerals have been introduced in 2023 amendment. And the recent amendment took place in 2025 that for in existing mining leases, if there is any presence of critical or strategic minerals is there, that can be added with some additional amounts, and no auctioning is required for that. And also for deep-seated mineral, if you are occurring more than 200 meter, one-time relaxation has been given to add 10% of the mining leases as well as 30% of the mining area in case of composite license. Now the National Mineral Exploration Trust, the concept has been changed to with the new definition like National Mineral Exploration and Development Trust, and this fund can also be utilized for acquisition of mineral rights not only in India but also abroad. So, and the percentage which were charged from mining leaseholder has been increased from 2 to 3%. And the 50% restriction which was there for the captive mines, they were allowed to sell. This 50% restriction has also been removed by this 2025 amendment. So the captive mines, after meeting their requirement, they can sell any amount to open market. Then the National Mineral Exploration Policy 2016 has been announced by the Government of India, which permits the private agencies to carry out exploration, and after approving the mineral deposits, if they got some economical mineral deposits after the auction, these exploration agencies can get some amount, revenue percentage to be paid by the successful bidder, so that the exploration agencies they can be compensated with some financial assistance. Then for meeting the challenges for environmental challenges, the government has introduced the concept of star rating system, and as a part of the sustainable development framework, the Indian Bureau of Mines through Government of India has introduced star rating concept. So with this, every mining leaseholder has to submit a self-assessment report on 1st of July every year with digital images of mining lease areas. And this is being, there are some standard templates which have been devised by the Indian Bureau of Mines, and the leaseholder, these templates are being examined by IBM, and at least 3-star rating is essential to carry out mining operations. If any mine is not obtaining 3-star within the period of 4 years from the commencement of mineral conservation and development rules, or within a year of 4 years, so these mines can be suspended. So minimum standard of environmental regulation has to be achieved by this concept. Then to curb the illegal mining activities, the Government of India has initiated launched a program that is Mining Surveillance System, which is a satellite-based program. It is act as a eyes in the sky. So any activities which have been catched by the satellite images within the periphery of the mining lease area, that some triggers are generated, and these triggers are to be field verified by the state government, and if there are any illegal mining activities taking place, so the legal action can be initiated on such activities. So this is MSS is an effective tool which have been introduced for monitoring illegal mining activities, what is the extent, where is the location, and etc. Then offshore mining, a new concept has been introduced, and it is going to be a game changer if it is successful. The first India has introduced the offshore mining, and first tranche of 13 mineral blocks have been launched. 3 blocks in lime mud in Gujarat coast, 3 blocks of construction sand in Kerala coast, and 7 blocks of polymetallic nodules in Andaman and Sea containing the cobalt, nickel have also been introduced. So, and the government has invited bids, and these are under examinations. And once that's successful, this can be a new offshore mining can be a new area for the Indian mineral sector. Then the critical minerals is need of the hour, because India has committed that by 2070 we will be net zero. So for achieving this, we are short of critical and strategic mineral. So Government of India has initiated a national critical mineral mission with an expenditure of 18,000 crore and also the matching participation by the public sector and private sector. So total ore outlay is about 34,300 crore to strengthen the mineral exploration for critical minerals, mining, beneficiation, processing, recovery of from the end of life product. So this is the National Critical Mineral Mission has been introduced with the focusing on increasing the domestic production of critical minerals. Then if it is not available in India, acquisition of mineral rights, and I am happy to inform that the Kabil, a government company, has already acquired many of the critical mineral mining leases in Argentina and other countries, and also the negotiations are going on in some countries where these critical minerals are available. Then recycling of critical minerals is another area from where we can recover the critical minerals. Then scientific research, because we have critical minerals but we don't have wherewithal for processing of these critical minerals. So this is also one of the aspects, and the matching human resources is also required to the skilled manpower for achieving the objectives as set in the National Critical Minerals. So these are the concurrent activities which have been taking place. This is the mission output. What are the micro level milestone which have been envisaged in the mission output. Then as far as digitization is concerned, we have introduced the mining tenement system. This is mining tenement system is a digital repository where all life cycle of each mining concession has been digitized, and all the approval process have been made automatic. Means any applicant don't have to face physically, they have to come. They can apply online, and all approvals can be made through online processes. And with this geological information system also we introduced. So this is a greater thrust on the transparency to bring more accelerated development. Drone data management also we have introduced. With this, the leaseholder has to submit the digital images. With these digital images, we can process these images in our office, and we can also check what are their proposals, whether they are in line with the proposals or not. So this tool can enable that virtual inspections are also possible, and sitting at the office, you can virtually inspect, you can point out any deviations from the approved proposals. State mining index, because ultimately the state governments are the authorities. So Government of India has given thrust that the state, they have also to improve their machinery, and with these objectives they have introduced the indexing of state, and what are the action performance, how any state is doing, encouraging for the early operation of the auction blocks. What are their exploration proposals, agenda, then what are their sustainable mining issues. These are the many templates they have been introduced, and the state has been categorized in 3 categories on the basis of their mineral potential, and the Government of India has already came out with the state mining indexes. Then new features we are going to introduce, that all mineral trading will be through mineral exchanges. At present, the buyer-seller has to contact, but just like the share market, all tradings will be through mineral exchanges, and the Government of India has already declared Indian Bureau of Mines for non-coal mineral sector as a regulatory agency, and a coal controller of mines for the coal sector, and shortly we are going to introduce the rules for the mineral trading. So with the start of some minerals, all mineral trading will be held through exchanges where the buyer and seller, they will not come face to face, but they will be do trading. And with this trading, the actual cost of the market price can be captured, and accordingly the real price of the minerals can be introduced. So these are the initiatives initiated by the government of India so far, but still there are a lot of scope to do. What are the challenges which we are facing? The exploration, because I have already told that only 30% of the obvious geological potential has been explored by the India, and the most of the exploration are on the superficial minerals, bulk mineral, but we are not going beyond the 50 to 100 meters, and there is need to carry out exploration at deeper depth. So National Mineral Exploration and Development Trust has been introduced, which can help, which is also giving the financial assistance for carrying out to mineral exploration. And under this NMEDT, so far 648 exploration projects have been already approved, and 320 have already been completed. And with this, it is possible that we can have the exploration of the country. Then regulatory aspects, because regulatory and clearance bottlenecks is taking place in India. Obtaining the incubation period for a grant to start is quite high. So the government has also introduced some pre-embedded approval system, including environmental clearance, and government is trying to process the delays in every approval stage, so that there is the incubation period for the operationalization of blocks, auction blocks, can be minimized. Auction related challenges are also there. Although auction has brought some transparency, but at the same time rivalry between the industry players have brought some key issues like high upfront premiums, which is affecting the project viability. Many of the things buyers are not coming forward for the auctioning, and major delays. There is a delay between grant of letter of intent granted to the bidder, successful bidder, but operationalization takes place. And at the same time, there is an uncertainty of geological aspects. So the bidder is not confident to go ahead whatever premium he is quoting. So these are the some issues, because out of 373 mining blocks have been auctioned, only 82 have put into operation, and bulk of the mining blocks are yet to be operationalized. Then illegal mining is another state, because the law and orders problem is the state government problems. So the state governments needs to adopt the latest tools, like initiatives like AI and machine learning tools to detect the illegal mining. We have already launched mining surveillance system and drone system, but this problem is more persistent in respect of minor minerals, where the role of central government is limited. So this issue, especially in unorganized sector, is still persists, and state government has to do lot of things. Then environmental and social concerns, because most of the mineral deposits are either in forest area or tribal areas, and these pose a great challenge to accommodate. So post-mining closure issues persist, and although in organized sector mines these issues have been tackled very well, because they are doing a lot of corporate social responsibility things, but in unorganized sector these issues still persist. And the key issues that I already told, critical minerals, we are 30 critical minerals have been declared by India as a which are critical for the our supply chain, and out of these only 14 critical minerals are available in India, and in the rest of the 16 minerals we are heavily dependent on import. And out of 14 critical minerals which are available, that too only in 7 minerals we are having the reserves. We are having only resources. So lot of exploration and degree of confidence, of geological confidence, needs to be increased for the critical minerals, so that whatever target which have set by a net zero emission by 2070, which can be achieved by exploration, mining, and processing of these critical minerals. So technological and infrastructure constraint, because large percentage of mining leases in India having the very manual or semi-mechanized mines, and more than 50% leases are occupying the less than 10 hectare leases. So obviously in such a leases, the mechanization is a great challenge. You cannot carry out mechanization unless you raise the bar for the scaling. Mechanization is not going to be sustainable. So this is an issue that infrastructure and technological investment is another challenge. In conclusion, I can say the government of India is aware of the problems. They are working very hard to come with the solutions, and they are bringing amendment from time to time. But ultimately, our system is a federal system where the central government makes a policy, but ultimately the implementation has to be done at state level. So there should be a sync between central and state government, and with this we can achieve the objectives whatever set by the government of India. So thank you very much. Thank you very much, sir.
Thank you, Dr. K, for this presentation. Excellent.
Yeah.
Thank you. Please, Professor Dusgun, with your presentation, please.
Thank you. So since, is it there still? Okay. So I can actually talk without slides. It's totally fine. This is, with the AI check, I realized that the audience is ready for this talk. And one more thing that I noticed is that if you continue as a speaker over 15 minutes, there's a noise coming from the back. So I'll be monitoring that as well, okay? So next slide, please. You've seen lots of promises, lots of ambitions to digital mining. Oh, thank you, that's better. Digital mining and digital transformation. Why we are more interested in that, actually, we wanted to have a goal to reach. It's autonomous mining, you know. Of course, we cannot do it right now. We're always thinking about digital tools, mechanisms that will take us to autonomous mining. That's our dream. I'm a mining engineer. I've been in the field over 30 years, and the concept of autonomous mining is not new. Even 1970s, even before I was born, people were talking about autonomous mining, but we're not still there. Why we want it? First, it's safe. And we know that mining, especially some mining operations like coal mining, is one of the most dangerous areas still because of the nature of the work. Second, mining is a discontinuous process. We always have disruptions, and this reduces the efficiency, production, and everything. So we want to achieve a continuous process, and autonomy is one way of doing it. Second, and the third one is, of course, scalability, because if we can do it in several of mine sites, we can do it from all over the world, and it's not only on the Earth. You can do it in the marine environment or even in space. So that's our goal. Next slide, please. And this transformation, autonomy, is definitely closely linked with AI. So I'm not talking about Air India. I'm not talking about large language models, okay? LLMs, ChatGPT, that's a different AI, okay? The AI that we need is mainly predictive because autonomy requires prediction before designing the operations. So, and there are some really good developments. Like we have high performance computing, we have advanced sensors. People are talking about remote sensing, IoT, multi-sensors, geophysics. Yes, we have all these things, but we're not still there. But those are all good. And machine learning and AI algorithms. You will be hearing machine learning and AI a lot. Sometimes I call it machine learning AI washing because it's a very hot topic. Everyone uses it, but actually use of it for certain purposes is totally different. It's not a solution for everything, okay? Because we cannot go to autonomy even though we have all these systems due to the nature of the industry, due to the nature of the work that is done, and also the regulations. You've seen how complicated and how many evolutions in the mining industry going on. I've been in so many different places, including Africa, US, Canada, and the Middle East. It's the same. Regulatory environment is changing a lot. And you cannot operate a mining operation without having a regulatory framework. And we're not yet there. Mining companies, those are very similar to oil and gas and other energy companies. They are so close, they don't want to share data sets. And you will see so many AI applications, but they are not in the nature of prediction. It's mainly improving the operational environment with some LLM applications. So we're not sharing. If we don't share anything, we don't have big data, and if we don't have the big data, we don't have good predictive AI models. And the most important part is that we're dealing with geological uncertainty. In other words, if you train a model in one rock type, one geography, one environment, it's not going to work for another site. So in my talk today, I will focus on geological uncertainty because it leads to hazards. And full autonomy mainly possible if we can manage and predict those hazards. Next slide, please. So AI has lots of promise in that area as well. Like if we develop methodologies that can predict hazards, then your autonomous operation can be possible. For example, you don't want any LHD smashed by a rockfall, right? But it's possible. And we have some autonomy in surface mines via autonomous trucks. That's the easiest, okay? We still did not create autonomy for shovels, okay? And for underground, this becomes extremely difficult. Let's assume that we solve everything. We still have the problem of managing geological uncertainty, and those are geotechnical hazards. So you can have roof falls in the surface, you can have slope failures, rock bursts, ground subsidence. So today in my talk, I'm going to talk about how we develop a system to predict roof falls and ground subsidence. Next slide, please. So what are the problems? Why we cannot advance it? First of all, good AI systems, predictive AI systems, is not unsupervised. So unsupervised, how many of you understand unsupervised? Oh, okay, so let me explain. So unsupervised means that system understands what do you want from the data. You don't do anything. For example, large language models was kind of evolving towards that area. In supervised models, you as a human being say that hey, this is table, this is chair, this is couch, and the system starts understanding it. For example, when you go to Google for security check, it asks you to look at the bike, right? You just press the bike in the image. So that is actually how you contribute to the autonomous cars, because all over the world people label the data. So in mining, in geomechanics, we don't have this type of labeled data. So how are we going to label it for accurate models? Second is that those models are black box. You don't know what's happening. So the question is, can you cover all the data sets that is representing the phenomena so that the system will recognize? Because you don't understand how the system is recognizing. So this creates some trust problems. At which level we have to trust the AI's input, right? So for example, as a person who develops AI, okay, I know how these things work in. I was in the lounge and there was a robot coming on my way, and I was skeptical whether this robot will see me or not, right? So there's the trust issue built in, and we have to understand that. Of course, there are so many models saying that we did this, okay? But those are not in reality. Those are all just experimentations. So we have to see real models. The real models are mainly autonomous cars. Recently, it's in our lives. But in underground, we still cannot operate them because of the problems that we're encountering. And also infrastructure is a typical issue because all these systems need huge infrastructure, and mining already operates under a given infrastructure, so you need to change the whole infrastructure according to that. So those are the barriers. Next slide, please. So then, in my talk, I will focus on data scarcity challenge. Because without solving that problem, going to the other problems is not feasible. Can we solve it? When you look at the literature and when you look at scientists or academics, let's say AI implications, they always say that, oh, we don't have data. We cannot do it. Recently, Global Mining Initiative from Australia started a new project. It was actually published. You can have a look at it. Open data standards. Yes, you need to first have some benchmarking data sets so that everyone can check their algorithms if they are providing an improvement or not. For example, in image analysis, there's a very famous image called Lena. All the computer scientists use their algorithms to test with a single image just to say that they are doing better. We don't have this, okay? But are we going to wait until all these data sets accumulated? It's ridiculous as well. So we need to look for some innovative solutions. So today, I'm going to show you 2 solutions that we tried and they are working. The major reasons for this data scarcity is not only data sharing. Going to a mine environment and collecting data without disrupting the mine environment is extremely difficult. So the question is, oh, we have all these equipments, they are already collecting data. Can we use it? Yes, you can use it, but they don't share it first. Second is that those data sets are hard to store. Currently, I mean, in the past, in all these mines, we had relational databases, people were storing it. You don't store IoT data. because it's expensive. If you don't use the data, what's the purpose of storing, right? So you need to design the system in such a way that you could use it. There is operational disruptions, I mentioned it, and then site specificity. For example, in one example I will show you, we need to collect images of the roof, and the roof height is 5 meters in an underground. How are you going to collect accurate images? It's not just taking a photo of a bike and putting it everyone's web and asking them to label, okay? So next slide, please. So in these kind of circumstances, expectation of having large data sets, like 1 million of images, is not possible. That is traditional AI, okay? And letting people to label those data sets is not possible. And field is not equal to the lab. We need different approaches. So those approaches are actually coming from, again, computer science, but using those solutions in our problems is promising. Those are usually called transfer learning. So you use the methods AI developed for a certain area, certain domain, for example, medical images, and then you can use your images from the roofs and ask the system to figure out what's going on, okay? And there are other models. For example, if you want to know the displacement in time, mainly subsidence, right? Then you can use some time-dependent spatio-temporal models that are developed in computer science to make predictions. So, next slide, please. So yeah, I will explain this next slide. Oh, there's no noise, so I can slow it down. Okay, next slide, please. So this first model that we developed was actually a project that we started before COVID, and we progressed during COVID. We selected a mine in eastern US, and they have frequent roof wall problems, and the major reason is tectonic stresses. The tectonic stresses are creating high horizontal stresses on the roof, and they have frequent roof falls. It's inevitable. And when we go to the mine, we realize that, can you press the next, yeah, okay, great. So when we go to the mine, we have observed these blocks falling, and it's very frequent. And it is so frequent that a geology engineer go to mine and make an inspection and define. Oh, thank you. Is it working? Working? Is it? Okay, great. So the mine, not working. Working? Okay. The geological engineer go to mine and say that, okay, today we will work in this section. So even this is against the mine planning. Because of the roof conditions, any production on the day is dependent on a single person. So when we go to the mine, we realize that the engineer used some visual clues. So the question was, can we mimic those visual clues? Next slide, please. Yeah, you can press all of them. Yeah, thank you. So we realized that he looks at the roof and he figures out indications of stress concentration, horizontal stress concentration in these chevron-like lineaments created on the roof. And then he also looks at the angle between those chevrons. This is a room and pillar mining. And they also note the locations of different roof walls. Next slide, please. You can. So what we did is that we went to the mine by looking at the map, we just classify the places that they have no potential roof fall and the roof fall. But the amount of images, you can press more, the amount of images that we collected was almost 1,000, you know. We collected 1,000 images, only maybe 20% are hazards, the others are not. And this is not possible to train a good AI system. So what we did is that we look at the medical images, because medical images also have certain features, like those linear features, that can be extracted from the images and then used for diagnostic. And actually, our problem is very similar. We're trying to diagnose whether there is a potential roof fall or not by looking at some visual clues. So those models are trained for large data sets, so we mixed our roof fall problems, roof fall images with their trained images, and we also labeled our data sets as hazardous and non-hazardous, and then we asked the system if it's going to find. Next slide, please. So these are, for example, the locations where we collected hazardous and non-hazardous roof falls, but we realized that even with 1,000 data sets, system is not working. And we cannot go to the mine, do more analysis. So what we did is that, as an additional data entry, we went to mine and we created 3D model of several roofs via close-range photogrammetry. So we have actual models of several roofs, and we created additional data sets rather than taking snapshots of it. We created an 3D photogrammetric version of the roofs, and then we feed the system with those synthetic images. Actually, those images are not synthetic, actual ones, but they were not taken from the mine at the time of the training. Next slide, please. So we realized that there's a significant amount of improvement in our prediction. And our system can predict with an accuracy of 89%, almost 90%, non-hazardous roofs, and 80% hazardous, because we don't have a lot of hazardous roof conditions, but this is promising. We can still make good predictions that can automate the system. Next slide, please. But we don't know how the system is working. Remember, I talk about trust issues. So we did some explainable AI analysis to get rid of this black box approach. And remember, I said that we also used the medical images. So we look at how system is learning. So there are some algorithms that you can use. That depends on your data type. In this case, our data is image, so we use some image-based explainable AI systems, and we learned that this AI is mimicking what our geologist is doing, because this AI learns everything based on the image features, and those features are mainly the linear features of the hazardous and non-linear features. We don't see any texture or any linear features in the non-hazardous roofs. Those are mainly smooth images. So these are some examples of hazardous and non-hazardous roof types and how the algorithm is finding the gradients and identifying the characteristic features. Next slide, please. So these are published. You can download it and have a look at them. Next slide, please. So how can we use these systems? So if you want to create an autonomy, you can install this system into a robotic device, and this device can scan the roof even before going to the mine or before sending your valuable engineer into underground. And as time goes, when you collect more data sets, even you can establish your own AI. You don't need these medical images. And of course, human-machine interaction could create some amount of trust based on the explainability as well. Next slide, please. So the next example I'd like to give you is, again, data scarce, but it's a different problem. Next slide, please. So this is a study that we conducted with colleagues from Spain. They were studying a tunneling operation in Sevilla. 2 tunnels are constructed, but during the tunnel construction, there happened to be lots of deformation on the surface, damaged so many historical areas. They did so many numerical analysis to predict the displacements on the surface. So the question was, can we use these models to predict the future tunnel advancement? Next slide, please. So what we did is that with them, they actually modeled numerically the tunnel's advancement in time frame. They also went to the surface and make some surface displacement measurements. By using these data sets, those are really huge amount of numerical models, like 244 excavation instances with 100 time steps modeled. And on the surface, they made this number of over 3,000 measurements. So we know what happened on the surface. We know its numerical model. This ends up around 87 million of data sets. Now the problem is, like, at which time instance, what are the displacements on the surface? Of course, we cannot use the AI, predictive AI that I described to you, for roof fall problems, because this is a different problem where we have these numerical models with these parameters, and they are validated with real data. Next slide, please. So we use a model called long short-term memory, LSTM. This is a very well-known model, but usually this model is developed in 2D. You have only XY coordinates, and in our case, we are in a 3D, so we modified this system to make predictions in 3D subsurface and also the surface. And we use those numerical model inputs for every time step of the excavation. And we obtained, next slide please, way better accuracy than the images. As you see here, these are some accuracy metrics. I'm not going to go into the details of them, but if you have questions, I'm happy to answer. We used to meet 2 centimeter threshold as the hazard. So this time we classified the displacements that are lower or bigger than 2 centimeters. That was their regulation. And then we identified critical hazard levels. Next slide, please. So this is also published, I think last year, and the colleagues are still working on this. I taught them how to use AI, so they have huge amount of data. They are using it right now. For me, it's now an interesting problem. It's not an interesting problem, AI, for an AI perspective, because we solve it. But of course, for them to continuing feeding the system with new data sets is really important. So they're still continuing. Next slide, please. So we try to mimic what is observed for the given system. Since they will be continuing these tunneling operations in the same, almost similar geological formations in the city, they're planning to adopt the system for design. Before implementing the design, they wanted to make these predictions. So this is a replicable framework, can be used everywhere. All you need is to make these tedious amount of simulations, but that is the solution. We cannot wait until we collected all that data sets. Next slide, please. So the two frameworks that I mentioned to you are the good way of eliminating data scarcity problem. Different AI architectures are needed. Those are called convolutional neural networks. There are zillions of networks. Unfortunately, large language models cannot solve these. And validation plus explainability is the way to build the trust. So from my experience, never ever use any AI system without asking its accuracy metrics. There's not a single metric, okay? We can discuss it later on. Yeah, next one. So future directions. I've seen in so many slides today, people were talking about workforce development. Yes, it is important, but the future is dependent on people who understands the geotechnical aspects and also the data. So I'm seeing recently so many people approaching to me and saying that, oh, we're really good in using Python. We're really good in machine learning. My question is, are you good in rock mechanics, geomechanics? Because without understanding the domain itself, all these models will not work. So we need people who understands principles, basic principles of mining, geomechanics, tunneling, plus a good understanding of data science. That requires a paradigm shift. I'm representing both industry. I have my own company and also the university. Universities are under the pressure of decreasing the credit hours, and industry wants well-trained people. That's a big dilemma. But this problem can only be solved via dialogue. Universities cannot solve on their own. Industry cannot hire simple data scientists and give that data and get a result. No, you have to work with geoscientists who understand how data science work, okay? Yes, digital twin, people are talking about this. There are so many companies right now, they're saying that they're doing digital twin, but I haven't seen any digital twins data providing a solution. So, digital twin oriented for a solution, especially for prediction solution, is critical. And multi-sensors, yes, we can still solve those problems with multi-sensor integration, but how we will curate the data for the problem is important, and I'm giving you heads up so that, if you want to do all these digital transformation, autonomy, all these things, these are my 4 recommendations. There may be more, okay, but people are really good in keeping 3 in their minds, so if you forget about 1, it's also okay. So the last thing is the safety regulation, okay? Even though technology is ahead of what's going on, in tunneling industry, in mining industry, if you don't have appropriate legislation, these methods will not be operationalized. So legislators has to also communicate with people who are developing AI, adopting AI, and working under these systems. Next slide. Okay, so I'm not going to repeat this. We recently revised, at Colorado School of Mines, we recently revised our curriculum. I was leading that effort, and I use AI, okay? How I use AI is that we look at all the lectures, content, and we ask AI to find the redundancy, okay? It's not a predictive system. What AI can leverage or change the speed of work if you use properly. Even though we change the curriculum, our students going to industry who has that, let's say, capability will take 5 years, okay? I'm following AI very closely, and every day it's changing. So the pace of our change is unfortunately slower than the actual change in the technology. So I think we need to fill the gap. So thank you very much. There was no noise, so thank you very much for listening my talk. And if you have any questions, I'm happy to answer.
I think we will start with the paper presentations. There are some, I think, 5 papers to be presented in this session. So I will call upon the first presenter, Nitish Kumar. Is he here? Yeah. He will be presenting on innovative INSAR approaches for detecting mining-induced subsidence. Mr. Nitish, you have to restrict for within 5 minutes. I'm sorry, that is the instruction given by organizers. Okay?
Good evening, everyone. My name is Nitish Kumar. Presently, I am pursuing my PhD at IIT ISM, Dhanbad. Today, I am presenting my presentation on innovative INSAR approaches for detecting mining-induced subsidence. In this slide, I present my overview of 24-month observation, where my objective is to detect and monitor long-wall subsidence of monetic colliery BCCL using time series INSAR data set for 24 months. And the second objective is to quantitative validation of INSAR result with ground-based observation. The methodology I adopted is integrated spaceborne INSAR technology using Sentinel-1A data and CSV DTS processing, that is a current small baseline, and INSAR time series processing, and validated it with ground GNSS survey. A status right now, I am monitoring my work with CSV DTS process till January 2022 and May 2024 too. Why to monitor mining subsidence? The first problem is to monitor mining subsidence is for environment and safety risk, where subsidence damage infrastructures, alter hydrology, and endanger personals. The second one is for regulatory requirement, where we have to monitoring and controls are for statutory for safety, environment, and mineral conservation. The third one is for if prediction limits, then we can monitor mine subsidence. The problem consequence of extraction here in this slide, this picture illustrates the consequence of extraction, where if we extract minerals, there will be problem of subsidence troughs. Here in physical process, if removal of rock mass creates voids, overburden collapses to fill these voids, creating surface trough and cracks. In my work, I have to find out this trough by using concentric fringe. These are the problem by which subsidence trough can occur, like physical process. Other one is hydrological risk and infrastructure risks. I have applied an integrated approach for my monitoring work. Like I have utilized a spaceborne INSAR with integration of ground-based GNSS technique. Here, this is the advantage of SWAS INSAR, that it is useful in early warning system, broad area coverage, and in accessible area it can have cover. Its accuracy is in millimeter to centimeter, and it is all-weather day-night capability, and it also works in historical displacement analysis, and also it's cost-effective monitoring. What are the data and instrument I have used? First, I have used Sentinel-1 data from January 2022 to May 2024 with the interferometric width swath mode, and I have used ascending, and SRTM DM for topographic error removal, and I have used GNSS and handheld GPS for obtaining ground control points, and software I used ArcGIS and SNAP. Methodology I applied is first pre-feasibility check of area, that I can apply my technology or not. Then the second methodology is to co-registration and resampling. After that, I applied CSV DTS processing, where I create interferogram generation and phase unwrapping, and then I done analysis to find out concentric fringe. Here I collected GNSS data acquisition. These are the results where I get deformation in range of about -4 to 4 centimeters. These are the results. In conclusion, we have created 20 permanent monitoring stations, and in my study, I don't find any fast concentric fringe. But LOS displacement shows in few centimeter plus minus positive and negative displacement. And I have used GNSS data for validation purpose. In this conclusion, I don't find fast concentric fringe. That's why in future works, I have to apply advanced monitoring system, advanced monitoring technology, and I have to apply GNSS data to validate and this study is only for 2 periods. That's why I'm working for next periods, additional 1 year work. Thank you.
Thank you, Mr. Nitin. There is no question session for this, so thank you for your presentation. I will call upon the next presenter, Mr. Pushpendra Patel, if he is here. Yeah, please. He will be presenting on machine learning approach for precise estimation of blasting PPV in tunnel construction. Please mind that you have 5 minutes.
Yes, sir. Respected chair, co-chair, distinguished delegates and researchers, आप सभी को सादर नमस्कार. I am Pushpendra Patel from CSIR Simfer, and today I am here to present my work on machine learning approach for precise estimation of blasting PPV in tunnel construction. It is just a predictive framework for controlling blast-induced ground vibration in tunnel excavations. So in today's presentation, I am going to cover What is blast-induced ground vibration in brief? The problem statement that why we have chosen that study and limitations of the existing empirical models and the data set and modeling framework, as well as the sensitivity analysis of the model and blast design optimizations for practically controlling the blast-induced ground vibration at site. So, because of various advantages, drilling and blasting is the primary method which is used for excavation of hard rock internal excavations. But when we detonate the explosive, it generates a high energy of stress waves, and when it passes through the ground, it creates vibration, and it is measured in terms of ppb. And if the ppb limits exceed the safe limit, then it can cause the structural damage. So this study is based upon a real incident. We all must have heard about the Josimat sinking news actually in 2023 actually, and we have heard that the structural cracks are appearing in the residential houses, and the resident of the Josimat town attributed these damages to the nearby construction sites, which was the Tapovan hydroelectric power project, which was very close to the site actually. And because of this, the project work was suspended. Then after some time, the committee has given that no, it is not because of the vibration from the construction activities. The work again started, but they have imposed some strict ppb limits that it should not exceed the 5 mm per second at 100-meter distance from the blasting location. So this was not just a vibration issue, it became a socio-technical crisis involving engineering, safety and public trust. So we had to have a reliable prediction model, and because the SIMFAR, we were the blasting consultant at the site, so we had to come up with a reliable prediction model. We have chosen the machine learning models because the existing models are based upon the two primary parameters which are used for predicting the ppb, and the site specific constants k and beta are determined using the regression analysis, but it has limitation. It do not consider the rock mass quality, confinement condition, blast geometry, explosive characteristics, which are a significant factor which contributes the ground vibration. And I will brief about the Tapovan hydroelectric project. Actually, it is developed by the NTPC. It is located in Chamoli districts of the Uttarakhand, and it is in Dhauliganga Alaknanda River. It is 520 megawatt capacity hydroelectric project, and here we can see that how big underground caverns are for the machine hall, that 48 meter and 158 meter length and 22 meter height, and there is a headrace tunnel of 11.5 kilometer total length and surge shaft of 13.5 meter diameter and 145 meter depth actually. And all these underground excavations are being carried out by the drilling and blasting. Initially they had deployed the TBM, but it got stuck because of some geological disturbance actually, and then the remaining excavation is being done by drilling and blasting. So to develop the prediction model, we have collected some data from the site. Altogether we got 332 data, which consist of which are tunnel cross-section area, rock mass quality in terms of the Q value, blast hole length, specific charge, maximum charge factors, blast monitoring distance, and the ppb in terms of ground vibration in terms of ppb. So this is the machine learning framework. So initially we have to before developing the model, we have to visualize our data, that if there is any missing data or what is with the data actually. And then we have, it is important to validate our the model that we have developed. So we have splitted the data into training and testing in the ratio of 70-30, and we normalize the data, the raw data, to avoid any scale effect. And in this study, we have considered 3 tree-based supervised machine learning models, that is CARD, the classification regression tree, and random forest, and the extreme gradient boosting. Then, just for making it more robust and generalized, we have optimized these models using the particle swarm optimization techniques. And then we retrained this model using the training set data, and then we evaluated these models using performance techniques. The common performance techniques, that is R square, mean absolute error, and root mean square error, along with the regression error characteristics curve. Then we did the SAP analysis also to interpret the model, and because of the time constraints, I am going to directly the model summary performance actually. And based upon the data we have collected and carried out the prediction model, and we have found that the random forest is giving the most accurate result. So we have chosen this model for our this prediction actually. And for the benchmark, we have considered this USBM model for just benchmark performance. Then, as we know that these machine learnings are treated as the black box model, that is what is happening behind, we don't know actually. So it is important to interpret the model that what is the role of the input parameters on output. So for this, we have conducted the SAP analysis also, and from this we have got that the distance from the blast location and the charge per delay and the rock quality as well as the cross-section area are the parameters which are influencing the ground vibration. So just to have an example that how we optimize the blasting design actually. So the objective is here for at 100 meter we have to limit our ground vibration at 5 mm per second. So if the tunnel area, cross-sectional area is 42 meters square, rock mass quality and blast hole length, these are this, then what will be the safe charge actually? Then we have found that 25 kg, and according to our the changing cross-sectional area of the tunnel, we and the rock mass quality, we are changing.
Please wrap up. Please wrap up.
Sure. So we have found that machine learning is the reliable model which can predict, control, and important for sustainable construction actually. Thank you. Thank you all.
Thank you, Pushpendra. I will request Mr. Aniket Verma, the next presenter, and he will be presenting on optimizing GNSS primary control point planning and establishment, a case study.
Respected chair and co-chair of this session, and good evening to all of you. I am Aniket Verma, working as Scientist D in CSI Simfer Dhanbad, and today I am going to present my work on optimizing GNSS primary control point, focusing on planning strategies, their establishment, and demonstrate through a case study. Here's my topic content. The advancement of technology has greatly enhanced the quality of surveying. So, use of conventional instrument surveying has become more cumbersome, labor intensive, and limited digital integration with less appropriate for complicated mining situation. So hence inclination towards advanced surveying instrument has become need of an hour to acquire desired quality output. Nowadays, many mining industry mainly prefer for surveying using advanced surveying instrument like GNSS, Global Navigation Satellite System. And here GNSS is basically uses multiple satellite system like GPS of USA, GLONASS of Russia, Beidou for China, Galileo for European Union, and for some of the regional based satellite system like QZSS from Japan and Navik from India. And recently, South Korea also in the line of developing its own satellite system, namely KPS, Korean Positioning System. Genesis survey heavily relies on the availability and geometry of the satellite system, and for that we uses the and this is the our study area, which is Jamkhani coal mine project. In this coal block located in Sundargarh district, and it is allocated in Vedanta Limited, and this location is shown in the figure. Now, planning point of view, we uses the Genesis planning online tool, which is uses and get the predicted satellite geometry and plan the best observation window and anticipate the expected quality of Genesis geometry. It involves input parameters, which is shown in the right side of the table, mainly base coordinate, tentative depth of survey, timing of the survey, elevation cut of mask, UTM zone, and select available satellite system. Here we use GPS and GLONASS satellite system because we use R4 Trimble-based R4 model GNSS system. After all the input parameter, we get the right side window of the planning tool, and it shows that the number of satellite is around 13 to 18, and PDOP is vary from 1.09 to 1.79, which is best possible time to obtain primary control points. And below of that image, there is a sky plot which is giving in 3 different time, and in which green color is shown GPS satellite, and red one is shown GLONASS satellite system, satellites basically. The GNSS availability and DOP estimate provided by the GNSS planning software may be unreliable in complex mining scenario because tool does not account the dynamic environmental weather condition. During the month of August 2025, Jamkhani mine, only one day, which is shown in here, is best possible day for establishing the primary control point. For stabilizing the, for local disturbance also consider for strategic planning for GNSS observation, and GNSS measurement primarily relies on signal received from satellite, and it will be a clear sky view. So we need that means we need station which is away from the tall building and wall to minimize the signal blockage. High power television or transformer may also cause the electromagnetic interfaces, and additionally reflective surface also means like glass, metal, water body can also reflect and degrade the position accuracy. Tall and dense tree also be considered for obstruct the signal, and here in Jamkhani mine there is a 1 point R1 in which there is a heavy dense forest area also there. After cutting the tree and all those things, so then we get the precise point of the point, R1 point. The methodology, we to start the survey work, the base station must be established using static method, and here we use in static method the base in static method the base station remain fixed over the known point, and rover receiver are placed on new point whose coordinate are determined. Here the base station also provided by the mine management, and the right side there is a 4 points which we are established in the area. In the post processing, we get the raw data in the form of TO2 form, and we process this data in Trimble Business Center software, and we get the vector data in which the PDOP, RMS and number of satellite with base vector length means baseline distance are mentioning, and by this help we get the all the points. Finally, the conclusion, there is the best possible time using GNSS planning online tool, weather forecasting and the local disturbance consideration of this study for establishing the ground control point. The static method was used for minimum 2 hours of observation using R4 Trimble GNSS instrument to obtain precise coordinate of ground control point. And this approach is suitable for national mapping, engineering project and cadastral application. We also recommended that the base and control point are protected for life of the mine and cover and protect the thing. This is my presentation. Thanks a lot. Thanks.
Thank you very much, Sir Verma. I will now request Sonam, who will be presenting on development of a low-cost cyber physical system for real-time multi-location monitoring of blast-induced ground vibration in surface mines.
Very good evening to the chairman, co-chairman and conference chairs and all the distinguished experts and delegates. My name is Sonam Drugel and I'm from Bhutan, and I'm currently pursuing my second year BTech in mining engineering in Aditya University in Andhra Pradesh. So I'm honored to present this research which has been developed under the extreme guidance of my instructor and co-authors, Professor Aruna Magalpati from the National Institute of Technology in Karnataka, and Professor Abhishek Kumar Tripathi from the Department of Mining Engineering in Andhra Pradesh. So today I will be presenting on our work title, The Development of Low-Cost Cyber Physical System for Real-Time Multi-Location Monitoring of Blast-Induced Ground Vibration in Surface Mine. So the introduction. So rock blasting is an important operation in the mining industry, and it is, although it is used for the effective rock breakage in the mining industries, it is associated with the various environmental concerns like air pollution, noise, fly rock and ground vibration. From those environmental concerns, the blast-induced ground vibrations are the most critical issue as it propagates along the long distance. So in order to monitor the blast-induced ground vibration, the peak particle velocity, PPV, is the key parameter for quantifying the blast-induced ground vibration. The PPV is the maximum speed at which the ground particle move because of blasting. So because of this movement of ground particles, it causes structural damage and human discomfort. So the severity of BIGV, that is blast-induced ground vibration, not only depend on PPV value, but also depend on dominant frequency. So even at low dominant frequency, it causes more structural damage, even at the relatively low PPV value. So the PPV value and dominant frequency are measured for the monitoring the blast-induced ground vibrations. So the continuous monitoring of blast-induced ground vibration are required in order to ensure the safety of nearby structures and mine infrastructure and nearby surrounding communities. So the limitation of existing BIGV monitoring system, currently the geophone-based industrial monitoring system are widely used in mining and construction industries. However, their high cost, fixed deployment and limited scalability restrict their applications for the continuous and multi-location monitoring of blast-induced ground vibrations. And similarly, the previous studies have shown that wireless sensing can enhance the blast-induced ground vibrations. However, the large practical deployment still faces the cost and free-related constraints. And the growing use of, recently the growing use of MEMS accelerometer sensor, which is micro electromechanical system sensor had been reported for the ground-induced ground vibration monitoring systems by using the compact and embedded computing framework. Despite this development, there is most of the blast-induced ground vibration monitoring system remain confined to laboratory scale only. So a practical field deployment is required in order to evaluate their performance in real field condition. So the objective of this study is there is need of continuous and multi-location monitoring of blast-induced ground vibration in order to capture the spatial and temporal variability of blast-induced ground vibrations. So the continuous monitoring of blast-induced ground vibration can enable the proactive preventive measures against the BIGV by providing the safety, data-driven safety approach. So this promotes the environmentally responsible blasting operation, which is the main pillar for sustainable mining practices. So this indicates the need of most advanced techniques, which is here we are working with the CPS, the cyber physical system, which is framework network that integrates the physical sensing, computation and wireless communication and several level analytics to enable the continuous monitoring of blast-induced ground vibrations. So in CPS, we are using the distributed vibration sensor in order to capture the ground motion simultaneously at multiple locations, and then edge data processing unit to determine the PPV value in the real time. So, this physical data can be transmitted wirelessly to the server level analysis, where the real-time data analysis and comparative analysis can be performed. So this integration of cyber physical system monitoring technology helps in assessing the impact of blasting and providing the data-driven safety approach. So the goal is to develop and validate the low-cost CPS for the real-time multi-location monitoring of blast-induced ground vibration. So this study is initial steps to the development of robust physical system for the multi-location monitoring, and it also focuses on establishing the monitoring and embedded computing platform, which is the foundational layer for future CPS enhancement. These are the system architecture and methodology. The system is designed to capture the blast-induced ground vibration and process the data at the edge level and transmit the data wirelessly for the centralized monitoring. As shown in the diagram, the regulated power supply provides the electrical power, stable electrical power by the battery and DC source, and the ground motion is sensed through the triaxial MEMS ADXL accelerometer, which converts the mechanical vibration into electrical acceleration signal along the three orthogonal axes. And this signal is echoed by the embedded processing unit, where data acquisition and analog to digital conversion are performed. And these processed data are then transmitted through the wireless communication modules to the centralized monitoring for the real-time data visualizations and storage. And moreover, peripheral and protection circuits are provided, like indicators and grounding provision are provided for the stable and safer operation under the real field condition. The field deployment of developed system is conducted in one of the operating limestone mine in southern part of India, where the drilling and blasting are routinely employed, And in order to capture the blast-induced ground vibration, 4 stations are installed at the radial distance ranging from 120 meter to 480 meter, and all stations are activated prior to the blasting in order to enable the time synchronous data acquisitions. And triaxial MIM sensor record the acceleration where the embedded processing unit process the data and transmit the data wirelessly. And this wireless capability of this system enable the parallel multi-location monitoring of blast-induced ground vibration, which shows the developed system can transmit the data wirelessly without physical cabling and ensure gives the data for the further vibration analysis. These are the pictures of the field deployment of 4 stations. In the station 1, the developed system is enclosed in the prototype casing using 3D models, and in station 2, 3, and 4, the developed system is put inside the box, and in station 4, the developed system and the industrial geophone system are kept together to determine the PPV value and then compare to do the comparative analysis for the validation purposes. So result here we are getting the triaxial accelerometer sensors can record the real-time acceleration responses, and in this graph we can see that near monitoring station has highest acceleration amplitude, which and compared to other station, and it decreases with the increase in distance, which shows the clear attenuation trend of the vibration energy with distance, and shows the capability of developed system to capture the transit vibration energy under the real field condition. So we are converting this acceleration time domain analysis into the frequency domain analysis to capture the PPV value and compare with the conventional geophone based vibration system. So in that we can observe that the vibration frequency decreases and shift to the left side, and it provides a key insight that the dominant vibration frequency lies to low and mid frequency range, which is associated with the service mine. So similarly, the PPV value, which is key parameter for the blast-induced ground vibration, has been derived from the acceleration data, and the PPV value decreases with the increase in time, which shows the clear attenuation trend of the vibration energy.
Please wrap up.
So last, for the validation, the PPV value obtained from the developed system and the conventional system is compared, and the comparative result shows that there is close agreement between the two systems, which has been performed in 3 trial blasts at varying distances. So finally, rock blasting causes the structural instability. So by inducing the ground motion, vibration motion. So in order to continuously monitor this vibration, we are developing a low-cost cyber physical system for real-time multi-location monitoring system by integrating the ADXL accelerometers on the embedded platform, where the ground motion is sensed to the physical sensors and processed at the edge level and transmit wirelessly for the centralized monitoring. And field deployment has shown that the developed system can reliably monitor the ground motion from the distance ranging from 120 meter to 480 meters, with the PPV value showing clear attenuation trends, and comparative analysis between the two systems shows a close agreement with the error showing between 0.78% to 3.95%, and this system ensures firstly the real-time, wireless, and continuous multi-location monitoring, which provides scalable and cost-effective alternative solution for vibration assessment and regulatory compliance. So, however, these systems, the long-term deployment of the sensor still causes performance degradations and occasional overheating. So this indicates the need of more sophisticated and thermally stable sensors to utilize the capability of CPS. So the future work will focus on improving the sensor durability and long-range wireless protocol for the data transmission. Thank you so much.
Thank you, Mr. Sona. I now request Mr. Anshul Agarwal. He will be presenting on cost-sensitive machine learning for seismic hazard prediction in deep underground coal mines.
Okay, good evening everybody. So this is the last talk of the day. Okay, So just endure me for another 4 to 5 minutes, okay? So I would like to thank Professor Sabnam for already laying the basis of AI and data science, okay? So actually she made my job easier. So I'm sure that within first bell I should be able to basically complete the task. Next slide. Okay, so we know deep undergrounds, okay, stress starts building up. We see that basically energy starts accumulating, so elastic strain energy, which ultimately leads to rock burst, okay. So now we hear a lot of monitoring systems available, a lot of sensors getting laid out, we see a lot of data, but the point we miss is that the hazardous events are very, very rare. So the percentage of such events existing in the entire data set, it's very, very rare, okay. So therefore, building any model out of them, it's a challenging task, okay. So if I basically want to learn the pattern of what a hazard really looks like, okay, it's basically equivalent to like finding a needle in a haystack. So generally people think that we've collected lots of data, people come to me and they say that, please give us a solution. But that's not just the answer. So that is something, I mean, this is a preliminary work that I've just started. This is what I've tried to tackle. Next slide. Okay, so like in the data set that I've considered, it's from Poland, less than 7% of the data actually represents hazardous events. So now the question is, if I, let's say, develop a model which always predicts that the outcome is going to be safe, even such a simple dumb model is going to be statistically around 94% accurate, which means that our standard notion of accuracy is actually not very pragmatic and is not going to solve our problem. So we need to look beyond this. So what we need to do is we need to focus on the hazardous events, okay? So in our case, it's the seismic bumps, okay? And then really say that out of all the hazardous events, how many of those events I could actually detect accurately, okay? So for this, there is a term called as recall in statistics. So in machine learning, we hear about precision, recall, F1 score, but in this particular case, recall is basically the game changer. If I can train my model and penalize so that my recall improves, I can basically get a solution which can develop. Remember, while improving the recall, there is a chance that I might lower my standard accuracy. But that's the point we are saying. That standard accuracy is misleading. It's not going to solve our problem. Okay, so if you talk about this, so there are two cases. In terms of error, either I basically give a false alarm. I say that a hazard is going to occur, but in fact it doesn't occur. Versus scenario 2, where I say that a hazard is not going to occur, it's going to be safe for the next shift, but in fact a hazard actually occurs. So for our case, the previous scenario is basically still acceptable, but the latter is actually very, very dangerous. It can lead to damage of mine pillars, basically impact the safety of workers. And that's why after a lot of basically study, recall is going to help us. Next. So when we say cost sensitive machine learning, so it's like whenever you erroneously classify the outcome, if you say that basically the outcome is safe, but in fact it was hazardous, the way the machine learning model is penalized is way, way higher as compared to the scenario where you say that the outcome is hazardous, but in fact it was safe. So it's like, if you are wrong on one aspect, you are penalized, let's say 5 units, but if you are wrong on the other aspect, you are penalized 1000 units. So this is how, with very scarce presence of data, you train your machine learning model to improve the accuracy for seismic bump prediction. Next. So this is, data set. Again, details can be found, in the paper. Next. Okay. So these are some of the attributes that are actually present with us. So these are, the first two have been categorized as expert assessment of regarding the seismic quality and with respect to seismoacoustic values, okay. And then we see next set of attributes which actually tell us the amount of energy that has been accumulated in the current shift, in the previous shift, and what is the relative increase in the energy. The last is basically the number of pulses that have been recorded in the last shift. So what we say is that there are some micro bumps which are not hazardous, but then they can also serve as an indicator to detect whether a hazardous bump actually occurs in the future. Next slide. So I think we've discussed this. Next. Now these are some statistical techniques that you apply again for scaling, normalization, so that my data actually comes into the trainable format. Next slide. Okay. Now there are many algorithms that exist. Okay. So again, details can be found in the paper, but we see that with this ensemble approach, okay, and when you apply this breed search optimization, you actually get the best set of values, so that you can actually get some kind of starting point. Next. So this is another parameter that I want to talk about, ROC, receiver operator characteristics. This is again a standard term, okay, in statistics. So now what we say is that if generally my ROC is more than 0.6, it is considered as acceptable. So in our case, we actually get 0.77, which means that we can actually go for the real world. Next. As you can see, out of around 34 instances, 19 instances could be correctly predicted, which means that yes, this is a good model, and this is something that previous authors couldn't do. Next. Again, next slide. This last point, out of all the parameters, you can actually see that this relative shift in total energy as compared to the previous shift is the most contributing factor. So if I can just focus on that, I can actually predict the future seismic bumps with a very high amount of accuracy. Next, next. So I just conclude, okay, future work include LSTMs, okay, so that I can actually predict the patterns over the next few and future basically shifts, okay. And the second is inclusion of more recent transformer based models that have proven to be more effective in such cases. Remember, the class imbalance is an issue. That's the biggest challenge that we need to solve. Thank you, everybody.
Thank you very much, Mr. Anshul.
Okay, thank you for your presentations. In general, it was a good session. I enjoy a lot the presentation of the Dr. Kale about India, you know, obviously because I am from Colombia, then I didn't know this information. And you say that India is the number 4 economy right now. In my opinion, in short time will be the number 3, because you have this geological potential and also the people, no, the knowledge. And then I think that in short time you will be, and this is the important goal, even in 5 years maybe to compete with China, I think in the same, because you have also this knowledge. The second one about the Professor Sedben, also about to use AI in underground mining, and it's so important. Amazing presentation, to be honest. I was focused on this presentation, and also because I know about Colorado school mines is very important, using AI, a lot of resources. It's one of the 3 most important school mining in the planet. No, I am aware also in spatial topics. Then AI, I am member of the Society of Mining Professors, and AI is very important in the pensum right now. In the planet, it's very important more and more to use. Even that you were talking about predictive systems, and it's a very important topic, and your knowledge is so amazing. And the other presentations also, unfortunately short time, but it was also integrate a good topic and a good session. Then thank you very much for your presentation, and it was a pleasure for me to share with you this in this chair. Okay, thank you.
Thank you, Dr. Danny. Any remarks from Dr. Raju, sir, please? Yeah, thank you. Thank you very much. So now at the end of the day, I request the session chairman and co-chair to please come on the dais, and also requesting the authors here to come one by one. Please. So Mr. Nitish Kumar, please come on the dais. So request the chairman and co-chair to felicitate and give the certificate of presentation to the author. Now requesting the second author, Mr. Pushpendra Patel, to please come forward. Request the third presenter, Mr. Sonam Drugyal. I'm sorry if I'm not able to pronounce the name correctly. The third presenter, please come forward. Request Aniket Verma to please come to the dais. And Mr. Dr. Anshul Agrawal. I now request Dr. Ritesh Lokhande to please come on dais. Okay, sir. Requesting Dr. Sebnam Dusgun to please come on the dais and request Dr. Lokhande to felicitate her. Our keynote speaker from Colorado School of Mines, USA. Request Ajay Agrawal sir to please come on dais. Dr. YG Kale sir, please come on the dais. Agrawal sir to please felicitate YG Kale sir. He is own alumni. Ajay sir, again requesting you to do honors to felicitate our session chairman, Dr. Danny. Please, Danny sir, please on the dais. Requesting Dr. Prapul Kumar to come on dais and Dr. G.D. Raju. Dr. Raju is not here. Okay. So, on his behalf, can anyone from L&T was here? I think he has gone outside. So on behalf of Dr. Raju, we have Ms. Soumya. Thank you, Dr. Raju sir, thank you. So ladies and gentlemen, we come here to the end of the day 1. Again reiterating, in some time now, we'll all again meeting here for the dinner. And tomorrow session starts 9 a.m. We'll like to, improve upon our timing tomorrow definitely. We'll try to stick to our session timing. So please be here by 9 a.m. and we are again meeting shortly for the dinner. Thank you. Thank you.